Today, the technology is vast, and the demand for Docker software developers and programmers is also very high in the market. Due to this, the future of Docker developers is very bright. Docker is increasing day by day and is counted as one of the most in demand skills in the industry now. Hello, everyone, and welcome to this session. You're currently watching an Edureka Docker Full Course video. By the end of this video, you will have a thorough understanding of Docker from theory to practical applications required to master. Now, if you love watching videos like these, then subscribe to Edureka's YouTube channel and click the bell button to never miss out any updates from us. Also, if you want to learn more about Docker after watching this session and wish to obtain Edureka's Docker certification course, then please see the link in the description below. Now let's begin with our agenda, where we'll have a brief overview of what we will cover in this Docker Full Course video. Well, we'll start with the introduction to Docker, where we will understand what Docker is and why should we learn it. And we will also cover the very basics that you must and should know about Docker. Next, we will learn some Docker commands with examples. Then, we will move ahead and see how Docker works on Windows. Now it's time to delve deep into the technical concepts of Docker. We will start with Dockerfile, after which we will see what Docker Compose is. Next, we will go ahead with understanding Docker Swarm. Once this is done, we will then get introduced to Docker WordPress. Following that, we will look at Docker networking and learn how to Dockerize an application. After that, we will learn about Docker Jenkins pipeline followed by NodeJs Docker. Now once this is done, we will then have a detailed explanation on Kubernetes and Docker. At last, we will compare Docker with other tools. Well, we hope that this session assists you in getting jobs in the industry. In order to accomplish this, we will look at some important Docker interview questions with answers. So stick till the end. Now let's get started with our first topic, that is Introduction to Docker. What is Docker? Well, Docker has a very simple definition. Docker is an open source platform for developing, shipping, and running applications. It enables you to separate your applications from your infrastructure to deliver the software quickly. With Docker, you can manage your infrastructure in the same way you manage your applications. By taking an advantage of Docker's methodology for shipping, testing, and deploying codes quickly, you can significantly reduce the delay between writing code and running it in production. Docker has some amazing features, like Docker has the ability to reduce the size of the development by providing small footprint of the operating system via containers. With containers, it becomes easier for teams across different units such as development, quality analysis, and operations to work seamlessly across the application. You can also deploy Docker containers anywhere, on any physical or virtual machines, and even on cloud. Since Docker containers are pretty lightweight, they are very easily scalable. Because of these features, many organizations have switched to Docker. Now that we have got a brief understanding about Docker, now let us see how to install Docker. So we will be installing Docker in Windows as well as in Ubuntu. And once we install the Docker, we will see how they run in each one of the environments with the Hello World program. So I'll be using the Ubuntu through a virtual machine. So this is your Ubuntu's operating system. Now here we'll be installing the Docker. For this, we will first need to open our terminal. So to install Docker, we will be following the guide to install a Docker. Here I have the official document of Docker where we get to know how to install the Docker engine on Ubuntu. So as you can see here, there are some prerequisites, the OS requirement. The different versions of Ubuntu are available over here. So you should have 64-bit or version of any one of these Ubuntu versions. If you have Docker previously, so you can uninstall your old version and we can set up a new version of Docker. So this is the installation methods. You can follow this guide and install Docker in your Ubuntu or any operating system. So now let's quickly go back to our terminal. So before you install Engine for the first time in your host machine, you need to set up a Docker repository. Afterward, you can then install and update the Docker from that repository. So first, to set up a repository, you need to update the package index and install the packages to use the repository over the HTTPS. So let's get started. So our first command is sudo apt get update. They will ask you your password, so you can give your password. And now here you can see reading all the packages in the operating system. Now once this is done, you need to install the some of the packages. So we will just copy this code and we'll just paste it over here and let's run. So here it will take some time. Now let's hit yes. Now the packages are configuring. Your packages are installed. Now what you need to do is set up the Docker repository. So here, first you need to import the Docker's official JPG key to verify packages signature before installing them with apt-get. For this, we need to copy this command, that is sudo mkdir etc apt keyring. So from here we will get the JPG key, and this is the actual Docker installation link. So from here they will install the Docker repository. We'll just paste it and hit enter. So here we need to run this curl command. So we'll just quickly paste this command and let's see. We'll just give them the access. Now what you need to do is upgrade the index and install the Docker Community Edition. For that, what you need to do is sudo apt get update. All our packages are installed. Now let's install the Docker. For that, we will write the command sudo apt get install docker ce. Hit enter. Let's see. Just hit yes. So it may take a while. They are just unpacking the whole Docker package. Let's wait for a while. Now, in order to check whether our Docker has been installed successfully or no, let's check with checking the Docker version. So for this, we need to just type docker/version and hit enter. So as you can see guys, your Docker has been installed successfully. You can see all the different commands and the functionings of how to use the Docker has been mentioned here. So you can see the different type of commands they have specified here. Now let's run an hello world program and see how Docker works on Ubuntu. So here you just need to type sudo docker run hello world and hit enter. So here what has happened is as he had typed here the sudo docker run hello world. So what Docker has done, it has downloaded the test image of hello world and then it has been passed to the container. It prints a confirmation message. So when the Docker runs, it prints a confirmation message, as you can see over here, hello from Docker. So this is how we install Docker in Ubuntu. Now let's see how to install Docker in Windows. So let's get back to our Windows environment. So here first we need to install the Docker installation package. For that we need to go to our main page of Docker. So let's type Docker installation. So here you get this link for get Docker. So we'll quickly get into this. So once you land on this page, you can see you have Docker installation package for 3 different environments, that is for Mac, Windows and Linux. So based on your requirement, you can choose any of one of your platforms where you would like to install Docker. Currently we're going to install this Docker on the Windows. So let's go choose the Windows version. So as you can see here, this is the installation document or a guide for Docker on Windows. So in Windows, you need to have some of the system requirements like the latest version of Windows, that is Windows 11 or Windows 10, with 21H2 Pro versions, and it can be more than that. Apart from that, you should have the WSL2 feature to be enabled on Windows, so to run the Docker container. Whereas you should have the hardware prerequisites like 64-bit processor, 4 GB system RAM, and BIOS level hardware virtualization support. So these are the system requirements you need while installing the Docker. What we need to do is to first download the installing package of Docker. So you just click over here and then it automatically gets. So once you double click here, you will get your Docker installation package. So it will take a while to download the installation package. So here, as you can see, it is initializing. Here they are verifying the package, and now let's move ahead. Well, this is a very easy step in Windows, like you just need to install the whole Docker package. Alright, so our installation is succeeded. Now let's close it and let's go to our desktop and open our Docker. Now here the Docker asks for the subscription service agreement. Now you just need to accept it. So once you come to this desktop here, this is how the Docker desktops look. So first we need to sign up. I already had an account, so it has been signed in. Now let's see how to sign up as well. For that, what you need to do is go to sign up. Here, first you need to create your account in Docker. So for that, you need to give your username. So you can keep any username, for example, Edureka1. So here you need to add your email ID. So just type down your email and you need to have a strong password. So it is up to you what kind of password are you putting. Now you need to accept the agreement, what they have asked, and then you need to verify. Once you get verified, then you just need to sign up. So here, as you can see, get started with Docker within few easy steps. So we'll just start, and here you can see you can clone your repositories, you can use your GitHub. So here is a tutorial what Docker provides while you start with the Docker. So we'll just quickly skip it up and let's get started. So once you sign up, you need to log in and then you finally get landed to this Docker desktop. It automatically opens. So you can find it over here, all your login credentials and profile. And here you see the containers, image, volumes. So as of now, we have nothing on this Docker desktop. So first we'll open our command prompt. In this command prompt, we will first check the Docker version. So for that, we need to just type Docker version. So here you get the version of the Docker, which is 20.10.21. And now let's run the hello world program like we did it in Ubuntu. So for this, you just need to type Docker run hello world and hit enter. So as you can see, you have got the same output as we had got in Ubuntu. We work on with the containers. This is how containers work on the Docker. Now it's time to delve into the technical concepts of Docker. First is Docker image. A Docker image is a read-only template with instructions for creating a Docker container. Docker images are the key concepts in the world of containerization, and they are important part of Docker ecosystem. They allow the developers to create and distribute software in a standardized containerized format, making it easier to deploy and run applications consistently across the different environments. If we go with the definition, a Docker image is a read only template with instructions for creating a Docker container. Let's make it more simpler. They are built using a series of commands that are stored in a text called Dockerfile. These commands specify the base image to use, any additional packages or libraries that need to be installed, and any other necessary configuration. These Docker images are stored in the Docker registry, such as Docker Hub, we'll be studying in further, which is a public registry that anyone can use to store and distribute Docker images. Well, you can also set up your own private registry to store and manage your own images. Docker Image is also lightweight, standalone, and executable package that includes everything needed to run in a piece of software, including the application code, libraries, dependencies, and runtime. So this was about Docker Image. So now let us understand what is a container. A Docker container is a runnable instance of an image. It is defined by its image as well as any configuration option that you provide to it when you create a container. So, the Docker containers are the way to package and distribute software in a portable and consistent manner so that it can run anywhere regardless of the environment. Containers offer several benefits like isolation. Here, containers allow developers to isolate their application from underlying infrastructure so that applications can run consistently across different environments. Next is portability. Here, containers can be easily be moved between the environments, allowing developers to easily test and deploy their applications in the different environments. Next is resource efficiency. This means that containers allow developers to package only resources that their application needs, resulting in more efficient use of resources. And lastly, they are highly scalable. That means containers can be easily scaled up and down to meet changing demands, making them well suited for use in cloud environments. Now, while we were learning about Docker image, we had used the word Docker file. Well, a Docker file is a text document that contains all the commands a user could call on the command line to assemble an image. It's basically a text file that contains the instruction for building a Docker image. It specifies the base image to use for the build as well as any additional dependencies or libraries that are needed to be included in the image. Dockerfile is basically used to automate the process of building a Docker image so that you don't have to manually install all the required dependencies and libraries. Instead, you can simply specify those dependencies in the Docker file, and the Docker build process will take care of installing all of them. So these are the key components which are used in Docker ecosystem. Now that we have come to know about the key components, let's see how these components work in the Docker architecture. Well, a Docker architecture consists of the following components. First is the Docker engine. Docker engine is the core component of Docker which is responsible for running containers and handling container related tasks. It consists of a domain, a REST API, and a command line interface that allows users to interact with the domain. The Docker engine can run on variety of operating systems including Linux, Windows, and Mac OS. Next is Docker Hub. Docker Hub is a public registry. As I had discussed before, that Docker Hub is a public registry that hosts a large collection of Docker images, which are pre-built packages that contain all necessary components to run an application. Users can search for and pull images from the registry to use a base for their own containers. Next is the Docker client. The Docker client is nothing but the command line interface that allows users to interact with the Docker domain. The client sends requests to the domain through the REST API, which then carries out the requested actions such as building, running, and shipping containers. We all know what are containers. That is nothing but a standalone executable package that contains all the necessary components to run an application. So, to build a Docker image, we can use the CLI, that is nothing but the client, to issue a build command to the Docker domain. Then the domain will then build an image based on our inputs and save it into the registry, which can then either go to the Docker hub or a local repository. If we do not want to create an image, then we can just pull an image from the Docker hub itself, which would have been built by different other users. so that we can issue a run command from the CLI which will create a container. So this is how the Docker architecture works. Now let us move on with our next topic, that is important Docker commands. So here we'll see some of the important and basic Docker commands that are used while you're working with Docker, and we'll see each one of them respectively. So starting with Docker version, basically this command is used to get currently installed version of Docker. So whenever you install Docker and you want to know about its current version, then you can just type down this command to know what is the current version of that particular Docker. Next is Docker pull. So this command is used to pull the images from the Docker repository. So whenever you through Dockerfile create an image, when you run your image, so what does the Docker engine do is pull that image to run that particular image. The next one is Docker run. Here, this command is used to create the container from an image. So as I said, once your image is pulled from the repository, now it gets converted into containers, and then you can run those particular containers. So the main function of the Docker run is to create the containers out of that particular Docker image. So the fourth command is the Docker PS. Here, this command is used to list the running containers. So if you have created more than one containers and you want to see how many containers are running at that moment, then you can just hit this command and you can see how many containers are running. After this, we have the Docker PSA. So here, as in PS, we can only see the list of running containers. And in PS, we can see all the containers which you have created. That includes your running as well as the exited containers. Now, our sixth command is Docker execute. This command is used to access the running containers. Next, we have Docker stop. Here, we use this command to stop a particular running container. So, if any container is running and you wish to stop that container, then you can just use this command. Next is Docker kill. This command kills the container by stopping its execution immediately. So, well, you must be thinking the Docker stop also stops the container, whereas Docker kill also has the similar functions. Well, Docker kill command is slightly different from Docker stop. Let me tell you how. Well, when you use Docker stop, it gives the container time to shut down gracefully. In situations when it is taking too much of time for getting the containers to stop, then you use the Docker kill command. Well, this was the only difference between Docker stop and Docker kill. Next, we have Docker commit. This command creates a new image of an edited container on the local system. And then we have Docker login. Use this command to log into your Docker Hub repository. You can just use this command when you're logging into the Docker. So on your command prompt itself, you can log in using this command. Next, we have Docker push. So this command is used to push the image to the Docker Hub repository. That is nothing but export the image to the repository. Next, we have Docker images. So here, this command lists down all the Docker images, whatever you have created in the Docker. Then comes the Docker RM. Docker RM is basically a command used to remove one or more Docker containers. So when you run this command, Docker stops the container and removes the container's file system from the host. This is useful when you're finished using the containers and want to remove to free up the space on your host. This was the function of Docker RM. Next is the Docker RMI. This command is used to remove one or more Docker images. Don't get confused. Docker RM is used to remove the Docker containers, and Docker RMI is used to remove the Docker images. So here, when you run this command, so Docker removes the images and any untagged parent images that were referenced by the deleted image. So if you have any sub images, like you have a parent image and a child image, so if you delete the child image, then automatically the parent image will get deleted. Here you can also remove multiple image at once by providing a list of IDs. You just need to type Docker RMI and you need to specify all the image IDs which will remove all at once. It is important to note that removing an image can cause problems if image is being used by other containers or if the image is the parent of other images. Be careful while you are using the Docker RMI and make sure that you understand the consequences of removing it. So if you delete a particular image which is relatable to other containers or images, then it will affect to those containers and images. So make sure that before deleting an image, you should be aware of the consequences. Last, we have the Docker build. Here, the Docker build command is used to build image from the Docker file. So here, the basic syntax of Docker build is like you write Docker build and you then specify a path and the URL, where path of the directory containing that particular Docker file and the context, and URL is the URL of the Git repository, which indicates that Docker file should be read from a standard input. So these were the some of the basic and important Docker commands which are used while creating image or working with Docker. These comments, it is very easy for you to work with Docker. Well, this was all about Docker. We got to know about the architecture and we also saw some of the Docker commands. Now let's use these Docker commands and create our own project and see how they run. So now for running our project, we will be using the Linux environment. Let's quickly switch to Ubuntu server. And here we will create a Java project, and through that we will create images and then we'll try to run that Java project. So for that, we will just open our terminal. So as I said, we will be working on the different commands, whatever we had discussed in this slide. So we will work with all the commands over here and we'll see how the Docker works. So let us start with our first command, that was the Docker version. So let's type down Docker -v. This tells you the Docker version. Now let's log into our Docker account. So you just need to type down Docker login and then you need to give your username and password. Like you're not able to log in from the terminal, you will get an option here to log in through this Docker Hub. So they directly give you the link to log in. So you just open link or from the terminal and you can head over, automatically gets open on the your web browser. So here, once you come here, it will, here you can log into your account. So I have already logged into my account. So these are some of the containers which I had created before. From here also you can log in, whereas I also log in from the terminal itself. Now let's quickly go on with our demo. As I said, we will be creating a Java project. So now let's move into our Docker folder which we had created. So let's type down cd docker. So now once you're in the folder, now let's, as we are creating a Java project, so let's create one more folder into it where we will specify it as a Java project, mkdir Java project. Now we'll enter to this folder and we'll then start creating our Java project. Let's quickly get into it. So let's move on to our Java project folder. For this, we need to just type cd project Java project, enter into that folder. Now here we'll be creating our Java project. So we will be using the VS Code itself to create the Java project over there. So let's open our VS Code. You just need to type code space dot and it automatically opens your VS Code. So here we will be creating a Java project and also our Docker file so that we can send the whole file to our Docker. So first let's create a Docker file. So our Docker file has been created. Now before adding the commands or the information in the Docker file, so first we'll create our Java project. So let's quickly open new file, name it as java demo.java and let's open it. We'll start with our classes. Class. So let us name it as class test. Then we will use our main method, that is public static void main. and we'll define the strings dot args. Inside this, we will use this system.out.println code, and inside we will just write welcome to Java. Now let us add some methods to make the project look more interesting. So we will just add public static void print system properties. And now we will print the properties. We'll type this out command, that is system dot out dot print ln, and inside this we'll write the printing properties. You can name it your way, the way you design it. So it's just a simple program just to see how we can run these in Docker. So it's totally on you. Now, as we are using the properties method, so we need to get the properties. So how do we use it? We use the system class, that is system dot get properties. And now we'll specify it properties prop is equal to. We have called the method. Now how do we print it? We'll use the same sort command to print the properties. So system dot println and props. Now we will call this in our main method print system properties. Now let's save it and now let's run the command. Here now our Java project has been created. Now let's quickly run this on the terminal. Let's see how does it run. So we'll just quickly run this. Here, as you can see, enlarge this. You can see here. So what we had printed are welcome to Java project and the printing properties, and they have extracted all the properties of Java, the whole version, whatever properties of Java are there, and they have just printed over here. Our Java project is created and it has run successfully. Now put this whole project into Docker and let's run them through the Docker engine. Now for that we need to first create a Docker file. So let us just name it as docker java.docker file. And now here we need to give all the commands to run the project. So now here we need to first create the image. So we'll first need to give the base image. So let us give them the base image from base image. So here you need to specify what is your base image, that is your the JDK. So here you can also specify the JDK version if you want to, whereas it would be fine if you don't mention also, it will take it automatically. Now it's time to create a work directory where our Docker file will be stored. So let's create a work directory. For that we write work dir, and then now we need to give the path. So here you can see Docker and Java project folder is there. So we will take that path itself here and we will specify it Docker slash Java project and slash my app. Now our next step is to copy the whole file into this directory. So how do we do that is you just need to type copy. So here we'll just put a dot, which means that it will copy all the files from the source, and now we need to provide them the destination, which is Docker Java project. After this we will run few commands through Docker. Now we'll add some commands like run Java C and our Java project name, that is Java test.java. After we use the run command, we need to use one more command, that is entry point, and here we will specify Java And after that, we will also specify our class name, that is test, and then let's save it. Now, once this is done, now we need to run this project through our Docker. So for that, we will go back to our terminal, and here what we will do is first we need to create an image. So for that, we'll type docker build and give the image name as java test image and dot. So it will take some time. Here you can see it has copied all the files and the java project, whatever it has to be taken, and the docker file which had to be extracted, and it has created into an image. So now let us see whether it is listed in our images or no. For that, we will just type docker images, and here you will see the list of images being created in this docker repository. So here, as you can see, we had recently created java test image. After this, we will now run this image that will get converted into a container and then it executes. So for that, we will type docker run and java test image. So here you can see our Java project has been executed successfully. So while we had run previously, so it had shown welcome to Java, then your properties, the printing properties, and here you can see all your properties which are mentioned over here. So this is how you build images through Docker, and then you containerize it and then execute this. Let's run few more commands. So now we had seen the list of images. Now let's see the list of Docker containers. For that, you just type docker ps. So this mentions you the running containers. So currently there are no containers. Now let's see all the containers which have been created. So here you can see there are almost a lot Docker containers, and our Docker container which we had recently created has been also specified here. So now if you want to remove a container, for instance, we can remove this Java image. For that, we will just write docker rm and we will specify the container name, that is Java image. Try to remove Java project. So here you can see your Java project has been removed. If you want to see in the list, so here you won't find your Java project. So here there were 3 Java projects. Now if you wish to remove an image, what you need to do? For that, you need to just type docker rmi, that is remove image, and you specify the image name, that is, let's take any image. Let's run. So here you can see the test image has been removed. Now let's see, check in the list. So here you can see your test image has been removed successfully. This is how you work with Docker.
The commands that you see on your screen here, they are the ones which are most commonly used. So if you are a DevOps engineer, or if you're just someone that's working on Docker, then you might have already used these commands, or you might use them in the near future. Some of those commands are Docker version, Docker help, Docker pull, Docker run, Docker build, Docker login, Docker push, Docker ps. Here ps stands for Docker processes, and this command is used to see what are the active containers currently. And then you have Docker images, then you have Docker stop, Docker kill. There is Docker rm, which of course stands for Docker remove, Docker rmi, which stands for remove images. We have Docker exec, and this is used to access the bash of any active container. And then we have Docker commit, we have Docker import, Docker export, Docker container, Docker compose, Docker swarm, and Docker service. So these are the 20 plus Docker commands which are most commonly used. Now, without wasting much time, let me get started and discuss each of these commands. Docker version. This command is used to find out what is the version of your Docker engine. Okay, so remember, there will be two flags that will come in before writing version. And then we have another command, which is docker, again, two flags, and then help. Now, this is basically used to list down all the possible commands that you can use with Docker. So here, Docker will be your parent command, and whatever child commands that are possible here as permutation combinations, those will be listed down. Now, let me quickly open my terminal and execute these two commands for you. Do remember that I will be using my Linux virtual machine, okay? And this Linux virtual machine of mine is an Ubuntu machine, and it's hosted on my VM, like I said. So I'm just going to open my terminal over here, and the first command that we are supposed to execute is docker version, right? So as you can see, the version of my Docker engine is 17.05. Okay, so that's how this command works. Now the next command that we were supposed to execute is docker help. That of course would also come with two hyphens. And like I told you, there are various commands that you have in Docker, like docker attach, docker build, docker commit, docker cp, docker create, docker diff. So all of these are the other child commands that can be used with Docker, okay, as a primary command. So I hope that was clear. And at any point of time, if you people have any doubt with respect to usage of any command in Docker, then you can just use the help, right? And help will basically tell you the different commands that are there along with a description. So it will also explain what each and every command does. Now, let's say you have docker build, then you can see the explanation that it says build an image from a Docker file, right? So that's a good enough explanation. If I was a guy that's working on Docker, then I would know which option to use, right? Similarly for everything. So for Docker RM, it says remove one or more containers, and then for Docker start, it says start one or more stopped containers, and many more. So whenever in your free time, you can use the docker help command and see what are the different commands possible along with their explanation. Okay, so I am going to clear the screen and go back to my PPT and check what are the next set of commands that I can execute. And remember, these are all still basic Docker commands. Okay, so the next command is docker pull. Now the docker pull command is used to pull any image from the Docker hub. Okay, and then we have docker images command, which of course lists down all the images in your local repository. Now in the previous command, we do a docker pull, right? So for the first time, you will not have any image in your local repository. You will have to pull it from your Docker hub. And when you pull it from your Docker hub, it gets stored in your local repository. And once it is there in your local repository, you can run the docker images command and then check all the different images. So all the images will be listed down. Okay, so that's about these two commands. And then we have docker run command. Now, the docker run command is basically used to execute that image. And I'm pretty sure you are aware that whatever you download from the Docker hub are images, right? And if you want a running instance or if you want it to be active, then you have to run it, because what you will have to deal with, they are containers, right? And to get containers running, then you have to basically run those images. That's the same thing that we are doing here. The command is docker run along with the image name. So supposing I'm pulling an Ubuntu image from Docker, so I will be using this command, docker pull Ubuntu. Okay, and if I want to execute this image and get a running container out of it, then I would have to basically go here and run the command docker run along with that particular image name, docker run Ubuntu. Okay guys, so I think you have a decent understanding of these three commands. Now let me again go back to my terminal and execute these three commands and show you how they work. So I'm back to my terminal here. Okay, so here let me write down the command docker pull Ubuntu. Now by running this command, I am pulling the latest Ubuntu image from my Docker hub. Okay, so when you hit enter, in spite of the fact that I did not specify any tag over here as latest, it's pulling the latest image that is available on the Docker hub. Okay, so let the process happen, guys. Give it a minute. Perfect. So now you can see the status here, right? It says it has downloaded a newer image for Ubuntu, that is with the tag latest. Now if I want to check if this image has actually been pulled, then I can run the command docker images. Now let me run that command by first clearing the screen and then actually running the command docker images. When you hit enter, like I said, you have the entire list of images available in your repository over here. The entire list is down over here, correct? So you have custom image, you have vardhan_ns/custom image, right? So this is another image which I created. If you want to check if your image is latest, then you look at Ubuntu here, right? So this has the tag as latest. And this was an image which was created 10 days ago in my local repository. And it is about 112 MB. Okay. This is the one which we downloaded recently, and it has the latest tag. So this is how you check the different images that you have in your local repository, guys. Okay, so I'm going to clear the screen. And now it's all about executing a Docker image. So for sample purpose, I can even run any kind of an image and get a container, right? So before I execute an Ubuntu image, let me execute a simple hello world container. So for that, I'm going to say Docker run hello world. Now remember, when we say Docker run hello world, you might ask me a question that, is hello world already present in my local repository? Well, the answer is it's actually already present. So I have an image of hello world in my local repository. But even if I do not have the hello world image in my local repository, this command will run, because when you do a Docker run command, this would first of all look for this particular image in your local repository. If the image is not present, then it will go to the Docker hub and look for an image with this particular name, and it will pull that image with the latest tag. Okay, so run does two things: it pulls and it executes. Okay, so let me hit enter, and there you go, it says hello from Docker, right? So this is the hello world container for Docker. Now the reason I did not execute the Ubuntu image is because I want to make a few modifications to that image. But if you want to make a few modifications to that image, then you have a different set of commands which are involved. So let me go through those commands and then get back to what I was supposed to do. That was about Docker run. And then we have something called as Docker build. Okay. And this Docker build command is used to build a custom image of yours. Supposing you have an Ubuntu image, okay, but you do not want it exactly as it is, and you want to make a few adjustments to that. So another example for that would be the node image. Right, in my previous sessions, I've had sessions on Docker Swarm, I had a session on Docker Compose, and many more, right? So over there, what happens is I'm using a Node.js image as my base image, and then I'm building my entire application on that. So what you have here is you have a base node image, okay? And on that node image, you build your entire application, be it an Angular application or be it a mean stack application. And the command that you use to build the entire application is the Docker build command. And as you can see, this is the syntax. You have to say Docker build with the flag -t. And the T flag, what it does is it basically tells you that you can give your name with a tag for your image which you're building, because this image is going to be your image, right? You're customly building this image. So when you custom build this image, you can give it your own name, and that's what this is. And followed by that, with a space, I have specified a dot here. Now the dot specifies that the Docker file which is needed to build this Docker image is present in the current directory where this command is being executed. Now, had I specified the entire path of my Docker file, then I wouldn't be specifying the dot over here, right? But in that case, if I'm specifying the entire path, then that means that my Docker file is present in some other location, not necessarily in the same location where the command is being executed. Okay, I hope that was a little clear to you people. So now if you're still not clear, let me give you a demonstration and then you will be able to understand this in a better fashion. Okay, so let me open my terminal again, and currently we are in the /home/Edureka directory. Now for the demo purpose, I had created a new Docker file. Let me first open and show you that Docker file, okay? And that Docker file is present in the downloads demo folder of mine. If I do an ls, there is a Docker file. Perfect. So let me say cat Docker file. In fact, let me open this in gedit. So sudo gedit Docker file. Yes. Now, the Docker file is the most important file if you want to build your own custom images, because whatever you want for the application to run, those dependencies are specified in this file. You have to say which is the base image that you have to first of all download from the Docker hub and use that as a basis for your application. And then you have to say the other commands that you want to run. Now in this demo of mine, I'm simply downloading an Ubuntu image from the Docker hub, and I'm just echoing this sentence. Hi, this is Vardhan from Edureka. So it's a very simple process, right? I'm pulling one Ubuntu image and I'm doing an echo on that particular image. So you can just save this, close this Docker file, and then execute this particular Dockerfile. Okay, and since I am in this folder, I can use the dot to specify that the Dockerfile is present in this directory. Now let me first clear the screen and then run that command again. So the command is docker tilde -t. Let's give the name of the image as my custom Ubuntu image. Custom Ubuntu. Well, that's good enough, right? And then I'm going to say dot because the Docker file to build this my custom Ubuntu image is present in the same path. Okay, so it says my custom Ubuntu should be in lowercase. Okay, no problem. So let me just check my Docker file once. Okay, now the reason I got this is because my image name cannot be in caps. So what I'm going to do is let me rerun the command with a different name, possibly in small letters. Okay, my custom Ubuntu. Okay, perfect. The command got executed. So if you can see here, it says sending the build context to the Docker daemon. And since I had specified only 2 steps in my Docker file, those 2 steps are being executed here. Step 1 is it's pulling the Ubuntu image from the Docker hub. And since it's already there in my local repository, it's using whatever is there. Okay. And step 2 is running the echo statement. Hi, this is Vardhan from Edureka, right? This was the second step. And the same echo command has been executed over here. Hi, this is Vardhan from Edureka. Correct? Perfect. So I hope you guys got a good understanding of this particular command, because this is the most important command if you want to make it as a DevOps engineer or a person that's regularly working on Docker, because all of the images that you will be working on in your office or in your workspace, you will have to be working on custom images for your application. So remember how this command is used and how the applications are built. So let me just clear the screen and go back to my slides and see what is the next command in store for us. Okay, so the next command is the Docker container command. And this Docker container command is basically used to manage your containers. Now let's say you have n number of containers, and because so many containers are active at the same time, your system may be lagging, right? There's a performance issue. So at that time, you might want to close or end certain containers, right? Kill their process. So at that point of time, you can use the container command and kill the container straight away. So it's just one of the different options that we have. So there are a number of other commands which can be used with the Docker container as the parent command. And I would request you to look up the set of commands on Docker docs. Okay. But for now, let me just go back to my terminal and execute one of these commands and show you how they work. So let me go back to my terminal here. And here, I'm going to run that command, Docker container. And let me run Docker container logs. Okay. But so here, let me run the command Docker container logs to basically find out the different logs that are associated with my container. Okay. Now the thing is, in arguments, I have to specify the container name or the container ID. And since I don't know it right now, let me first find out what is my container ID. Okay. So I'm going to do a docker ps command to list down the different containers. Okay. There are no active containers. So I'm going to do a -a flag. So these 2 commands I will explain in detail at a later point of time, guys. Okay. But anyways, getting back to our problem here, you can see that the hello world container got executed, right? So I'm going to copy the container ID here. And now I'm going to find out what are the logs of this Docker container logs. And then I'm going to paste the container ID. This way, whatever logs were generated for this container, those would be displayed. Perfect. Worked as though the container executed again. So the same thing can be done for any of the other containers. Okay. If I do a docker ps -a and see there are so many other containers which are there right in my system, I can copy the container ID of any of these and I can execute the same thing again and again. Docker container logs, right? And then I can paste this. So this time the logs of this particular container, which is 916 and this entire ID, this logs have come out. And like I said, with Docker container, you have various other options, correct? You have options like Docker container kill, you have Docker container remove and all those things. So I can use a Docker container remove and hit enter. And basically when I do that, this particular container is off. So if you remember this ECC, right? This container is the hello world container. And when I said RM, this container is removed. So if I go back and do docker ps -a, then the first entry for the hello world container would not be present. And yes, as you can see, it's not present, right? The hello world container is not present here. Now that's what I want to show you. So I've cleared my screen, and now let me get back to my slides. So I basically executed the docker container logs command and the docker container rm command. So you have various other options. Like I said, you have the container kill, which can be used if you want to kill any one particular container. Okay, you can use the docker container run command to start any container which has been temporarily stopped or which is inactive. Okay, and if you want to again start the container from something that has been stopped, you can use the docker container start command. And these are just a few of the commands, and the entire list of docker container commands can be found in docker docs. Okay, so I would request you to go to docker docs and then see the entire list of commands if you want to learn more about this command. In the meanwhile, let me go to the next slide and continue with our session. The next command that we're going to talk about is the docker login command. Okay, and as simple as it sounds, this is used to log into your Docker Hub account. Can any of you guess why we would need to log in? Well, it's for the simple reason that you might want to push any of your image that you have created locally, right? So when you're working with a team who are all using Docker, then you can just pull the Docker image or create a new Docker image from scratch at your end and build a container. And if you want to share that container with other people in your team, then you can upload it to Docker Hub, right? So how do you upload it to Docker Hub? So if you want to upload it, you don't have any other workaround. So you do it through the terminal. And to do it through the terminal, you have to first do a Docker login. Once you've logged in using your Docker container credentials, then you can simply start pushing your Docker image to the Docker Hub. Okay, so that's why this command is really important. So let me go to my terminal and show you this command. The command is docker login. When I hit enter, it says login with your Docker ID to push all images from Docker Hub. If you don't have a Docker ID, it says head over to this website. So this is where you can create a new Docker ID. Okay, and the username, it says in brackets, it says VardhanNS. That's my username because I'm already logged in. So I'm just going to hit enter without entering the username again. And the password I can enter is my password. So that, of course, I'm not going to reveal to you people. But once you enter the password and hit enter, then it says login succeeded, right? If your credentials are a match, then you are successfully logged in. And once you're logged in, you can start pushing your Docker images, which you worked on locally, to your Docker Hub. Okay, perfect, right? So let's clear the screen and get back to our slides. Now, like I said, the next command is basically to push your Docker image to your Docker Hub. Remember, the command should have your Docker ID / the image name. Okay, my Ubuntu image, this may be the name of the image that you might have created locally. Okay, but if you want to push it to the Docker Hub, you have to tag it with a name, and that name should be your Docker ID. Okay, so let me get to the terminal and show you how this command works. So let me first look for the image that I want to upload to my Docker Hub. Okay, so when I hit Docker images, the list of all the images come out. And if you remember, my custom Ubuntu is the name of the image which I created. Now let me try pushing this image to the Docker Hub. Okay, so I'm going to copy this and first clearing the screen. And here I need to tag this image with my Docker ID, right? Because right now it has the name my custom Ubuntu and I cannot upload it to Docker Hub with this name. Now, since I have to tag it with my name, there's a command called docker tag, and here you have to specify what is which image that you want to tag. So the image is my custom Ubuntu, and here let me specify my Docker ID / the image name. So I'm going to say VardhanNS. Okay, now that's my Docker ID and / my custom Ubuntu image, right? So this is the name of my image. I can even change the name, but I've just retained my custom Ubuntu as the name of my image. So when I hit enter, this image would be getting uploaded to Docker Hub. And now this image has been renamed to VardhanNS / my custom Ubuntu. We can verify the same by running the command docker images. And as you can see here, there is one image with the name my custom Ubuntu, and then there is another image with VardhanNS / my custom Ubuntu. Correct? Now this is what I have to upload. So now I can use the docker push command. So I'm going to say docker push and then simply specify the image that you want to push. Docker push /my custom Ubuntu. Hit enter and the image would be getting uploaded to Docker Hub. And once when you do it from your end, after this command is executed successfully, you can go to your Docker Hub and check that your image which you created locally has been uploaded to the Docker Hub and it can be shared and accessed by other people. Okay, perfect. So this shows that my image has been uploaded. And let me just clear the screen and get back my slides and move forward. And this command is something that I already executed some time back, right? If you remember, I used the docker ps command to identify which are the containers which are currently active in my system, right? In my Docker engine. So that's what this does. PS basically stands for processes. And when you hit Docker processes, then all the container processes which are currently running in your Docker engine would be listed. However, if you append this command with a yay flag, right? Then all the containers which are inactive, even those containers would be listed down. So that is the difference between these two commands, docker ps and docker ps with a flag A. Now let me go to my terminal and show you that. So docker ps first, okay? And right now there are no entries because there are no containers which are currently active. But if you want to find out all the containers, irrespective of whether they are active or whether they are not active, then it would list down all the containers in my system, right? Or in my host. And that's what it's going to do. Docker ps -a. And as you can see, there's an entire list of Docker containers over here. There's the custom image which I created. And then there are various other images over here which I used to build a container. And I've shown you how they work in my previous sessions. So the contact list, Angular, and then there is a demo app one. These were images which I used for my Docker Swarm and for my Docker Compose videos respectively. So if you want to go and see those videos, then the link will be there in the description below, guys. And I would request you to go through those images to understand other Docker concepts better. Okay, because Docker Compose and Docker Swarm, they are the advanced concepts in Docker, and that's a must know if you want to make it as a Docker professional. The link for those videos are in the description below. So let me just clear the screen and get back to what I was doing. So the next command that we have is the docker stop command. Now the docker stop command is basically used to shut down any container. So if there is any container in your Docker engine which is running, right, in your host, and if you want to stop it, then you can use this command. And do note that this command would not be shut down right away. It might take a few seconds because it would be gracefully shut down, waiting for the other dependencies to shut first. Okay, it's not a forced stop. It's a very gentle stop. That's what this command is. But we have something called as a docker kill command. Okay, and what this docker kill command does is it ungracefully stops your container. As in, if there is any container that is actively running, it would straight away kill it. In spite of it's something similar to force kill, right? So that is the difference between these two commands, docker stop and docker kill. Kill would straight away kill your command. Now, before I show a hands-on of this, let me go forward and talk about a few more commands. There is something called as a docker remove, right? Docker rm. This one, what it does is it removes a container. At this point of time, you have to remember that if you want to remove any container from your host, you have to first stop it. And how will you stop it? By the two commands that I explained in the previous two slides. You either force kill it or you kill it gracefully using the docker stop command or the docker kill command. And once you've used those two commands, you can remove them from your repository. Okay. And we have another command that is the docker rmi. Okay. So the docker rm would remove containers. But if you want to remove images itself from your repository, then you can use the docker rmi command. Okay, guys. So these are the four different commands that we have here, which are regularly used. Now let me open my terminal and show you how they work. First, let me do a docker ps. And since there are no containers which are currently active, what I'm going to do is I'm going to start a service. Okay, I'm going to containerize a particular service, and then I will show you how to stop it or kill it or remove it. Okay, there is one particular image demo app one, okay, which I used to deliver my previous session. There was the Docker Compose session, right? Over there I used that particular image and I created an Angular application. So I'm going to first start that service, and the command for that is docker run -rm. I'm going to say port number is 4200:4200 because it's an Angular application. Let's give it a name. It's hyphen name, right? So let's give it a name, my Angular application, or let's give it a name, my demo application. Okay, and demo app 1 is the name of that image. So when you hit enter, first the image would come up, right? The image would be spun and the container would come up. Let's just wait for the container to become active. So let me first open a new tab of this terminal. Okay, and here let me run the command docker ps, and you can see that 42 seconds ago this app was created, right? The demo app 1. Here it says the webpack is compiled successfully. So if I go to my Firefox, the servers would be active, the Angular application would be active. Okay, but if I want to temporarily stop this container, or if I want to kill this, then I can use those commands docker stop, or I can use docker kill. Okay, so let's use those commands and see how they work. I'm going to say docker stop followed by the container ID, correct? Hit enter. So the Docker servers are stopped. Now if I do a docker ps command, this container would not be active. Okay, and over here also you can see that which was temporarily compiled, it has ended, right? Even the service is not hosted anymore. So that's how the docker stop command works. So let me go to this command and restart the same service. And over here, this time instead of using the docker stop command, let me say docker kill. Okay, sorry, I've just used the same container ID, right? So I need to do a docker ps first. Okay, and yeah, now this is the container ID which I have to kill. So I'm going to say docker kill, pasting this container ID and hit enter. And that container has also ended. So even the service has exited from here, right? So that's how you kill a container. That's the difference between the stop command and the kill command. Okay, so I'm just going to clear the screen. And after these two commands, there are two commands like docker rm and docker rmi, right? They are used to remove containers and images respectively. So let me go ahead and do that. First, let's run the command docker rm. Okay, and now you have to specify which container you want to kill or remove. So for that purpose, let me first find out which are the different docker containers that are there in my system. So when I do a docker ps-a, there are a number of containers, and from here let me remove this test angular container. Okay, this is the name of the image and this is the container ID. So I'm going to copy this container ID and go back here. Let me clear it, and here let me run the docker rm with the container ID. And when this is returned, it means that my container has been deleted successfully. And the benefit with this is I have freed up a little more space in my host, right, in my Docker engine. Now guys, similarly, we saw how to remove a container. Okay, now let me go here. Let me do a Docker images. So these are the list of the different images that are there in my repository. And if I want to remove any of these images, then I can do Docker RMI. And what we have here is we have a Redis image and we have an Alpine image, which I do not need. So let me copy this Redis image and remove this image from my repository. So the command is docker rmi this time, because remove image is what it stands for. And I can specify the image name, or I can even specify the image ID. So image name is good enough. So that's what's happening, right? It says untagged and deleted. Perfect. Now I can clear the screen, and what I wanted to show you, I've showed you already. Now if I run the docker images command again, then Redis would not be visible here. So you can see Alpine, but you can't see Redis, correct? So that's how it works. So let me go back to my slides and go to the next command. We spoke about stop, we spoke about kill, we spoke about docker rm, and we also spoke about docker rmi. Now the next command that is in question is the docker exec command. Okay, and this command is used to access any active container, right? Any container that is actively running. If you want to access the bash of that particular container, then you can use this exec command. Okay, and we use IT flag over here. So you can either use -it together, or you can use -i space -t. Now what I does is it's basically, it says access your container in interactive mode. So that's the option this flag specifies, and that's why we're able to access the container. Okay, and you have to specify which container you want to access, followed by the word bash. So let me go back to my terminal and show you how that works. So over here, let me clear the screen and do a docker ps. and check which containers are actively running. None of them are running right now. So let me start a container over here. Okay, let me do a Docker. In fact, I can start one of the containers I started sometime back. The demo app one, right? The one I spoke about is the Angular application. Let me start this same container. Let's wait for it to come up. Perfect. Now it says Webpack compiled successfully. So now let me go to my browser and hit localhost 4200 because my Angular application is active on port number 4200. Right. So this is that Angular application which I was talking about. So if I go back to my terminal, you can also see that I have specified 4200 as the port which is to be used to access that application on my host. And this is the port number it's running on internally in my container. So I'm mapping my container port to my host port. And because of this, I could access that Angular application on my web browser. Now, getting back to our slides, we were supposed to use the docker exec command to access this container, right? So right now I cannot access this container over here. So let me access this container in a new terminal. So this is the new terminal. And here, if I do the same docker ps command, the new container is active. So from here, let me copy the container ID and then run the command docker exec with the flag IT, followed by the container ID and then bash. Bingo. So right now I am inside this container. So all this time, this was the user, right? Edureka@ubuntu. This was my host machine and this was my username. Right now, I'm logged in as a root user inside the container with the having the ID this one, because this is what I specified over here. So now we are not in my local system, we are inside the container. And what can we find inside the container? We would basically find dependencies, libraries, and the actual application code of this particular Angular application which is hosted over here, right? Which you can see all the project codes would be present inside this container, correct? So let's verify if that is the case by checking if we are actually there. And by doing an ls, you can see all the different files here. We have a Docker file which was used to build this application, and then we have a package.json file which is the most important file to build any Angular application or any mean stack application. And then we have protractor.conf.js which is used to test any Angular applications. And then we have so many others, right? We have an src folder, we have an e2e folder, and then we have node_module. So this is where all your project dependencies are stored, correct? So package.json specifies what are the project dependencies that you want, and this is where it's all stored. So this is my Angular application, right? So if I go one directory back, I am in this src folder now. Okay, let me do an ls. I have app here. Let me go one path back again and do an ls. And here you can see that I have other folders like bin, games, include, lib, local, sbin, share, and src. Now all these are inside my container. I hope this was enough evidence for you. I hope it was. So I'm back here, and yeah, that's how you access your container. If you want to make changes, you can make changes here. Okay, and since we are inside the container, let's just create a new file. So let's just say touch f1. So the touch command is used to create an empty file, right? So now if I do cat f1, of course there is nothing, but let me do a sudo gedit. Okay, so I don't need to give a sudo because I'm already logged in as root user. So I'm just going to do gedit f1. Okay, so it's not letting me access this command, right? Okay guys, anyways, that's how you access the container. Okay, so let me just clear the screen. And if you want to exit the container, exit the bash, then you should use the command exit. So when you hit exit, you're back as the Edureka user on your Ubuntu host system. Interesting, right? So I'm going to clear the screen and go back to my slides and check what's next. And then we have the docker commit command. And what this docker commit command does is that it basically creates a new image of an edited container on the local repository. In simple words, it creates a new image of any container which you have edited, correct? So let's execute this docker commit command and see how that works. Let me go to my terminal here. Let's first run the docker ps command and check this is the container ID. I accessed my Docker container, so I hope some changes would have been there. So let's create a new image of that particular Docker container. Okay, so I'm going to say copy and run the command docker commit, and then specify the container ID of your container, and followed by that you have to specify the name of your new image. So I can say vardhan_ns/my image, right? My Angular image. So this would basically create an image of this container which is running. And bingo, perfect, it's done. So if I run the command docker images, then there will be a new image with this name and tag. Let's verify that by going to docker images. Let's go up, and as you can see, there is vardhan_ns/my Angular image. Perfect. This is what we wanted to verify. Correct. So let me clear the screen and go back here. And yes, the webpack is compiled successfully. This was the message we got earlier. So anyways, let's not worry about that. That's what a Docker command does. So if I want to stop this container service, then from the new terminal, let me just kill that container service. Correct. So this is the ID. I'm going to copy this, and then I'm going to say Docker container stop, and my container would have stopped. So here, yes, my service has stopped over here. Bingo. So I'm going to clear the screen in both the places. Okay, now let me get back to my slides. So the next command that we're going to talk about is the Docker export command. Correct. So the Docker export command is basically used to export any Docker image in your system into a tar file. Correct. So this tar file is going to be saved in your local file system, and it's not going to be inside Docker anymore. This is another way of sharing your Docker images, right? So one way was by uploading it to Docker Hub. But in case you don't want to do that, you don't want to upload it to Docker Hub because the image is very heavy. So in that case, this is an alternative which is used in the industry, where we do a Docker export from one machine and we save that image as a tar file. And this tar file is imported inside the destination system, and over there it can be accessed again and the container can be run. So let me show you an example of that by first of all getting to it. Okay, so it says Docker export, right? So this is the syntax for that. Okay, you say Docker export. You use the output flag with 2 hyphens. You can specify the name of the tar file that you want to store it with, and then you have to specify your image name over here. Okay, so the image name over here is my container. So you'll have to specify your image name. So let me go to my virtual machine, and what are the Docker images that I have available? There is vardhan_ns/my Angular image. There is my custom Ubuntu. So what I'll do is, let me save this my custom Ubuntu image. Okay, this is my image and the image ID is this, right? So I'm going to copy this, go back to this terminal, and what I'll do here is I'll say Docker export double hyphen, which is the flag. I'm going to say output flag is equal to, I have to specify the name of my tar file, right? So my Docker tar file, I can say that my Docker tar file, and here I have to specify the container name. So Docker images wouldn't do for that, so I'm going to do a Docker ps-a. So I have a custom image here, right? So let me save this particular image. So I'm going to copy the container ID, copy this, and paste it over here, which indicates that I will create a tar file of this particular container, and this tar file would be saved in this repository itself, Edureka_Ubuntu. Now, since it's a heavy container, it's going to take a few seconds, and it's done. And we can verify that by doing an ls. The name we gave was my Docker tar file, correct? And then you can see there's a my Docker tar file, which is basically a TGZ file. So if you go back to your documents, you can see that there's a new tar file, my Docker tar file, that was created, and you can verify the same my Docker tar file over here. This is the newly created tar file. So I can go back to my slides here, and let me just clear the screen. Okay, perfect. So going back to my slides, I've shown you how the Docker export command works and what's the benefit. Now in the next slide, we have the Docker import command. Now the Docker import command is basically used to import any tar file. If you have any tar file which has been given to you by your fellow developer, and if you want to create a container out of that one, then you have to import it, right? So how is that possible? So this is the syntax for that. The command is docker import and then the complete path of that demo file, of that tar file. Okay, so for this particular purpose, I have already created one tar file because I wanted to create one which can be imported very soon. So I created a tar file over here, demo tar. So it is present inside my downloads folder, correct? So let me import that file. So I'm going to say docker import, and then I have to specify the complete path. So it's /home /edureka /downloads /demotar. Let's hit enter, and this particular image has been successfully imported. You can verify that by seeing the first few characters of the newly created image. Okay, so let's run the command docker images over here, and you can see that just recently 23 seconds ago a new image was created, right, with the same image ID 23EF, and it is the same image ID over here, right? It starts with the same sequence characters, and right now it has no name. So that is how you easily import Docker images. Okay, you first export it and then you can import it. So let me just clear the screens of both the tabs. And now getting back to my slides, I'm done with my Docker import command. And now comes the advanced Docker commands. Okay, so up till here we saw the Docker commands, which are very basic and which can be executed easily. But here comes the challenging part: Docker Compose and Docker Swarm. Right, these are all advanced concepts in Docker, which solves a lot of business problems. And of course, the commands are also a little advanced in nature. So first, let's start with Docker Compose. There are two variations to it, and the two syntax can be seen over here: docker-compose build and docker-compose up. So these are the two commands which work very similar to Docker build and Docker run, right? So Docker build is basically used to build a new image from a Docker file, correct? Similarly, a Docker Compose build is used to build your Docker Compose by using your Docker YAML file. Now your YAML file stands for yet another markup language, and now in the YAML file we can specify which all containers we want to be active. Okay, and you have to specify the path of the different Docker files which will be used to create those containers or those services. And that's what Docker Compose does, right? It creates multiple services, and it's basically used to manage all those services and start them at one go. So it would use more than one Docker file. Probably if you go through my previous video on Docker Compose, I have explained it in detail over there. I have used 3 different Docker files, and using those 3 Docker files, I have created 3 services, right? And the 3 different services are the Angular service, the Express and Node service, and the MongoDB service. The MongoDB was used as a database, the Express and Node was used as my backend server, and Angular was used for my front end. Okay, now the link to this video is present in the description below. Okay, but let me just quickly wrap this up by saying that if you want to build that, you use the Docker Compose build, and if you want to start your Docker Compose and start the container service, then you can use the Docker Compose up. This is very similar to the Docker run command. Okay, and that's what your Docker Compose does, right? It creates multiple Docker services and containerizes each of them and gets the different containers to work together. So perfect. Let me go back to my terminal and let me do that for you. So Docker PS, there is nothing. So right now we are in the home/Edureka folder, correct? So let me do ls, and there is a folder called mean stack app. So I'm going to cd into this particular folder, and here if I do an ls, you can see that there's a Docker Compose.yaml file. So let me do a gedit Docker Compose.yaml file. So over here you can see that I have specified the commands to create 3 different services. One is the Angular service, other is the Express service, and finally my database service. Okay, I have explained all these things in my previous video. I repeat, the link for that video would be in the description below. Okay, so let me quickly execute this YAML file. Okay, so if I do a Docker Compose build, then this command would look for this Docker Compose file inside this directory. Okay, and then it would once this image is built, I can straight away execute that command by using the Docker Compose up. Okay, so I'm just gonna replace build with up. This way my Docker Compose would also be up and running. Earlier I showed you an Angular application, and this time it's going to be an entire mean stack application, which is going to involve everything: MongoDB, Express, Angular, and NodeJs. So my Express is up and running, my Angular is up and running, my MongoDB is active on port number 27017, my Express would be active on port number 3000, and Angular, as usual, would be active on port number 4200. So let's verify the same by going over here. Okay, it also says Webpack compiled successfully. So this time if I refresh this, there's a different application that would come up. Correct. So this is my main stack application. On port number 4200 is the front end. On port number 3000, this is my server end, which simply says foobar. And then on port number 017, there is my MongoDB. Right. So these are the three different services which are active on my various port numbers. So going back to my terminal, I can do a Docker PS to verify that there are three different services of mine which are running. Now, if I want to stop each of these services, I can simply do a Control C from here, and hopefully it stops. Yes, all three services have stopped. Let me execute the same command, and this time, yeah, they're all gone, right? So the Docker PS command shows no containers active. Bingo. So I'm going to clear the screen out. Okay, and go back to my slides and go to the next command. And the next advanced command that we have is the Docker Swarm command. Docker Compose, I told you, was to basically have a multi-container application, right? And Docker Swarm is, however, used to manage multiple Docker engines on various hosts, right? So usually you might be aware that your Docker engine is hosted on one particular host and you're executing your Docker commands over there, right? That's what we were doing all this time. Even Docker Compose did that. On the same host, three different services were started. But with Docker Swarm, the benefit is that we can start those services in multiple machines. So you will have a master machine, which is nothing but the Docker manager, as visible from here. And then you will have different slaves, or which are called as worker in Docker terms. So you have a manager and worker. And whatever service you start at the manager will be executed across all the machines which are there in that Docker Swarm cluster. Okay. So it says, right, it creates a network of Docker engines or hosts to execute the containers in parallel. And the biggest benefit of Docker Swarm is scaling up and ensuring high availability. Okay, so some of the commands which are associated with Docker Swarm are these. If you want to first of all start off creating a Docker Swarm, then you use this command, Docker Swarm init, and you say advertise. Okay, and then you have 192.168.1.100. It's supposed to be two hyphens over here. Okay, yeah, so this is how the syntax is supposed to be. Docker Swarm init hyphen hyphen advertise hyphen adder, and then you have to specify the IP address of your manager machine. So if I start the swarm from this particular host of mine, then this would assume the role of my manager. Okay, and in this syntax, remember, I have to specify my own IP address so that the other workers who will be joining my network would subscribe to my IP address over here. So let's quickly go and execute this first command, and let me show that to you. Okay, so let me open up the terminal, and the command is Docker Swarm init, which stands for initialize, with the flags advertise, adder, and then the IP address. So the IP address of my VM is 192.168.1.100. Okay, so when I hit enter, see what happens. It says swarm is initialized, and this is the current mode. This particular node is now a manager. Okay, and if you want other machines to join this particular manager as workers, then they have to use this token. So you have to just copy this, go to the other machines and execute it. Supposing this is another machine of mine. Okay, I'm giving you an example. So over here, you would have to paste that token. Okay, so this is called the token. You just hit enter and then you will join as a worker. Okay, so that's how the Docker Swarm command works. Now I cannot go into too much details with respect to how Docker Swarm works. Okay, because there again, it will take a lot of time. And if you want to actually learn Docker Swarm, you can go and watch the other video which I delivered a couple of months back. Right, that video is called Docker Swarm for high availability. Okay, and that is a detailed video, and you will enjoy that video because with that video I've shown how Docker Swarm can be used, and you will see the power of Docker in that particular video. So I would request you to go there, and the link for it is again below in the description. Okay, so I would request you to go there if you want to learn more about Docker Swarm. But getting back to our slides, we have other commands here, right? So the Docker Swarm join is what I already explained to you. So followed by this, you will have a token. So if you give that, you can join a particular Swarm cluster as a worker. Okay, so if you want to regenerate that particular token which is needed to join that particular cluster, then at the manager's end, you can execute this command, docker swarm join token. So it would generate that token and give it to you. And similarly, if you want to leave the Docker Swarm cluster, then you can execute this command, Docker Swarm leave. Okay, so if you execute this command straight away at the worker's end or the nodes, then it would simply leave. Okay, but at the manager's end, it would not leave just like that. You would have to append the flag force. So let me show you that. Let me just execute the command, Docker Swarm leave. If it was a worker, it would leave right away. But since it's a manager, like I said, it says use the force option. So let's use that. Okay, Docker Swarm leave with double flag force. And it says the node has left the swarm. Perfect, right? So this is all about Docker Swarm, guys. Okay, so let me go back to my slides and cover the one last command that is there for today. And that command is the Docker service command. So this command is used to control any existing Docker service, be it any container or be it a Docker Compose or Docker Swarm or anything else, right? So Docker service is a very underutilized command, I would say, because if you want to control your different nodes when you're in a Docker Swarm, then you use the Docker service. You use the Docker service command to list down the different nodes that are there in your cluster. You use the Docker service PS command to find out what containers are being executed in a particular node. And then if you want to scale the number of containers, supposing you have a cluster of 5 machines and then you have 5 containers running in each of those machines. If you want to scale those containers to 25, that means you will be executing 5 containers on each machine, right? So for that, you have to use the command Docker service scale. If you want to stop any container on any particular node, then you use the command Docker service stop. And then if you want to find out the different logs, then you use the command Docker service logs, Docker service rm, and so on, right? So the Docker service command is, let me repeat, it's used in sync with your Docker Swarm and Docker Compose primarily. So that's why these form the advanced Docker commands. So let me go to my terminal and quickly show you a glimpse of this. So it's Docker service. If we do an ls, you will not have any options listed because it says this is not a swarm manager currently. But if I start my Docker swarm and then if I run the same command, Docker service ls, then you can see that the output is different, right? I have a few attributes here, ID, name, mode, which is basically details about the different worker nodes in my cluster. But since no worker has joined my cluster, there are no entries here. So that's how it is. So let me just end that. So that is the Docker service ls. If you want to find out the logs, then you can do that too. Docker service logs. So if you use the Docker service log, you have to specify which service you want to check the logs of and what is the task, right? So which task and which service. So it's that simple, guys. So that's how Docker service is used. Okay, guys. And again, if you want to stop any service, if you want to remove any service, you can use these commands: Docker service stop or Docker service remove.
So why should we use Docker for Windows? Now the first reason is that it avoids the work on my machine but doesn't work on the production problem. Alright. Now this problem occurs due to the inconsistent environment throughout the software development workflow. Now for example, let's say that a developer has built an application on Windows environment and when he sends the application to the testing server, it fails to run. Now this happens because the testing server operates on an outdated version of Windows. Now obviously the application does not support the dependencies needed to run on the outdated version of Windows. So because of the difference in the software versions in the development and testing server, the application will fail. But when it comes to Docker, we can run our application within a container which contains all the dependencies of the application, and the container can be run throughout the software development cycle. Now this practice provides a consistent environment throughout. Now apart from that, it improves productivity. So by installing Docker on Windows, we're running Docker natively. If you've been following Docker for a while, you know that Docker containers originally supported only Linux operating systems. But later Docker made its platform available for other operating systems, but with a simple limitation. Now the limitation was that Docker engine ran inside a Linux-based virtual machine image on top of the operating system. So basically you could run Docker from Windows or any other operating system, except Linux was still the middleman. But thanks to the recent release, Docker can now natively run on Windows, which means that Linux support is not needed. Instead, the Docker container will run on Windows kernel itself. Alright. So guys, just like I mentioned earlier, Docker for Windows supports native networking. Now, not only the Docker container, the entire Docker toolset is now compatible with Windows. This includes the Docker CLI, Docker Compose, data volumes, and all of the other building blocks for Dockerized infrastructure, which are now compatible with Windows. But how is this advantageous? Now, since all the Docker components are locally compatible with Windows, they can run with minimal computational overhead. Now let's move on to the prerequisites. So before you install Docker for Windows, you need to check if you're running on a Windows 10, Pro Edition, Enterprise Education, Student Edition, 64-bit system. Now guys, a point to note here is that Docker will not run on any other Windows version. So if you're running on an older Windows version, you can install the Docker toolbox instead. Okay. Now Docker for Windows requires a type 1 hypervisor, and in the case of Windows, it's called the Hyper-V. Now, what is Hyper-V? Hyper-V is basically a lightweight virtualization solution built on top of the hypervisor framework. So you don't need a virtual box, you just have to enable hypervisor. Alright? And also you need to enable the virtualization in BIOS. Now, when you install Docker for Windows, by default, all of this is enabled. But in case you're facing any issue during installation, please check if your Hyper-V and your virtualization is enabled. Alright? Moving on. So guys, when you install Docker, these components are also installed automatically. So first we have the Docker engine. Now guys, whenever we say Docker, we actually mean Docker engine. Now the Docker engine basically contains the Docker daemon, REST API for interacting with the Docker daemon, and a command line interface client that communicates with the daemon. Now Docker daemon accepts Docker commands such as Docker run, Docker build, and all of that from the Docker client. Alright. Now the next component is Docker Compose. Docker Compose is basically used to run multiple Docker containers at once. Now we'll be discussing more about this in the further slides. After that, we have the Docker machine. Now Docker machine is used to install the Docker engine. It is basically what you install on your local system. Okay. Docker machine has its own client known as a Docker machine and a Docker engine client known as Docker. Alright. Now at last we have Kitematic. Now, what is Kitematic? Kitematic is an open source project built to simplify the use of Docker on Windows. It basically helps to automate the installation of Docker, and it also provides a very interactive user interface for running Docker containers. Alright, so it's more like a UI tool. Now let's look at the Docker registry. Now Docker has its own registry known as Docker Hub. Now Docker Hub is basically where you store all your Docker images. Now these images can be pulled from the remote server and then they can be run locally on your system. In fact, you can also push the Docker images that you have created onto Docker Hub and you can share it with other users on Docker Hub. So in short, Docker Hub is basically the storage house for all your Docker images. Now let's move on to the demo. So we're going to begin with installing Docker for Windows. Now before we go ahead, guys, you have to make sure that you're using a Windows 10 Pro, Enterprise, Education, or Student Edition. One more important point to note here is that if you're using a virtual box on your system, you won't be able to run it because a virtual box will not work with the hypervisor enabled. But in order for your Docker for Windows to work on your system, the hypervisor must be enabled. So guys, basically you cannot run Docker for Windows and a virtual box on the same system side by side. Okay, so if you have a virtual box in your system, it's not going to work because you'll be enabling your hypervisor. So let's get started by installing Docker for Windows. Now, in order to install Docker for Windows, you need the Docker for Windows installer. Now, I'll leave a link in the description box so that you can download the installer. So guys, I've already installed the Docker for Windows installer. Y'all can go ahead and download it from the link in the description. Now here you can see that I've run the installer. So now let's just wait for the installation to complete. Okay, now let's just click on OK. Alright, so it's unpacking files. Alright, so the installation is completed. So guys, once you've installed it, just open the Docker for Windows app. Alright, it's here on my desktop. So when you try to start the application, you'll see a whale icon on the status bar. Alright, here you can see the whale icon. Now when the whale icon becomes stable, it means that Docker has started and you can start working on it. Okay. So this icon needs to get stable. That means that Docker has started. All right. So you can see a message popped up like this. Okay, it says Docker is now up and running. All right. So guys, you can either log into your Docker Hub account from here, or you can use the Docker login command and log in. All right. I'm going to go ahead and log into my Docker Hub account. So now you all can open up any terminal and start running Docker commands. So guys, I'm going to be using Windows PowerShell. Now make sure you run as an administrator because there are a lot of commands which require admin access. Okay, let's say yes. All right. Now, in order to check if we've successfully installed Docker, what we're going to do is we're going to check the version of Docker. So the command for checking the version is docker space -- version. All right, so it's returning the version of Docker that I've installed, which means that we've successfully installed Docker. Okay. So now that we know Docker is successfully installed, let's run a few basic Docker commands. Okay. So let me just clear the terminal. Now I'm going to run docker run hello world. Now this is the most basic Docker command that's run once you install Docker. Okay, so I'm basically going to run the hello world image. Now let's see what happens. So it's unable to find image locally, so it's going to pull the hello world image from Docker Hub. Okay, all right. So this basically gives a hello from Docker message. So we finished the first command. Now let's try something different. Yeah, so you use docker images command to check the images that you have in your system. Since we just ran this hello world image from Docker Hub, we have this image in our repository. All right. Now let's pull a Docker image from Docker Hub. Okay. Now in order to do that, you just use this simple command called docker pull and the name of the image that you want to pull. All right. So I'm going to pull an Ubuntu image. Let's see how it works. So it's basically pulling Ubuntu image from Docker Hub. All right. Now let's run this image. So guys, do you remember that I said that whenever you run a Docker image, it runs as a Docker container. So whenever I perform this command, docker run -it -d and name of the image. All right. So whenever I use docker run and I run an image, it's basically going to create a container from this image. Okay. So it's going to create an Ubuntu container. All right. Now the next command is docker space ps -a. Now basically this will show all the containers. All right. So basically we have two containers over here because we ran both of these images. All right. So whenever you run an image, it runs as a container. That's exactly what I told you earlier. Okay. Let's clear this. Now let me type this out and then I'll tell you what this does. All right. Now what I'm doing here is I'm just accessing a running container. Okay. This is the container ID, which is basically the Ubuntu image that we pulled. So I'm basically giving the container ID of this Ubuntu image that we pulled. Now we're basically within the container. Okay. You can perform commands like, let's say, echo hello. All right. So it says hello. Now what you can do is you can just exit from here. All right. So you come out of the container. Okay. Now let's try to stop a running container. Okay. Let's say docker stop and the container ID. All right. So it stopped that container. Okay. All right. So the next command is docker commit. Okay. Let me just type this out and then I'll tell you what it does. Okay. So basically I'm using the docker commit command. So basically it's going to create a new image on the local system. So after docker commit, I have the container ID and I'm going to create an image out of this. And after a space, I've mentioned Zulekha /Ubuntu. Now Zulekha is basically the name of my Docker Hub repository and Ubuntu is the name of the image. All right. So let's see what happens. So basically we created a new image over here. So here you can see that there's another image which is added, which is Zulekha -Ubuntu. Okay. It has a new image ID and so on. All right. Now guys, if you perform this command without logging into Docker Hub, they're going to ask you to log in first. Okay, and for that you can use the command which is docker login. All right. Now I've already logged in earlier in the session, so that's why it says login succeeded. Otherwise it's going to ask you for your credentials. All right, it's going to ask you for your username and your password. Okay, now what we're going to do is we're going to push this image to Docker Hub. So we're going to use the docker push command along with the name of my Docker Hub repository and the image name. All right, so it's preparing and it's going to push this image to Docker Hub. All right. Now let's say that you want to delete a container. So what you can do is you can use the docker rm command. So basically the command goes docker rm and the container ID. Okay. All right. Now let's look at our containers. Now we have only one container. So basically the container with container ID, this got deleted. Okay. Similarly, you can also remove Docker images. All right. So first let's look at the Docker image ID that you want to remove. All right. Let's say I want to remove Zulekha Ubuntu. Okay. I'm just going to use this image ID, and the command is docker rmi and the image ID. Now let's look at the Docker images. Now you can see only Ubuntu and Hello World is there. So this is how you remove Docker images, and I also showed you how to remove Docker containers. So those of you who weren't familiar with Docker have a good idea of how simple Docker commands work. Now if you all want a more in-depth video about Docker and Docker commands, I'm going to leave a link in the description so you can go ahead and watch that content. Alright, so now I'm going to create a simple Python web application using Docker Compose. Okay, now let me tell you a little bit about this application. It basically uses Flask framework and it maintains a hit counter in Redis. So guys, for those of you who don't know what Flask is, it is basically a web development framework which is written in Python. And Redis is an in-memory storage component. It is basically used as a database. Okay. Now guys, don't worry if you don't know Python. This program is very understandable. So we're basically going to use a Docker Compose to run two services, which is web service and Redis service. Now what this application does is it's going to maintain a hit counter every time you access a web page. So each time you access the website, a hit counter gets incremented. Okay, it's simple logic. Just increment the value of the hit counter when the web page is accessed. Okay. Alright, so let's begin with creating a directory for your application. It's always a good practice to have a directory which stores all of your code. Alright, so let's start with creating a directory. Let's say web application. Alright, now I'm going to change to that directory. So guys, I've already typed out the entire code because I didn't want to waste a lot of time. So what I'm going to do is I'm just going to open up the files and I'll explain what the code does. Alright, so I have all of my code written in Notepad++. So I'm just opening up Notepad. Also guys, I want to tell you that you don't have to install Python or Redis. We're just going to use Docker images for Python and Redis. Okay. So first what you have to do is you have to create a Python file. Okay. I've called it web app. So I'm not going to spend a lot of time over here. I'll just tell you what we're doing. So first of all, we're going to begin with importing the dependencies. So we're going to import real time. We need Redis. We also need Flask. Okay. These are the requirements that we're going to import. After that, we're just initializing the name of the application. So here we're just hosting the database and we're connecting to Redis using the port number 6379. Alright, this is the default port. Then we define the get hit count function. This basically returns a number of hits. So we're also setting the retries to 5 in case the page does not load. While all of this holds true, the incremented hits are returned. And if there's an error, then we have an exception. So we've also defined exceptions in case of errors. This function is basically to display the hello world message along with the hit counts. So this is the Python file. It's very simple, guys, very understandable. You don't have to be a pro in Python to understand this. This is very understandable. All right. Now the next file you're going to create is a txt file, which I've named requirements.txt. Okay. Now over here, I'm just going to add my requirements, which is Flask and Redis. So next we have the Docker file. Now this Docker file is used to create Docker images. Okay, I mentioned this earlier in the session that you require Docker files to create Docker images. Okay, so first we're just setting the base image. So we're building an image starting with Python 3.4. Now in this line, we're just going to add the current directory into this hyphen code path of the image. Then we're going to change the working directory to this path. After this, you're going to use a package manager of Python to install the requirements that I mentioned in my requirements.txt file. Okay, so these two were the requirements, which is Flask and Redis. And then finally, we're just setting the default command for the containers to Python web app. Okay, so it's basically going to run my web app. Now we finally have a Docker Compose file. Like I mentioned earlier, that a Docker Compose or a YAML file is going to contain all of the services. So there is web service over here and there is Redis service. So we're basically running two containers over here or two services over here, which is web and Redis. So now the web service is basically building the Docker file in the current directory. All right, the dot signifies the current directory. and it forwards the exposed port 5000 on the container to the port 5000 on the host machine. Now the Redis service is basically using a Redis image pulled from Docker Hub. So guys, this was all about the files. You need to create a web application file, which is a Python file, and then you have a requirements.txt file, then you have to have a Docker file and a Docker Compose file to run both of these services. So guys, now that I've explained the various files, what I'm going to do is I'm going to run both of these services or both of these containers by using the docker-compose up command. Alright, guys, make sure to create all of these 4 files, and you have to create them obviously in the web application directory. So if I do ls, I know that I have a dockercompose.yaml file, I have a Docker file, I have requirements.txt, and I have a web app.python file. Now let's use docker-compose up to run all of these containers. So it's just building from my Docker file. So now it's installing my requirements over here. So now it's running my web app.python file. Now it's creating 2 services over here, which is web service and Redis service. So what I'm going to do is I'm going to look at the output by using Kitematic. So guys, I told you all earlier that Kitematic is basically a UI tool for Docker for Windows. So just left click on the Docker icon over here, and here you're going to see Kitematic. Okay, click on it. Alright, I think I'm facing an error. I'm just going to go back to my files and see if I have missed out any line. Alright, so over here I have written RT. This is actually import time. Okay, this was a simple mistake. So let me just save this and let's try and run this again. Now it should definitely work. I'll just clear the terminal and we're going to use docker-compose up. Alright. Now guys, what I'm going to do is I'm going to show you the output using Kitematic. Here you can see an option Kitematic. So click on this. Now it shows 2 applications over here which are running. One is the web service and the other is the Redis service. Now when you go to the web service, you can see the output over here. Let's click on this. So whenever you refresh the page, the hit count increases. So this is how the application works. If you keep refreshing, the hit count will keep increasing. So guys, this was a simple web application, and I also showed you all how to view this using Kitematic. Okay, so now you can see that this is green, which means that it's running. Alright, you can also restart the container, you can stop it, you can enter into the container, and you can run a few commands. Okay, you can use Kitematic in a lot of other ways.
And now if you ask me how to use Docker, then let me tell you that it's pretty simple. You have a Docker image of the particular application that you want to run, and then when you use the run command and then execute this particular Docker image, you get a Docker container out of that. That's as simple as that. Okay, but there are a few things which you have to understand how this Docker image is being built. So there are 2 different ways. Basically, if you're using a custom Docker image, then it's going to be a little complicated, which is going to involve a Docker file. But if you're using a normal Docker image or an image which is already existing, then it's going to be pretty simple. You just use a Docker pull command to pull the Docker image from the Docker hub, and then you will just execute that particular Docker image, and then you will have the container running. And if you want to build your own Docker image, then you have to first of all write a Docker file. Okay, and in the Docker file you have to specify what's going to be your base image, and then you have to specify what libraries and what packages you have to install in that particular Docker image. So they will make up a stack of images built one on top of each other, and that will be one final Docker image. And that one final Docker image, if executed, will basically be run as a container, and then you will have your application which is deployed, and that will be your custom Docker container. And then comes the part of Docker Hub, where if you want to share it with other people, then you can upload it to Docker Hub. And then when you upload it to Docker Hub, you can basically pull that particular Docker container anywhere else in the world. You can pull it onto your staging server, and you can pull it onto your production server. And when you pull it over here, then you're basically getting the same particular application with the same dependencies and the same versions. So this way, a lot of problems are eliminated, which people face regularly by going through the traditional approach. Now, imagine if there was no Docker image which could be pulled over here to replicate the same environment. Imagine how things could be. So you have a staging server, and then you have a production server. Now, let's say you have Java 8 installed in your staging server, and you have Java 9 installed in your production server. And the code that you have written, which you're later on deploying to both these servers, let's say that particular code needs Java 9, specifically Java 9. And without Java 9, it would not run. Certain modules don't work. So if that is the case, then when that particular code is deployed onto your staging server, then your code will work fine because Java 8 is present over here and your code needs Java 8 in particular. Okay. But if the same code which needs Java 8 dependencies, if that is deployed onto production server, then it might not work because your production server has Java 9 and then your code needs exactly Java 8. And this way you have the traditional DevOps problem that comes up. The code works on my machine, but it does not work on your machine, right? The developers and the ops guys have a fight over it all the time. So to ensure that there is consistency in both the environments, the staging and the production server environments, we use Docker. So this way, it's a big benefit over any server or any virtual machine or anything else for that matter of fact. So that's one reason why you should use Docker, okay? So that you can have the same environment across the different servers or the different places where you want to deploy your application. That's it, guys. Let me go to the next slide. And now let's see how to build and use Docker images, okay? But before I go into the details of building a custom Docker image, let's see predefined images. Now, like I told you, you have a Docker hub wherein all your Docker images will be present. If you want to just use a normal Docker image or a Docker image which is already present on the Docker hub, you can simply pull it from the Docker hub repository by using the pull command, and then you can execute that Docker image which you've downloaded by using the run command. And then when you run your Docker image, you have a Docker container which is active. So your Docker container is basically the active version of your image, right? And that way, whatever application you wanted would be running there inside this container. But most of the time, these predefined images are of no good because what we want for our business is something which is very specific, right? So in this case, we have to use some kind of custom image. We have to download our own applications and our own libraries. So how will I customize this Docker image? For me, I can basically write a Docker file, okay? And in this Docker file, I'll first of all say which is the base image I'm going to use. And this base image is also going to be pulled from my Docker hub, okay? So if I want to basically execute or containerize an application on Ubuntu, then I'm going to say in my Docker file that use Ubuntu as my base image and then perform various commands. I can have XYZ commands running on that particular base image of mine. Okay, so I'm going to do something similar here in today's session. I'll be pulling one of the Docker images. I'll be using that as the base image, which is going to be Ubuntu. And in my Ubuntu, I'll be installing Apache and I'll be installing NGinx. And while you're writing a Docker file, it's pretty easy to pull a custom Docker image, but the challenge comes after that because there are various functions which you want to perform on that Docker image, right? You want to customize it as per your needs. So for that, to achieve various functionality, we have various commands like run, from, maintainer, add, cmd, entry point, environment, expose, user, volume, working directory, and many more. Okay, but these are the most common ones which we will be using in a day-to-day basis. So let me explain each of these functions and the syntax of this Docker file before I show you my demo. So let's go about writing a Docker file. First of all, your Docker file is just going to be a file, okay? Just going to be a text file without any .txt extension, okay? And your Docker file will basically contain commands and arguments only. And that is all that is needed to run, okay? These commands and arguments. But additionally, if you want to just comment something, if you want to use bogus lines, then you can use it. Then you can write it by using this hashtag over here, okay? So technically, it might involve you having commands and arguments, okay? So my commands and arguments are the ones which are going to help me customize my Docker image. And the commands is something which I can write for my explanation, okay? So if I say hashtag over here, then whatever comes in that particular line after the hashtag would be ignored. So if I say print welcome to Edureka, then I'm just giving a sample here. So this line would be completely ignored and not executed. But however, in the second line, if I have run, echo welcome to Edureka, then this line would be executed, okay? And in this case, I have my commands and arguments. Run is going to be my command and echo welcome to Edureka will be my arguments. So I can have argument 1, I can have argument 2, I can have argument 3 and many more. Okay, but by default your arguments would be just 2. Okay, I will have one command and then 2 arguments. Okay, so let me go into more details of these things, and by details I want to talk about the different syntax that I can use here, the different functionalities or the different commands that I can use. Okay, so let me start off by talking about the most important command, which is nothing but the from command. So from is the most important command because without the from command, you cannot write a Docker file, because the from command is what is used to specify a base Docker image. Okay, in my case, I've specified here Ubuntu, which means that I will be using an Ubuntu as my base Docker image, and all my customizations will be on top of my Ubuntu image. Now think of it very much like you working on a server or you working on a Linux machine. Okay, you have an Ubuntu machine with you,
And then if you want to execute or deploy your application on that particular machine of yours, you have to install everything, right? So you've not done the other steps though, but so far by using a from Ubuntu, it means that you have an Ubuntu machine with you. So this is just the base image, which can be equivalent to you just having an Ubuntu machine. Okay. And what you do after that onto that particular Docker image depends on the other functionalities. And then moving on to the next command is the run command. Now this is again, I would say, the second most used command, because at the end of the day, if you want to run a particular image or if you want to run a particular command, then you use this run command. In my case, if I have an Ubuntu image and if I want to install, say, Java or Jenkins or React or curl, then I will be using this run command. Okay. So I have my run command, and then my arguments here would be apt-get install with a yes flag. I'm saying React or Jenkins or whatever. Okay. So that's what my run command does. It's basically for executing any command of mine, but it has a slight difference when compared to CMD. Okay, because run is used to run a command. Okay, it can be a command which is it could be a shell command, or it could be a command which basically runs my image into a container. Okay, and that is what the difference is with respect to CMD. With CMD, you again can execute your shell commands like I've done here. I can say CMD echo welcome to Edureka, but however, I cannot use a CMD command for building my Docker image. Okay, so I cannot execute my Docker image, or I cannot build my Docker image with the help of the CMD command. So if I want to execute a command on my shell, I can use either run or CMD. And if I want to basically build my Docker image, then I can only use run. In such places, CMD don't work. Okay, so moving on, the next important command is the entry point command. Okay, the entry point command is basically used to basically override whatever function your CMD command does. Or the entry point basically suggests that when you've finished building your Docker image, then the command which is specified with the entry point, that will be the one which will be executed first when you run the Docker container of that particular image, right? So I can build a Docker image which has this entry point command, and my Docker image will be built. And when I execute that particular Docker image, then the command which is specified with entry point will be the first command to be executed. Okay. And the additional functionality that entry point has is the one which I already said, which is nothing but it can override your CMD command. So take for example over here. So here I'm saying CMD welcome to Edureka. Okay. And here if I say entry point echo, then my entry point will basically override this, because most of the time your CMD commands would be the first set of commands which would be executed in your Docker file. Okay. You can have a lot of things, but in your CMD command, you will have some set of arguments present over here. So in this case, I have one command and then one argument. But with my entry point, if I say entry point echo, then this would be used as my argument to execute this argument of mine. Okay. So that is the whole point of entry point. And this is the subtle difference between entry point and CMD. Entry point can basically override your CMD commands. So next comes the add command. Now the add command or the copy command, these are commands which can be used interchangeably, because the add command is used to copy whatever files which are there in one particular directory to another directory. Okay, so it could be copying files from my host to my container. Okay, so I'm saying add, and then I can just specify the path of my source. After that, with a space, I can specify the path of my destination to where I want to copy my files. Okay, so this is also pretty self-explanatory. And then the environment command. Now, if my application needs a particular environment variable, then I can specify to my Docker container that this application needs certain environment variables, and this environment variable is present over here. So an example of this could be if you want to execute a Java program, then you need Java, right? And you have to set your environment variables. So I can specify my Java environment variables like this inside my Docker container. So my environment would be my command, and these would be my arguments. So server works would be my argument 1, and this would be my argument 2. All right. So that was one example. And then the next important command that you have to be aware of is the working directory command. In your Docker container, a lot of times you would want to go into a particular container and then start execution inside that container, especially when you want to execute certain commands in the shell, right? So if you want to use the CMD command inside your Docker file, then you want to basically execute a particular command on the shell, correct? But where exactly do you want to execute that command? Because these commands will be executed from inside the container. And inside the container, if you want to customize the place where you want to execute that command, if you want to change the place where the CMD command will be executing its arguments, then you have to set the working directory over here. So you will say working directory, and you'll just set the path over here. And then whenever you have a CMD command which gets executed, then that CMD command would be executed in this particular path. Okay, so pretty simple, right? And then we have the expose command. And the expose command is a very important command in case of front-end applications, because so with the expose command, you can specify a port number and you can specify that this application would be active on this particular port number inside the container. Okay. And yeah, this will be the one which is running inside the container. And however, if you want to execute the same particular application and you want it to run on a particular port number on your host, then you have to do the port mapping, but that comes later on. But inside the Docker file, this is how you specify that. And remember, this is going to be only specific to your container, and this port number is only going to be used from inside your container. The next thing is the maintainer command. So it's not a very technical thing, but if you want to tag your name along with the image which you are building, then you can use this maintainer to specify who's the person that's maintaining this particular Docker image before you upload it to Docker Hub. And then that way, whoever uploads or downloads your image from the Docker Hub will know that, okay, this is the guy that basically built your image. Okay, so you can just set your name over here. And this has to be present only after the from command. That's the point which you have to note. And then we have the user command. And if you want a particular user to execute or to run a container, then you can use this user command and specify the user ID of that particular user whom you want to execute the Docker container. Okay, so it's pretty simple, right? So the user here is my command and 751 is the argument, and this particular user who's having this UID will be executing that particular Docker container of mine. And then we have the one last command that we're going to talk about, which is nothing but the volume command. So this volume command is basically used to set a custom path where your container will store all the files. So this is the place where all the files related to your Docker container will be present. And even if you want two containers to share the same path, then you can use this volume. So this path, it can be shared by multiple containers. So logically, if you have multiple containers which are hosting the same application, then you might want them all to use the same path, right, where it's stored. So this is the path where it can be present. So that's it. And now let's move on to our demo. And first, I will show you how to install your Apache web server, and I will show you how to write a Docker file. Okay. So in the first demo of mine, I have a simple Docker file where I'm first of all using an Ubuntu image as my base image, and then I'm saying maintainer is Edureka, and then I'm running a few commands. Even if you're trying to install Apache on your local machine on Ubuntu, then you will have to probably run these commands. You'll have to do an apt-get update. This basically updates my apt-get repositories. Okay, and then you'll have to mainly install your Apache service. So the command for that is apt-get install Apache, wherein your Apache will be downloaded from your apt-get repository, and then you will want to clean your apt-get repository. So you'll use the apt-get clean command, and most importantly, we are deleting this particular path. Okay, so you will have various files which are there in this particular path where libapt lists. Okay, so whenever you use an apt-get update, and if you get an error that time, then that's because of the files which are present in this particular path. So to avoid any error that comes in the future, we are deleting whatever is created over here. Okay, and rm-rf is what is used for that. And our run command is what performs all of these. So I have up to 4 functions or 4 commands which need to be run, and I'm using one run command and using an and over here. Okay, an ampersand to say that I have multiple commands which need to be run. So that's the thing. And for my Apache to work, I have to set my environment variables, and that's what I've done here. So it's pretty simple, and it's the same as the installation process. It's just that I'm setting it manually inside the Docker file on my own. Okay, so for Apache run user, for Apache run group, and for Apache log directory, there are various paths where it has to be present, and that's what I've specified in arguments over here. So these are my first arguments, and these are my second arguments. And then I'm saying expose 80, which means that on port number 80, my Apache service would be hosted. Okay, but remember, this is only from within the container. Okay, if I want to access it on my host machine, then I have to do the port mapping while starting this particular container of mine. So inside my container on port number 80, Apache will be present. And finally, if I want to start this Apache service, then I have to go to this particular path, and then I have to start that Apache 2 service, right? I'm doing the same thing over here using my CMD. So using the CMD command, I'm saying go to this particular /user/sbin/apache2, and I'm saying execute this and run it in foreground mode. So -d is the flag which we have to specify, and then I'm saying foreground to basically get the UI up and running and to get it hosted. Okay, now to show you the same demo, let me open up my virtual machine where I have prepared this Docker file. So this is my VM. I hope you all can see my VM over here. Okay, so I'll just open up my terminal and I'll bring up my Mozilla Firefox. Okay, so let me do an ls, and then I have my documents folder, right? So let me do cd documents, and let me do ls. So I have a Docker file here. Let me do cat Dockerfile and show you that I have the same code present over here. Okay, so what I explained right now as to how to install Apache and then use the various commands, I have copied that same code into this particular Docker file of mine. Now the first thing I have to do is build a Docker image, which is going to be my custom Docker image out of this Docker file. Okay, and the second thing I have to do is to run that particular Docker image into a container. All right, so let me get started with the first thing. So if you want to basically build a Docker image from your Docker file, the command is docker build -t, and then you have to specify the name of your Docker image. Okay, so I'm going to say my Apache image. Okay, and then I'll just say the place where the Docker file is present by mentioning period. So by mentioning period, it means that the Docker file can be present in this particular directory, and based on that Docker file, this Docker image would be built. So let me hit enter and just wait for the various steps to be performed. Okay, so step 1, step 2, step 3, and then all the different steps which I specified inside my Docker file are being executed one after the other. So my first step here is nothing but from Ubuntu, which means that I'm pulling a base Ubuntu image that is present over here, and then I'm saying step number 2, make Edureka as the maintainer, and then step number 3, where I'm installing various functionalities. Okay, so let this complete. Okay, I think this part can be forwarded and moved ahead. Okay, so I think all the steps have been executed successfully because I've got this message, right? Successfully built and the ID of my Docker image. So if you intermittently see step 4 executed, step 5 executed, step 6, step 7, and step 8, everything have been executed. So my Docker image has been built, and then I can verify the same by running this command, Docker images. Okay, let me say sudo Docker images, and as you can see here, my Apache image with the latest tag has been built 28 seconds ago. All right, and this is the size of this particular Docker image of mine. Now let me use this Docker image and bring up the Docker container out of this image, and the command for that is sudo docker run, and now I have to specify the port number because inside my Docker file I've specified that the application has to be active on port number 80, and if I want to access that application on my host machine, then I have to do the port mapping of my host port to my container port. So let me say -p and say 80:80. So this means that port number 80 of my container will be mapped to my port number 80 of my host. Okay, so first comes the host, then comes the container, and after this I can just simply specify the image which I want to build, right? So I can say the name of the image is my Apache image, and I can also give a name to my particular container. I can say -name equal to app1. Okay, so I can give enter, and yes, so ignore this message, but anyways my Apache service would have been installed. So let me just go here, and if you remember, it was port number 80 where it was hosted, right? So let me just type in localhost :80, and yes, it says that it works. This is the default page for the server, and the server is running, but no content has been added yet. That's because I have not done anything manually, but it's just that I've hosted the same service which I got. This is my Apache service which I've installed. Okay, so my service is running now, and I can verify that from a different terminal. So let me just go here and say docker ps. Okay, sudo docker ps, and you can see that my Apache image was the name of the image, and then the name of the container is app1, and this has been containerized, and it's basically created these many seconds ago, right? Now if I want to stop running the service, I can either stop this container over here. I can run a command to stop the container, or I can simply use a Control-C, and with that I'm out, right? This container is not being executed anymore. So this is a shortcut, but it's not advisable. Rather, the command to stop a container is docker stop and then container ID. So I will show you how to do it with the second demo. Okay, but let me just go here and verify that again. So if I refresh this, then the page is not accessible anymore. That means my container is not running, and hence the server is not working. So that's the end of the first demo of mine, which shows how to install Apache. Okay, so let me just do a sudo docker ps -a over here and show you that the same container over here with the same ID has exited. Okay, and let me clear the screen here and over here too. Okay, and then get to my second demo. So my second demo is all about installing NGinx. So again, to install my NGinx server, I'll follow the same steps. Okay, I'll first of all use an Ubuntu base image, and I'll be installing my NGinx service on my Ubuntu machine. So that's why I'm doing from Ubuntu, and then I'm specifying maintainer Edureka, and then similarly I'm using or running the command run apt-get update, run apt-get install -y NGinx, and then I'm doing add an index.html. Okay, now first of all, let me tell you that with respect to the previous demo, I ran these two commands on the same line, correct, with an ampersand. Here I've just divided it into two lines. So it's just to show you the functionality and the shortcut which I used in the previous demo. Okay, but otherwise it's all pretty much the same. And then what is new here is the index.html, because with NGinx, this index.html is not created by default. So I just created an index.html file, and then I put my own code in that index.html file, and that is what I'm putting inside my container over here. So if you remember, the add command basically copies what is there in one path to the destination path. So this is my source path, which is my host path, and this is going to be my container path. So index.html, which was there in my same folder, that is copied inside my container. So there is NGinx inside the user/share. Okay, so inside that there's another folder called HTML, and inside that folder the index.html file will be copied. And once it's copied over there, from here I'm using an entry point command, so that whenever my container is running, right, so I have my Docker image, and then when I execute the Docker container, then this line would be executed. So these will be built, though all the environment would be set up over here, but this command /user/sbin/NGinx, so this is the service which needs to be started. So my Docker is going to particularly go to this particular path and then start my NGinx service by giving the flag -g and daemon off. So daemon off here basically helps me bring my application to the foreground. Okay, so if it's daemon on, then the application would be running in my background. Okay, but since I've specified daemon off over here, and because I've specified daemon off and brought it to my foreground, I can see the UI, and I can only see the UI if I say the particular port number, and that is what I've done in my final line. I've said expose port number 80 again. So if I've said expose port number 80, it means that in my container it's going to be hosted on port number 80, and I can map this to my host port in my run command. Okay, and when I run the command, I'm going to repeat again, when I run the command, this would be executed, and this was what brings up my NGinx service. Okay, so let me go back to my terminal and show you the file. But however, it's not in the documents folder, so let me go back and go to my downloads folder. Okay, so here I have my index.html file, and then I have my Docker file for installing NGinx. So first let me do a cat Dockerfile. So it's the same set of code which I explained a few seconds back, and then let me also do cat index.html, and this is basically my HTML code which will be displayed on my UI. So the title of my page is going to be Edureka's Docker NGinx tutorial, and then in h tags I have hello Edureka learners, and then I have a p tag where I've specified something. So this is the backend of a HTML file, and this is how any HTML file is built, right? So I've just copied it and I've pasted it. So this is how the backend HTML of any web page will look like, right? So I've just created that and hosted. I actually had it on my machine, and then I basically put it inside my Docker container, and then I'm going to start the NGinx service. When I start the NGinx service, this index.html file will be picked up and be used as the default page or the first page which comes up in my UI. Okay, so let me clear the screen and first of all execute this Docker file. Now to build the Docker image out of this Docker file, the command is docker build -t, and then after specify the name of the image, let me say my NGinx image, and then after this let me say the path where the Docker file is present, and I can do that by specifying dot, and let me go ahead and also specify sudo. Okay, so my first step executed, second step also executed, and so is my third step, and let's just wait for all the steps to be executed so that my custom image is built. And trust me, this is my custom Ubuntu image. Okay, okay, so that was my build command, and if I want to execute or bring up the container out of this particular image of mine, I can use the command docker run -p. I'll specify the port number where it will be active, and let me again say 80:80, followed by the name of this particular container. I can say name is equal to app2, and then I'll just specify the image which I'm going to use. So my NGinx image. So this is the name of my image, right? And however, I have to also specify sudo over here. So if I hit enter, my container would be active. And since I've specified entry point, basically it would go to that particular path and start my service. So let me just go to localhost and check if that's working. Okay, I'm going to say localhost 80. And yes, this is my NGinx service. Of course, it's a little different from my Apache service, and I've customized this one to say that this is my page title, Edureka's Docker NGinx tutorial, and then I've specified hello Edureka learners, and then this, right? This is what I also showed you sometime back in that index.html file. So this time, let me show you how to stop this particular container by not doing Control-C, but by actually stopping your container in a healthy way. So let me open up the second tab over here, and over here, let me say sudo docker ps. This would first of all list down this particular Nginx image of mine. Okay, this is the container ID. So I'm going to copy this container ID and then stop this particular container. I can say sudo docker stop and then container ID, and my container would have stopped by now. So if I go back to the other tab, you can see that I've got control back here, which means that my application is stopped being deployed. So if I refresh this page, you can see that I do not have access to the page anymore, right? So that's how you host any application of yours, and that's how you bring it down with the help of your containers. Okay, in a snap of your fingers, you can get anything done, and that's why Docker is really good and really useful.
Why Docker Compose? So when we have a single container, we don't need any specific tools to manage that container. We can do that ourselves, right? But when we have large number of containers that have been deployed, so managing those large number of containers manually is not going to be an easy task, or it's not going to be feasible at all. So for managing those large number of containers, we have to use a tool which is going to allow us to manage those containers, to deploy those containers, to simply, if we want to scale up the containers, if we want to add more containers, if we want to remove some containers, we have to deploy the containers, we have to deploy the updates in those containers. So for every setup required, every kind of management tool is offered under orchestration tool, like we have Docker Compose. So if we talk about a simple example, we can take the example for Agio, which is basically one of the most popular online retail store. So Agio is basically deployed again in different services. So basically Agio in, or even if you talk about any e-commerce store, not just Agio, but any e-commerce store, they have multiple components, as in multiple microservices defined here. So for example, Agio being an online e-commerce store, it has a component for server, where it allows the users to log in or sign up for a new account. Then it has a different service for catalog, where the users can browse through the entire products. And then we have the shopping cart, which is again offered as a service, where the users can keep the products that they like, or they would like to check out with. And then we have other service for checking out, which is integrated with any of the popular online payment gateways. Now, these all services are deployed separately. They are not deployed on a single server, but they're not bundled together, because if we do that, and if we have bundled them all together, and if we have any issues in any single component, then that is going to create issue for the other components as well. That means in case there's an issue with the catalog, then the login account server, the shopping cart, these checkout, again, these functionalities are also going to be hampered. If there's some issue with the checkout, then all the other services are also going to be hampered. Because even if there's something wrong with only one service, then still, so for example, if there's something wrong with the checkout, still the users can create their account, they can browse through the entire product, they can add them to the cart, but they won't be able to check out for a certain time period till the time the developers team, they fix the issue. That means at least all the other components will be up and running without any issues. And that's why it is always a better method to go for medium to large scale applications, where we can define the entire services into microservices. So basically, we have a complete service together offered as an online retail store. And then here we are dividing the entire services into multiple microservices component, where the login account can have access to their own database for accounts. where catalog can have its own data set, data access to any database defined for only for specific products. Then we can have a separate database for cart, a separate database for checkout. That means they all are working separately. They are not dependent on a single resource. And the idea behind microservice is that some type of applications becomes easier to build and maintain when they are broken down into smaller pieces which work together. That's the main idea. And it becomes much easier to do the entire maintenance, patching up the servers, taking care of, you can say, applying any maintenance window or upgrading the servers as and when required. And that is the main concept of using microservices, especially for these large retail stores. Just like we have a separate microservice containing the catalog server and the database, same way for shopping cart and database, and this for checkout server and its own database. So each of these microservices could be scaled up in its own container if required without disturbing the others. That's the main concept of using microservices here. And using Docker Compose, we can connect all the isolated containers as a single service. So basically, Compose makes sure that, suppose if we want to start the application, right? So we don't need to go individually in each and every service component. For example, here, we don't have to go to each and every service and then start them manually. Because if we have 15 different microservices deployed for a single application, and then starting, stopping, or managing each and every service manually is not going to be an easy task, correct? So using Docker Compose, we can connect all the microservices together, and then we can start them, we can manage them easily using a centralized location, or we can say as a centralized service. And that is a main advantage of using Docker Compose, where we can use all the services, we can start, stop, we can deploy all the services at once by using this Docker Compose section. So now let's discuss what exactly Docker Compose is. So Compose is basically used for managing all the containers together, and it allows us to make sure that we are having the centralized management tool to manage all the containers in case you want to apply some configuration changes on multiple components of these microservices. And that is exactly what Docker Compose is. So basically, in simple layman terms, we can say it is used for running multiple containers as a single service. And each of the containers here run in isolation, but they can interact with each other whenever required. And Docker Compose files are very easy to write in a scripting language called as YAML, which is a XML-based language that can be used easily without having any kind of parenthesis or complex syntaxes required. The entire layout is much easier for the Docker Compose files as they are written in YAML. And another advantage that we get by using Docker Compose is that users can activate all the services using a single command. So if you want to stop all the microservices, we can do that. If you want to activate all the services by using a single command, we can do that easily by using Docker Compose files. Now, a simple example can be, for example, if we have an application that requires an NGinx server and a Redis database. So we can create a Docker Compose file that can run both the containers as a service without the need to start each one separately. We can do that. And there are multiple advantages that we get with Docker Compose. So basically here, if we talk about Docker Compose, then it offers a single host deployment. That means we can run everything on a single piece of hardware. We don't need to have multiple hardwares for running the entire environment. And it is quick and easy to configure as well. It offers a high level of security. That means all the containers are completely isolated. When we say they are able to communicate with each other, that doesn't mean that we are compromising the security. They are still completely isolated from each other. And then it simply reduces the entire threat landscape here. And it offers easier configuration due to the YAML scripting, which is much easier to structure. Even for those who are not proficient in the coding aspects, they can still make use of YAML script for configuring the entire containers in an easier manner by using Docker Compose. And then it also offers a high level of feasibility, and again it offers a high level of productivity. So basically it reduces the time it requires to perform the task, and thus increasing the entire level of productivity that we can achieve from this entire Docker Compose tool. So what is a compose file? So compose file, as we have seen, it's simply written in YAML script. So basically, when we are creating a YAML script, we can define the entire versions, as in the version of the file, the services that we are going to work with. Like we have the database. So here we can choose the image as Postgre. Here we can choose define the environment as in the Postgre database, the user, the password for the current environment that we are working with. And then for web services, we can define the entire build command, whatever command we want to be executed for the current web version. Then we can define the volume, the ports, depends upon the entire configuration that needs to be done for the web servers. So that's why we can define the entire services. Like we have microservices. Then we can manage these services individually by defining the service properties. And here we can notice there are no parentheses required. There are no semicolons towards the end. And that makes the entire deployment of this compose file much easier because it is based on simple YAML script. And the compose file is basically a YAML file definition service in networks and volume. The default path for compose file is .docker and -compose.yaml. So this is basically the default path for Docker file. Although if we want, we can customize that. But again, in case we want to maintain the homogeneity of the file structure, it is recommended to make sure we are keeping the default path the same. And it contains a service definition which configures each container started for that particular service. So now let's see how we can install Docker Compose in our system. So first of all, the process of installation is going to be a bit different based on the platforms that we are going to choose. So as a part of a hands-on, we are going to work on Ubuntu platform, which has been deployed on a cloud service by AWS. So based on the platform you're going to use, suppose if you're going to install this on a Windows server, on a Linux server, and that too based on your own system, that's going to be a bit different. So I'll be guiding you all on how we can take care of different installations. But for our hands-on, we are going to make use of the Ubuntu server running on as a part of EC2 instance service offered by AWS Cloud Platform. So first of all, to get started, we have to use a simple basic command in Linux. So first of all, we have to deploy the EC2 instance, and then we can get connected to that server by using PuTTY or using any other SSH client. And then we can start by using the pip library for installing Docker Compose in our system that we want to use as a part of Docker Compose file. So on Linux system, first of all, we have to install Docker engine for the operating system, and then we are going to use pip library and then install Docker Compose to install Docker Compose on a system, and then we are going to use Docker Compose version to verify if it has been installed properly or not. Because if it's not properly installed, then we are not going to see the Docker Compose version returned to us. So let's see how we can install Docker on Ubuntu platform. So currently what we have done here, we have an EC2 instance running on top of the Ubuntu image, and we are going to install Docker Compose on this particular server. So basically there are some prerequisites that needs to be installed and configured on the server before we can start with installation of Docker Compose. We do need to have the entire pip package. We need to have the entire Docker engine already installed and configured. And for getting details on how we can install these different Docker engines, so you can find the references to install these different packages and how to configure them as a step-by-step guide in the description below. So we are going to use the pip library that we have already configured on this entire Docker engine. So we are going to use a common command as sudo pip install Docker Compose. And once we are done with installation, then we are going to check for the version and see if the correct version has been installed or not. Because if we are not getting the version returned, then that means there is some error and we have to do the installation again. So to make things comfortable for you all, so that you don't have to strain your eyes, let's increase the font size. So we can go to configuration. Currently, we are using MobileStem as our SSH client. We can use any of the other SSH client. It is not mandatory to use only a single platform. Depending upon your comfort level, you can use any of the SSH client as per the comfort level. So let's increase the font size from 10 to, let's say we increase it to 16. Let's restart the instance. Now we can clear the screen. Now here we are going to work on installation of this Docker Compose file. So first of all, we have to use a command set as sudo. Then we are going to use the pip library. And here we are going to define install Docker-compose. So this is going to refer to the pip package manager that we have already defined, and then it is going to refer to this package and download the entire Docker Compose library for us. So as you can see, the entire package has been downloaded. And to make sure that the entire package has been correctly installed, we can refer to Docker Compose and version, because again, this is going to make sure that we are having the right version installed. And if there is not installed, then again, we are going to see an error. That means the current version has not been installed properly. So I hope this entire installation process is clear for everyone. So we have to use a command as docker pip, and there may be some different versions of pip you may have installed. For example, if you are using pip 2 or pip 3, then you have to maintain the version there, and then docker-compose, and then this is going to install the entire package. And to cross-check if the Docker Compose has been properly installed or not, we can use docker-compose space -version, and that is going to return the version of Docker Compose that has been configured. So we had seen how we can install Docker Compose. Now next we are going to see a Docker Compose hands-on. So in this hands-on, we are going to deploy a microservice. So basically here we are going to deploy a Docker Compose project, which contains a Docker file where we have the entire Docker file defined in the same format as the template that we have seen earlier. So we are going to define a version, the services, which we are going to deploy, both in terms of database and the web services. And then we are going to create a Django project by building the image from the build context defined previously that we have seen. So let's see how we can define that. And towards the end, we are going to see how we can set up a database connection to this Django platform. Docker Compose, then we are going to work on our Docker Compose file. First of all, here we are going to create the entire configuration files. So here we can create a separate project directory, which is going to be our project directory, where we can name the directory something easier for us to remember. And this directory is meant for creating the image that we are going to use as a part of our Docker Compose tool. So directory can be anything. We can name the directory as per our own requirement. We can name it as anything. And here we can define a directory by the name of sudo mkdir for making directory. Let's say we made the directory name as Django. Now we already have the directory name defined as Django apps. So basically, if we want to create a new directory, we can define it as any name. And we already have defined a directory by the name of Django apps. So we can switch to the directory. For example, say we want to switch to the directory. Here we can define the name as Django-app. And in here, we are going to create 3 main files that we are going to work with our Docker Compose. So first file we are going to work is Dockerfile, which is basically the file that is used to create the image. So for creating the Docker file, we can use any of the editors. We can use V editor, we can use Nano editor, whatever editor we are comfortable with. Let's say we can make use of Nano editor. Now, basically, when we are creating a file, we should be giving the sudo as in the admin privileges. So we can define sudo, and then we can define the editor name as Nano editor, and then we can define the name of the file. Now, when we are creating a Docker file, we don't have to define any extension. So Dockerfile doesn't have any extension, so we don't need to write any extension in the beginning or towards the end as well. It is simple, plain Dockerfile. So here we have defined the Docker file, where we are going to define from the library as Python for version 3. And then we are going to define the environment on Python buffered. We are keeping the value to 1. And currently we are defining the run command here from the make directory, where we have stored the entire code. So basically Dockerfile is going to define the entire application image, where we are going to run multiple build commands that is going to configure the image itself. And then we are going to define the work directory, where exactly we want to copy the current requirement text. So requirement text is going to contain the entire dependencies that needs to be configured, right? So basically this file is used as a part of the Docker file itself. And in requirement.txt, we are going to define the Django version and the binary package that we are going to create separately. So here we define the file name as requirements.txt that we are going to create. And then we are going to define the run command that is going to be executed once we are creating the image. Again, this entire command is going to be executed from the pip library. We are going to install the parameters that we are going to define in requirements.txt file, and then we are going to copy it in the default location of the code. So this is what needs to be there in our Docker file as a part of our hands-on. Now to save this Docker file, we have to simply press Control X, and then it is going to ask for a confirmation that if we want to overwrite any of the file, then we can press Shift yes and to overwrite the current file. Once we are done, then this is going to be saved. And after creating this Docker file, just to make sure that we are done with Docker file creation, whatever we have entered has been saved correctly, we can again open up the Nano editor, and here we can see the entire code being visible to us again. So that is going to make sure that the entire code has been successfully updated. So to close this, we can again press Control X in case we are using the Windows system, or in case we are using the Mac, we can use Command X. So we can press the Control X statement, and that is going to simply bring us out of the Nano editor. So now once we are done creating the Docker file, then we are going to create a requirements.txt folder or text file in the same project folder. We don't have to change the path. We have to create a requirements.txt in the same project directory. So for again creating the file, we can again type the same command as sudo. We can use Nano editor. We can define the name as requirements.txt. So we have to make sure that there is no typos in this requirements file, and once we enter, we can see that file that we have created where we had defined the Django version and then the binary package that we want to define in this particular requirements file, because again at the end Docker is going to install the requirements that we have specified in this Docker file. So whatever path we have given there, we have defined the path as requirements.txt, right? That's why the name of the file also needs to be the same. And here when the requirements.txt file is going to be installed, then again these Django with a specific version is going to be installed and configured on the server. So we are going to come out of this. Same way we can press Control X, and just to be sure that the current file has been updated, we can again run the same command. So for reusing the same command, we can press the upward arrow key, and then the last use command is going to be repeated. So again, just to cross check that we do have the content saved in requirements.txt, we can see the commands being opened up. And then we can come out of it by pressing Control X again. All right, so now once we have Docker file, once we have requirements.txt configured, then we are going to create Docker compose.yaml file in the same project directory. So basically, as we discussed, Docker compose.yaml file is going to describe all the services that we are going to use for making the application. And as a part of a hands-on, we are going to use the servers for web servers and database, as we have seen previously. So the compose file is also going to describe which Docker image these services use and how they are linked together, and any value that may need to be mounted inside the given containers. And then that's why we are going to deploy this kind of Docker compose YAML file. So basically, we can also define all the ports. That means which ports to expose as a part of configuration that we can define under Docker compose.yaml. So let's create that. So again, we can do the same thing. We can run the same command as sudo nano, and here we can define Docker compose.yaml. So YAML format is basically either by AML, or as a standard, we can keep it to YAML format. So here we can define Docker compose.yaml. We can press enter. So this is the Docker compose file that we have to create, where we have to define the version to be kept as 3. Under services, we have defined database. The image is going to be Postgre. In case we want to use some other database engine, then we can define it. For our hands-on, we are going to make use of the Postgre itself. So here we can define the database, the name of database, the user, the password that needs to be configured, because at the end, we don't want to do this manually. That's why we are taking the help of this Docker compose file. And here we can define the configuration that needs to be done for the web servers, the build, the command that is going to be used for Python manage.py. And then we are going to run the server, localhost, and that too on port 8000. So again, we can define the entire volume that needs to be configured, the port that we are going to use the port 8000, and it is going to depend upon the database that we have defined here. So name has to be the same, because if there is any misconfiguration, then our database in our application is not going to get connected to this database that we deployed. All right, so same way, if you want to save this up, we can hit Control+X, and then we can define the yes format to make sure a Docker compose file is created. Again, just to cross check that if we do have the content updated there, So we can simply use the same command set as sudo nano docker compose or YAML to see if the content has been correctly updated. And then we are going to work on the Django project. So for working on Django, we can come out to our root directory, and then we are going to create the Django project by running the docker compose run command as per the current structure defined. All right, so now we are going to work on the Django project first. So we are going to build the Django project. Now here we are not going to discuss the entire Django project in detail because our main focus is to see how we can make use of Docker Compose to deploy the components of Django application and how we can manage it, right? So we are going to use the project that we have already configured locally, and then we are going to simply import that project and configure it by using the Docker Compose YAML file that we have created. So let's do that. So basically, for getting started, we have to make use of this command as sudo docker compose run web Django admin start project compose example dot. So basically, this is going to instruct compose to run Django admin start project compose example in a container itself. And this is going to be done by using the web service image and configuration. Now, because we know that the web image has not been deployed yet, correct? That's why the compose is going to build it from the current directory as specified by the build command that we have defined as build.line, and that has been mentioned in the docker compose.yaml file. And once the entire web service image is going to be built, the compose is going to run it and perform the entire execution for Django admin start project command specified in the container. And the command is going to instruct Django to create a set of files and directories representing a Django project. Now, currently what we have done here, we have installed the entire Django project, and basically here we have defined the Django project from the entire container. So now once the entire web services has been built, now as we know here, currently we are working on the entire Docker part, right? Now the files for Django admin has been created, or there's going to be defined here owned by the root user, because in that container runs as a root user itself. And for changing the ownership, we can define the sudo change ownership, and we can change the ownership back to the root user itself. So let's do that. Now for changing the ownership, we can execute the command set as ch owners. Basically here using the admin privileges of sudo, we can use the ch owner for changing the ownership, and then we are changing the ownership back to the user. Now, this has to be defined here. For example, currently, if we have connected via Ubuntu, because currently we are using with the platform for EC2, where we have connected by the name of Ubuntu user itself, right? So here we can change the username, define. Currently, we are running Docker. Suppose if we are using this entire setup on your Mac or Windows, then we should have the ownership of all the files, which includes the files generated by Django admin. Now, to see the list of the files, we can simply use the ls-l command to see the entire list of all the files that has been generated. And for seeing the entire ownership of all those files, we can simply use a command as ls, and then we will be able to see the list of all the files along with the ownership that has been defined by using the command as ls space -l, especially when we are using the Windows or the Linux systems. And now we are going to connect to the database. Now in this section, we are going to connect the database server with the Django application that we deployed. And in the project directory, we have to simply edit the settings.py file. So where we are going to replace the entire credentials for the current database that we have defined. So let's do that. So for editing the file here, again, we can make use of the same nano editor. Depending upon whichever editor we are comfortable with, we can make use of V editors or nano editor depending upon the requirement. And here we have to specify the path for compose example because that is what we have created. And then we can define the file path as settings.py. Here we have to open this settings.py file. Now this contains the entire default configuration that is going to be used by the Django application. So when we are defining the entire security component, we have to make sure that we are going to allow the host to all or to specific IP of the server that we want to allow the access to. So basically in production servers, we don't keep it to all, but again, as a part of a hands-on to see this up and running, we have defined this to all. So all we can define by default, the file is going to have no values defined. So we have to add this asterisk value under single quotes that is going to give the access to all the hosts that on which we want to access Django application. Then we can scroll down and we have to locate the section for database. So basically in database, we'll be having the default parameters defined where we have to configure this based on the application and based on the Docker file that we have created. So this is going to be the engine that we have used for Postgre. Then we have to define the name, username, password that we have used, the host, that is the DB that we have created while we were working on the Docker Compose file. And this is a port on which we have opened this database engine on. And once we are done defining all of these attributes, we can save this file and then we can come out of it. Again, just to cross-check if we have defined the same file, always have a cross-check because again, it is a common issue that sometimes we may forget to save the file even after writing all the changes. So that's to make sure we have all the changes defined. We can again open the save nano editor. We can cross-check for all the components. We have allowed the host and the database configuration is also defined. So once we are done, we can come out by pressing Control X. And at the end, now we have to run the command as sudo docker-compose up. So basically, this is going to simply turn on the entire Docker Compose section, which is currently going to launch the application so that we can make use of it. So once we have this one deployed, then we can come to the browser. If we are deploying this on a local machine, then we can simply choose any browser on which we want to open up the application. For example, we can come to the browser and we have to type in localhost. In case we are deploying this on a local machine, we can define localhost, and then we had to install the application on port 8000. So here we can define the port number, and this is going to open the application in the browser. Like we can see here, this is a default Django application that we have successfully deployed by using Docker Compose. And if we are deploying this on any of the cloud platforms, and as we had defined the host to all, so we can specify the IP of that particular instance that we deploy, and then we can add the port as 8000. So this is going to open the application in the browser. And now if we want to customize it further, we can easily do all the customization as per the requirement. All right, so to see how exactly we can stop the application, so we can come back to the console. Now, first of all, easiest method is to simply kill off the application by simply pressing Ctrl+C, and this is going to simply kill off the application right away, as in a force stop. So although this is quicker, but again, this is not recommended when we want to stop the application. So if we want to stop the application, then we can use a simple command called as Docker Compose down. Just like we have used Docker Compose up, so we can use Docker Compose down. Basically, it's a more elegant way to shut down, which basically switches to a different shell and run Docker Compose down from the top level of our project directory itself. Let's say once we have the application up and running, let's say we run the application again. Now, if you want to stop the application, we have the application up and running, we can simply use a command such as Docker Compose down.
What is Docker Swarm? So a Docker Swarm is a technique to create and maintain a cluster of Docker engines. Okay. Now, what I mean when I say a cluster of Docker engines is that there will be many Docker engines connected to each other, forming a network. Okay. Now, this network of Docker engines is what is called as a Docker Swarm cluster. And as you can see from the image over here, this is the architecture of Docker Swarm cluster. Okay. And there will always be one Docker manager. In fact, it is the Docker manager which basically initializes the whole swarm. And with the manager, they will have many other nodes on which the service will be executing. So there will be times when the service will also be executing at the manager's end. But basically, the manager's primary role is to make sure that the services or the applications are running perfectly on the Docker nodes. Okay. Now, whatever applications or services that are specified or requested, they will be divided and they would be executed on the different Docker nodes. Now this act is called as load balancing, right? The load is balanced between all the other nodes. So that's what happens with the Docker swarm, and that's the role of a Docker managers. Now let's go and see what are the features of Docker swarm and why it's really important and why it's the go-to standard in the industry. That's because with Docker Swarm, there is high availability of these services, okay? It's so much so that there can be 100% high availability all the time, right? That's what high availability means, right? So how is that possible? That's possible because at any point of time, even if one node goes down, then the services which are running inside that node, they can start, the manager will make sure that that service is started on other nodes, right? So the service is not hampered. Even though the node may be down, the load is balanced between the other nodes which are active in the swarm. So that's what a Docker manager does, and that's why the Docker manager is heart of the Docker swarm cluster. Okay, that's one feature. The other feature is auto load balancing. Now again, the auto load balancing is something that is related to high availability itself, where at any point of time, if there is any downtime, at those times the manager will make sure that those services are not stopped and they are continued and executed on other nodes, right? So that the manager would do. But along with that, load balancing also comes into the picture when you want to scale up your services. Supposing you have say 3 applications and you have 3 nodes for that, right? So including the manager, you will have 4 nodes, because manager is also technically a node. Okay, so you have a manager node and then you have 3 different nodes. So in this case, the 3 services which you deploy, they will be running on 3 different nodes. And if you want to scale them at a later point of time, let's say you want to scale them up to 10 services, then at that time the concept of auto load balancing would still come into the picture, wherein the 10 services, they would be divided between the nodes. All right, so it would be such that you will have probably 3 services running on one node, 3 more services running on the other node, and the remaining 3 services on the other node. And the one service that is left out, that would sometimes be run on the manager, or it would be load balanced on some other node. Okay, and the best part with Docker is you don't need to do any load balancing. It's all done on its own, right? So there's an internal DNS server with which the Docker manager manages, and the DNS server makes sure that it allocates the DNS server makes sure that all the nodes are connected in the cluster, and whenever any load is coming, it would balance the traffic between the different nodes. Okay, so that's one big advantage with auto load balancing. And another feature is that of decentralized access. So when we say decentralized access, it means that we can access these managers or these nodes from anywhere. So if you have these managers or these nodes hosted on any server, then you can simply SSH into that particular server and you can get access to that particular manager or node. So if you access the manager, then you can control what services are being deployed to which nodes. Okay, but if you log in or if you SSH into the server which is a node, then you can control or see which service is running inside that node itself. Okay, but however, you can't control the other nodes if you're inside a node. Only the manager node can do that for you. But anyways, all that we need is to log into or SSH into a Docker manager and control which services are running, right? So that's all we need. That can happen this way. And of course, it's very easy to scale up deployments. So I also spoke about that earlier, where you can, if you want, let's say you already have 10 services, and if you want to suddenly scale it up to 50 or say 100 services, then what you can do is you can just buy a few more servers and deploy those 100 services into those servers, right? So it's a very simple functionality where you can do it with just one single command. One single command is all it takes to scale up your number of services or applications to the desired amount, right? And you will have multiple services running inside that same Docker node. So each node can have will probably have 10 or 15 services running, and it basically depends on the number of nodes that you have. But ideally, you shouldn't do that. You cannot have too many services running inside the same node, because that causes performance issues, right? So all those things you can do. And finally is this concept of rolling updates. And rolling updates is by far the most catchy feature, because when we say rolling updates, what we mean is these applications or services which are running, right, they will have to be updated at one point of time or the other. Down the line, you will have to update it. So at that time, what will you do? You cannot, update manually in every single machine, right? If you don't have Docker, if you have hosted your web servers on either virtual machines or on actual web servers, then what happens? At that time, you would have to go to each and every system and then probably update it everywhere, right? Or you might have to use other configuration management tools. But with the help of Docker, you don't have all those problems. You can simply specify you can use the rolling updates functionality for that, and you can specify a delay. So in the delay, it would update one service or each service which is hosted or deployed inside every node. It will update each of those services one after the other with a delay of the specified amount of time, right? So even when one service is getting updated, the other service is not down, and because of that, there is high availability. Since the other service is still up and running, there is no downtime caused, right? So you can be sure of that. In spite of and rolling updates are very simple also. So it's just one command and you're all done. These are the benefits of Docker Swarm, and these are reasons why you should implement Docker Swarm in your organization if you have a massive web application, web service which is deployed over multiple servers. So that's the big benefit with the Docker Swarm, right? So moving on to the next slide. Okay, now it's time for the demo. Okay, now let's see how to achieve high availability with Docker Swarm. Before I get started with the hands-on part where I would be showing you on my virtual machines, I want to first go through what I want to show you with respect to high availability, okay, and how to achieve it with Docker Swarm. Okay, so first of all, in terms of high availability, the ideal definition is that you have the application or the services deployed in each of the web servers. Okay, now look at this architecture where I have 2 nodes and I have one manager. Okay, and I have Docker engine running on each of these nodes, and each of these are all highly available. Okay, so at this point of time, I don't have any problem, okay, with respect to any services, and my application is deployed in each of these servers. Okay, each of these servers or each of these nodes. So at this point of time, if I try to access my browser, and if I try to access this port number in my browser, I can see my application running. Okay, now this is the application which I will be showing you my demonstration on, and this is also the application which I executed a couple of sessions back. Okay, the link of this application, the demo of this, I will share it at the end of the session. Okay, but don't worry about that because this session is all about Docker Swarm. So getting back, what I was saying is, since these are hosted in each of these servers, I can access the application that I've deployed on each of these machines. But look at this scenario where my service is only hosted on one particular node this time. Okay, I have the other services connected to my cluster. Okay, this is my Swarm cluster where it's all connected, but the application is not hosted on these 2 nodes. So at this time, can you guess what happens? Does anybody think that the application will not be accessible on these machines? Can anybody tell me that? If you people think like that, can you just well, if you think like that, then you people are wrong, because since it's connected in a cluster, these Docker, whatever is hosted on one particular node, they can also be accessible on other nodes. So even in spite of the fact that these servers do not have the application running, the web port on which this application is hosted, right, this port number will be internally exposed to all the nodes inside this cluster. And since the port number on which it's running over here, that is 4200, since that is exposed to the cluster, then in all the other nodes in that cluster on the same port number 4200, the application would be accessible, right? Same thing with even this particular node. So on 4200, you can access this Angular application. This is the second scenario of high availability. But this is just a scenario where you don't have your application. This is the third scenario where high availability is actually being implemented. Okay, now you have a scenario where you have your 3 nodes and 2 of your nodes or 1 of your nodes goes down. Okay, so this time you don't have your application itself. Forget about the fact that Docker is not, the application is not hosted. Forget about that fact. Think about this scenario where your node is not accessible. It's down for some reason, for some natural calamity. At that point of time, do you think you can't access it? You can. Well, that's because the nodes would be connected inside the Docker cluster, the Swarm cluster, and the port number would be exposed. So because of this reason, you would still be able to access, you would still be able to view the Angular application on these servers, right? Now that's the benefit of having a Docker Swarm cluster. All right, so and this is how the high availability factor is achieved with the help of Docker Swarm, and this is what I'm going to show you in my hands-on part. But before I go to that part, let me just quickly run through these Docker Swarm commands. Okay, so these commands is what I will be using extensively in my demo. And these are also the most common Swarm commands that you need to use when you're starting with your Docker Swarm cluster. Okay, so first of all, to initialize the Swarm, you use this command. You say Docker Swarm, and in it, you use double flag and say advertise adder. Okay, followed by that, you specify the IP address of the manager machine, or that same machine where you're starting this service. Okay, so the when you do this, whatever IP address is specified here, that particular machine would be acting as a manager. Okay, it is also ideally the same machine on which this command is running, right? The IP address of what you specify here, it should be the same machine. So that's the thing, and whenever you issue this command, this swarm would be initiated along with the manager being this particular machine which has this IP address. Okay, that's what happens when you do when you initialize the swarm. And of course, when you initialize the swarm, you will get a token. It's more like the entry key using which your other workers can join your Docker cluster. Okay, but getting back to our Docker swarm, once you've initialized your swarm, you can list the different services that are running inside that swarm. Okay, you can list the different nodes that are running. You can check which all nodes are connected to your swarm cluster. You can check what all tasks of services are running. You can check, you can create a new service as in a new container, and then you can also remove that new container, and you can scale them up using these commands. Okay, so use the Docker service ls to list down the services that are running. Then if you want to drill down on one particular service and check in which node one particular service is running, then you can use the Docker service ps command. Okay, so it lists down that process when you issue it with the name of the service that you want to check for. And then if you want to create a new service, then you use this command of Docker service create. Then you specify the name of the service, in fact, and you got to specify the image which you want to use to build that particular container and service. And finally, to remove a service, you use this Docker service rm followed by the name of that particular service. And finally, if you want to scale your services, then you can use this command, Docker service scale, and then you can just specify the name of the service, and you can specify the number that you want to scale it up to. Okay, so in this case, if I had the service which had 2 replicas, then by simply specifying is equal to 5, I would have scaled it up to 5 different replicas, right? So these are the swarm commands which are applicable from the manager end. And now going back to the node end, if you want to list down all the nodes that are there in your swarm, then you can use the Docker node list. Okay, do note that here it was all about the different services. Okay, and these commands cannot be run on the Docker nodes. Okay, they can only be run on the Docker managers. Okay, so here you have the Docker node ls, which lists down all the managers and the nodes. And then if you do a Docker node ps followed by the service which you want to in fact, if you do a Docker node ps, it basically lists down all the containers or services that are running inside that machine. Okay, now this command, again, it can be run on even nodes. Okay, this cannot be run on all the nodes. So the node ls, it can be only run on the manager. And finally, if you want to remove a particular node from your service, from your cluster, then you can run the command Docker node rm followed by the ID of that particular node. Okay, but at times you might not be able to do that. That's because the node might still be connected to the cluster. So in that case, what you have to do is you have to use the docker swarm leave command. When you use this command, you can get, if you run these commands from the nodes, then the nodes would leave the cluster, and then you can just end your cluster, right? And finally, if you can just run the docker swarm leave from the manager end, then you can end the whole cluster itself. So even the manager would leave, and manager would ideally be the last instance to leave, right? So when there are nodes there, you cannot have the manager leave with the nodes being present. So that's one thing. And at times you would be given a error saying that you cannot leave the cluster because you're a manager. So at that time you can use the force flag. Okay, so at this time you're as a manager, you can leave the cluster and your cluster session ends there, right? So these are the top commands which are in question. So yeah, I think it's a time for me to go to my session. Okay, it's time to go to my hands-on session where I'll open up my virtual machines. So guys, please confirm if you can see my virtual machine now. Okay, can you see my virtual machine here, guys? Okay, great. So for the demo purpose, I have 3 different VMs, okay, and inside these VMs I have 3 different Docker engines, and I will be basically using 2 of the Docker engines as my node, and I would be using one of them as my manager. Okay, so this is my manager 1, as you can see over here, and this is the password. Okay, so this is the manager 1, which I'm going to start the service, the whole swarm and the services from here. Okay, and if I go here, this is my worker 1, as you can see over here. All right, and this is worker 2. Now in these 2 nodes I would be executing my applications or services. Okay, so first of all, if you want to create the swarm service, then you have to run the command docker swarm init advertise adder followed by the IP address. So the IP address of this manager machine is 192.168.168.1.100. Okay, so great. So my swarm is initialized, and as it says, if you want to add a worker to this swarm, then you have to run this token. Okay, now this is the token. Let me copy this token and run this at the node's end. Okay, so I'm going to go to worker 1, I'm going to paste this token, and when I hit enter, it says this node has joined the swarm as a worker. Now let me verify that. If I go back here and if I issue the command docker node list, then it says that I have one manager, which is myself. Myself is being indicated by this asterisk, okay, referring to this own system, which is also the leader. So it says manager status leader, correct? The status is ready, and availability, it's active. And recently I added the worker node, so it says even this is available. Now let me go to the third VM and enter the token here, and it says even this node has joined as a worker. Now if I go back to the manager and run the same node list command, you can see that the worker 2 has also come in now. Okay, now that's because I have I issued the join command at my node end. So I'm gonna just clear the screen, and now we can start creating our services. So first of all, if you want to create a service, the command is docker service create followed by the name of the name flag. Okay, so you specify the name of the service that you want to give. Let's say I want to say Angular application. I will say this, and followed by this we should specify the name of the image. So the image name is demo app 1. Okay, and along with this I also want to specify the port number on which I want to do the binding, because the Angular application which is being hosted in one particular port number inside my container, that has to be mapped to my browser port number, right? If I want to access it on my web browser, that is this Firefox. So for that reason I'll use the -p flag, and I'm going to say 4200 of the browser port should be mapped to 4200 of my container port. So this is the command. Okay, now this command simply creates one instance of this service Angular app, which will be built from this image demo app 1. Okay, and it would expose the port number 4200 from the container to the port number 4200 of my browser. So let me hit an enter, and let's see what happens. We got to give it a few seconds because it's a big application, right? Yeah. So now let's do a Docker service ls. Okay, you can see that one Angular application is created. Now this is just a warning. Okay, you can ignore this because this is the confirmation that your service has been started. Okay, you can ignore such warnings. It's this what you need to look for. Now if you get this image ID, then it means that your service has been created. Okay, this is the service ID basically. So as you can see here, right now the mode is not replicated. There is just one single instance, and the same thing you can see over here. It says replicas is one, the same name which I specified, the image that it used, and the port number where it's active right now. Okay, now let me do a docker ps command from the manager and check if this application is running inside this node. So yes, it says that this application is running over here. Now parallelly, let me go to my worker 1. Okay, this is also connected to the same cluster, so I'm going to do a docker ps over here. You can see that I have got no output, so this means that there is no container that has started inside this node. Okay, this is the worker 1. Similarly, let me go to worker 2 and say docker ps. Again, there is no output when it with this. Okay, it says no container has started. Now if I go back to the manager and verify, I can verify in which node this application has started, and the command for that is docker service ps followed by the name of the application, that is Angular app. So when I hit enter, you can see that the name of the application is this is the ID and the image that was there and the node where it's running. So it's hosted in the manager 1. In my system itself, it's hosted. Okay, primary system. The desired state is running, and the current state is running about a minute ago. Okay, now let me go to my browser and access localhost 4200. Now as you can see, this particular this is the Angular application which I've hosted. Okay, now I've explained what this application is about in one of my previous sessions. I would request you to go to that video and get more details about this application. Okay, I want to just quickly get back to my session here with respect to Swarm. So since I've started my application, I can access it over here. Now as I explained earlier, all the nodes in your cluster can see the application that you've started, right? I explained that earlier, right? Now let's verify that by going to the other nodes. So in spite of the container not being hosted on this particular node, I can get the same Angular application over here, because the port number would be exposed internally between the different nodes in that cluster. Same thing with my Docker worker 2, right? So if I do, well, I've already done a docker ps. You can see there's no container here. So let me just quickly go here and do a localhost 4200. Yeah. So you can see the application is hosted even on this particular node. Now this is good news. So this means that your application is successfully hosted on the cluster and it's accessible on all the nodes, right? Now I'm going to do a docker node ls. And yeah, we have 3 different nodes. It's the application executed over here. If you want to verify that, you can also do this. Docker service ls. Okay, it's just one application, and if I do ps with the Angular name, with the image name, it says it's running here. Great. This is one of the scenarios which I wanted to show you. Okay, but I want to show you another scenario where the application can be hosted on multiple nodes at the same time from the manager. Okay, and the command is not going to be too lengthy also. Okay, so last time what I did, I basically executed the container at one end, right? So that was executed only over here. Let me, but before I go to the next scenario, let me remove this service. Okay, so the command to remove the service is docker service remove Angular app. So when you get this output, it basically means your application has stopped, the deployment has been removed. So if I try and refresh this 4200 port, it says it's unable to find anything there. And similarly, you won't be able to find it on any of the other nodes also, because the cluster itself does not have access to this particular Angular application right now. But now let me go back to what I was talking about, the second scenario where I can start the same service on all the 3 nodes. Okay, the same Docker service which I created, I'm gonna issue that with a slight modification. So after my port options, after this flag, I'm gonna use this flag of mode. Okay, I'm gonna say mode is global. Now with the help of this flag, the application which I'm deploying, which I'm hosting, this will be basically deployed onto all the 3 nodes of mine. Okay, I can show you that by first hitting enter, and let's see what the status comes. Okay, so it'll just take a few seconds because it's being deployed to multiple nodes, right? That's the only thing. So yeah, again, the service has been created. This is the service ID. Now let's do a docker ps and check. And there's one instance of this application running in this same manager. Okay, like before, it's running over here also. And let me verify that if it's running over here this time by running the same docker ps command. Yes, as you can see, 17 seconds ago, this application was created. And similarly, if I go to the third VM and run the same docker ps command, it's opened over here also. This means that the application this time was deployed to all the 3 nodes parallelly. Okay, we can also verify that by going to the 4200 ports of each of these machines. So this time the app is back up, right? It's running again. Same thing, I can refresh this, and I will see the application coming here. It's just connecting. And similarly, over here also, I would have the same success scenario. Okay, it's connected. Great. This is the movie rating system that has been deployed across all the 3 VMs. Now let me verify this. Give you the way you can confirm this is by running the docker service. First, you do the docker service ls command. Okay, so with this you have the mode as global. Okay, and it says replicas is 3 of 3. That's because there were 3 different nodes connected, and since it's deployed to all the 3, it says replicas is 3 of 3. Correct? The only difference last time was it was 1 out of 1. This time it's 3 of 3. And to give you drill down further into details as to if it's running on each of these nodes, we can use the command docker service ps followed by the application name, that is Angular app. So when I hit enter, as you can see, it says there's 1 instance running on worker 1, 1 instance running on manager 1, and the 3rd instance running on worker 2. Great. So this is what we this is the real fun part with Docker, right? With one single command, you can do all these things. So let me also, we just verified this, right? Now comes the concept of high availability. If any of my node goes down, then what happens? Will I still get access to my application over there, right? That question needs to be answered. So let's see if that is gonna happen. So for that, let's say my internet of my worker 1, right? This is my worker 1, right? Let's say my node is down, and to get my node down, I'm just going to do a disconnect. Okay, so right now it's not connected to the internet, and if I go here and do a docker node ls command, which would list down all the different nodes in my system, you can see that the status for worker 1 is down. Okay, all this time we were getting ready. That's because the status was that's because the server was up. But since I turned off the internet in my worker 1, it's telling status as down. But in spite of that, I won't have any problems accessing any application. Okay, so even though I refreshed it, you could see that on this port number I could access this application. That's because in spite of the fact that this node is connected to the cluster, I can access this, right? And the very fact I can do that is because all the machines or all the nodes in the cluster will have the port number opened, right? It would be exposed between all the other nodes. The same concept I explained during my slides, right? So in spite of the fact that my node being down, I could do this. Now this solves one aspect of high availability, right? So in this case, even if I have like multiple nodes going down, then some of the nodes which are good enough, which are healthy, those can those can satisfy all my services for a temporary period of time. But of course, I'd have to bring up my nodes again, right? So this is how one high availability can be accessed. That's one thing. So let me just go back to my worker one and enable internet again. Okay, so that I can continue with my demonstration. Okay, I'm connected now. So if I do a docker node ls again, and let me just refresh this. Yes, now it says the status is ready. Great. I'm going to just clear the screen. Now since I ran last command where I did it in global mode, I had an instance running on each of the nodes, right? So this time, let's say I don't want to do that. I have 3 different nodes, but I want to host the application only on 2 nodes. Well, I can do that also. I can set the number of replicas of my service over there in the command where I'm starting my service. So let me go back to that start command and modify it as per our needs. So I'm going to remove this mode global. Once you remove this flag, you can add replicas and set the number of services you want. Okay, but before this I would have to remove the service, right? Sorry, my bad, I just forgot to do that. So let's say docker service remove Angular app. So I've removed it now, and I'm going to restart the service. Okay, so now let me start modifying this start command. So I'm going to remove this global mode, and I'm going to say replicas, and I'm going to set the replicas to 2. Now this would indicate that I will have 2 running instances of this service between the 3 nodes. Okay, it will load balance between the 3 nodes, and the manager will choose on its own. It will deploy the application on 2 of the best performing nodes. Let's verify if that's happening. So yeah, the success, so it's successful. We can verify that by doing a docker node ps. Okay, this would basically list down if the container is present in this node. Yeah, there is one container or one service running over here, but to get a detailed to get more details, let's run the docker service ps command. Okay, let me just clear the screen out and run that command again for you. So when I do this, it says that 2 instances have been created, right? One has been started on my worker 1 and the other has been started on my manager 1, right? 2 instances between the 3 nodes. Let me also do this for you. Let me do a docker service ls to confirm the replicas, right? It says the mode is replicated mode and it's 2 out of 2, correct? So no hassle anywhere here, right? So if I refresh it, I would still have the Angular application hosted. This is worker 1. It's anyways hosted over here, so I don't need to verify anything. But to give you a confirmation, I can do that also by running the docker ps command. So the docker ps would list down all the containers and services running in this particular node. So when I hit enter, I have one entry here, okay, for one service that got started. However, in this node 2, the worker 2, I do not have the application, right? So let me verify that by running the command docker ps. Okay, it's not running here, there's no service, but in spite of that, the application would be running here. So that's the concept of Docker cluster, wherein all the nodes will get access to what's there in the Docker cluster. So that's the fact. And now comes the concept of scaling up and scaling down, right? this is one thing which a lot of people have this doubt, because it's not always done, right? In spite of having a cluster where you have only 3 nodes, we can scale it up to any number of services that we want to. So right now I have 2 different services, right? If I do a Docker service and if I do a ls, you can see that there are 2 services running. Now if I want to scale it up to let's say 5 services, I can do that too. That would also happen. And the simple command to do that is docker service scale, and we should choose the application, and we have to set the number we want to scale it up to. Let's say I want to scale it up to 5. So in this case, 3 more services would be added on to this cluster. Okay, I'm going to go ahead and hit enter. And yeah, so it says the application has been scaled to 5. Now let me run the same docker service list command, and when I do that, it says right now 3 replicas have already been started, and let's give it a time. Let's give it a few minutes so that it can start on all the other nodes. Okay, in the meanwhile, I'm gonna I'll clear the screen first, and I will do a docker service ps and Angular app. This would tell me on which nodes my applications are going to get deployed. So it says out of the 5 on worker 1, there on 2 of those services will be running on worker 1. Okay, as you can see here, service number 1, this is the service number 2, right? This is running on worker 1, and again on worker 2 there will be 2 services running. You can see these 2 services over here, worker 2, and then on manager 1 there is 1 service running. This is because I scale it up from 2 to 5. Now let me do a docker service list command to check if all my replicas are up. Yes, so we've given sufficient time, and by now all the services are up and running. We can check it over here, but we don't need to because we know for sure that it's going to be hosted anyways. So this is good news, correct? So yeah, this is how we can easily scale up, we can easily scale down, and we can achieve a lot of comfort by using Docker, correct? So yeah guys, so this brings an end to my session, to my hands-on session. I've also showed you how to scale up and scale down. I've showed you the concept of high availability. Also the whole concept of load balancing happened here. But there is one more thing which I also want to add on from my side. Okay, and that is, why will services be executed at the manager's end, right? A manager ideally is not supposed to do any work, right? That's what the workers are for. The manager just manages. So this is a question that you can come up with. It's a very valid question. So if I want to do that, then I can again run just one command and enable that functionality also. Okay, and the command to do that is, there is docker node update. I can use the availability flag here. Okay, and I can say drain, and I can choose which node I want to drain. So when so drain basically stops allocating services to that particular node which is specified. So over here, if I specify manager 1, then, and if I hit enter, then from now on the service which is allocated over here, right, this would shut down and a new service would be created on either worker 1 or worker 2. That would happen. Or if I don't want to drain my manager, I can also drain one of the workers. I can either drain worker 1 or worker 2. But let's say for in our case, we want to down the manager. So I can do that by simply hitting enter over here. And yes, we've got this as the return value. That's great. So now if I do docker service ps Angular application, which is the same command, you can see that the manager 1 has been shut down. Okay. And there has been an additional service that has started on worker 1. So right now there is worker 1 running is 1, 2, and 3. So 3 running on worker 1 and these 2 are running on worker 2, right? So I'm going to clear the screen here and re-execute the same command and also show you what happens now when I do a docker node list. Okay, the node list will basically list down all the nodes connected inside that cluster, right? So I'm going to do a docker node list, and over here this time you can see that for my manager 1, which is this ID, the status is ready. However, availability is not active, it is drained. Okay, even though it's the leader, it is drained. So from now on, if I scale up the service or whatever I do, even if in case of high availability, at that time I cannot no services will be allocated to my manager unless and until I remove the drain. Okay, I can remove the drain by again specifying the command of active. So let me run that command and show you that. So here, instead of saying drain, if I change the availability to active, then I can start allocating services to my manager also. So if I hit enter, it says I've got manager 1 as the return value. And again, if I run the same docker node ls command, availability is there. And from now on, whichever, if I scale up only at that point of time, will my manager start getting resources. So these would what are existing, right? This will not get allocated to my manager. In case if there's any downtime, if any of my node goes down, then at that time manager 1 will get access, right? And yeah, that would happen. So this is the simple demonstration which I want to show you. It sounds simple, but this solves a lot of industry issues. Correct? It's one of the best tools I've worked on. Docker and Docker Swarm is one amazing technology that also I've witnessed. So I hope you've also understood what kind of what I'm talking about over here. Correct?
Let us understand what can one use Docker for. The first advantage of Docker is its fast, consistent delivery of applications. Docker streamlines the development lifecycle by allowing developers to work in standardized environments using local containers, which provide your applications and services. Containers are great for continuous integration and continuous delivery workflows. Let me explain you this with an example. Now, developers write code locally and share their work with their colleagues using Docker containers. They can use Docker to push their applications into a test environment and execute automated and manual tests. When developers find bugs, they can fix them in the development environment and redeploy them into the test environment for testing and validation. When testing is complete, getting the fix to the customer is as simple as pushing the updated image to the production environment. The second advantage is the responsive deployment and scaling. Docker's container-based platform allows for highly portable workloads. Docker containers can run on a developer's local laptop, on physical or virtual machines in a data center, on cloud providers, or in a mixture of environments. Docker's portability and lightweight nature also makes it easy to dynamically manage workloads, scaling up or tearing down applications and services as business needs dictate in real near time. The third important advantage is that Docker can be used for running more workloads on the same hardware. By now, you must have figured out that Docker is lightweight and fast. It provides a viable, cost-effective alternative to hypervisor-based virtual machines, so you can use more of your compute capacity to achieve your business goals. Docker is perfect for high-density environments and for small and medium deployments where you need to do more with fewer resources. Moving on, let us talk about another important topic, that is Docker Compose. Docker Compose is a tool for defining and running multi-container Docker applications. With Compose, you use a YAML file to configure your application's services. Then, with a single command, you create and start all the services from your configuration. Compose works in all environments: production, staging, development, testing, as well as continuous integration workflows. Using Compose is basically a three-step process. The first one is where you define your application's environment with a Docker file so it can be reproduced anywhere. The second one is to define the services that make up your application in Docker compose.yml file so they can be run together in an isolated environment. And the third step is to run Docker Compose up and Compose starts and runs your entire application. Now, the next question that arises is that what is the difference between Docker and Docker Compose? So, what if you need to deploy containers? Where do you begin? You could certainly do this from the command line, deploying each container via a long string of command options every time. Or you could make use of a tool that allows you to carefully construct the deployment within a configuration file and then deploy the container with a simple command. So basically, the Docker file is a text file, whereas the Docker Compose is a tool. Now, your Docker workflow should be able to build a suitable Docker file for each image you wish to create, then compose to assemble the images using the build command. As I've already mentioned before, the Docker Compose basically defines the services that make up your application in a Docker compose.yml file so they can be run together in an isolated environment. So in short, you use a YAML file to configure your application's services. Then with a single command, you create and start all of the services from your configuration. By default, Docker Compose expects the name of the compose file as dockercompose.yml or dockercompose.yaml. Now that we know the difference between Docker and Docker Compose, let's move on and talk about WordPress with Docker. Before we get to this topic, we have to firstly understand what is WordPress. WordPress is a free and open source blogging tool and a content management system based on PHP and MySQL, which runs on a web hosting service. Features include a plugin architecture and a template system. WordPress is extremely popular and used by more than 22% of the top 10 million websites as of August 2013. WordPress is the most popular blogging system in use on the web with more than almost 60 million websites. You can use Docker Compose to easily run WordPress in an isolated environment built with Docker containers. But for that, you'll have to firstly define the project, build the project, and then finally bring up WordPress in a web browser. Now we will move on to the demo section and understand how to run WordPress with Docker. So we're going to learn how to run WordPress with Docker in Amazon Web Services. So I'm going to click on the services and I'm going to click on the EC2 service. So this will redirect me to a page where I can view all my instances, my images, all of that on the left-hand side. And I'm going to click on the instances option on the left-hand side. So on this page, I can view the instances that are currently running. But for this demonstration, I'm going to launch a new instance. That is, I'm going to create a new instance. So I'm going to click on the right-hand side orange button that says Launch Instances. Now this will redirect me to a page which says Choose an Amazon machine image. For this demo, I'm going to click on the Amazon Linux 2 AMI machine. And I'm going to let this be on the t2.micro instance type, which is free. Once that is done, I'll be able to configure my instance details. So here I'm going to just create one instance. So I'm just going to let that be 2 and I'm going to move on to adding storage. This is going to be the same tool and I'm not going to add any tags. So I'm just going to click next. Here I can select the type of security group. I'm just going to select an existing security group and I'm going to review and launch. And I'm going to click on launch button. So now I'm going to select an existing key pair, that is P1, and I'm going to launch instances. Now I'm going to click on the instance that has been launched. This will take some time for it to run. Now I'm going to use Putty, which is the most popular free SSH client. It basically supports SSH, Telnet, and raw socket connections with good terminal emulation. It basically supports public key authentication. Here I'm going to now type in the host name. Now before that, let us name our instance. I'm just going to name this Docker WordPress. Now I'm going to select this instance and I'm going to copy its public IPv4 address. Now I'm going back to my Putty file. I'm going to paste this address. Now this is an extremely important step. Now the host name should always be ec2-user @ the IP address, the public IPv4 address. Okay, so this is really important. I'm going to load the save session, that is the MySQL server session, and save it. Now, once I save this, I'm going to go to my SSH and authentication, and I'm going to load the private key. So that's done. Moving on, I'm going to just keep the seconds between keep alives to 30 because I don't want my session to turn inactive after some amount of time. So I'm going to do that. Now we're going to move back and check ec2-user at the rate. So the host name is good to go. And we're going to save the session in MySQL server session. So with this, I'm good to go. I'm just going to click open. And this will redirect me to an Amazon Linux 2 AMI machine. So now we're good to go. Now that the server is active, I will install Docker and Docker Compose. I'm going to click yum install docker-y, and it says the package Docker has been already installed and it has nothing to do. But if you haven't installed it, it's going to install. Now, if you're creating the instances for the first time, it's going to install all of these packages from the beginning. Now I'm again going to use the sudo curl -l, and I'm going to paste the link from where the Docker Compose package will be installed to my Amazon machine. Once these packages are installed, we have a few more steps until the entire procedure is completed. Please do follow along. Now I'm just going to check the Docker version we're currently working on, and I'm going to do this by typing the command docker -version. So currently we're working on the Docker version 19.03, and then I'm going to start the service of the Docker by typing in the command service docker start. And this will redirect me to this particular folder and start the Docker service. I can also see the status by clicking on Docker service status. Okay, great. Now we will check if the Docker Compose has been installed. Because this file exists already for me, it's going to say that the file exists. But as I've already mentioned before, if you are new and you're creating this for the first time, then you will not get any sort of alerting message. Now that we have set up Docker Compose 2, we'll just check the version. And for this, I'm using the command docker-compose-version. And as you can see that we are currently working on the Docker version 1.25. Now both Docker and Docker Compose are ready. Okay, now moving on to the main part. As I've already mentioned previously in the session, the first thing that we'll have to do is to define the project. So the first thing that we're going to do is we're going to create an empty project directory. So I am going to make a new directory that says Edureka, and I'm going to move into this directory. Now this directory is the context for your application image. So the directory should only contain resources to build that particular image. So this project directory that we've created contains a docker compose.yml extension file, which is complete in itself for a good starter WordPress project. You can either use the .yml extension or .yaml extension. Now I'm going to create a file called docker compose.yml with the YML extension. So here I'm going to add a piece of code that is really important, and I'm going to explain this code too. So inside the services section, we've added the first service definition, which is named DB, that is the database. And there's another section too that is called as WordPress. As I've already mentioned before, the Docker Compose helps in creating multi-containers. So currently there are two containers in the service, that is the database container and the WordPress container. And both of these containers are services. So this particular service, that is the DB service, is associated with the MySQL image and therefore providing the needed MySQL database instance. Now we have set the MySQL to version 5.7 here. Now, if you're restarting your MySQL, the volumes will help you regain the credentials. Furthermore, we need to set the following environment variables, that is the root password, database, user, and password. Now, moving on to the second service, that is the WordPress. It directly depends upon the database service. Also here, we're using the WordPress image. You can specify to use any version of WordPress, but I am going to mention the latest one. Furthermore, again, we are using the environment section to set values for 4 environment variables, that is the database host, database user, password, and name. Now, the value which is assigned to the WordPress database host needs to be the identifier of the database service. Now, the value of the environment variable WordPress database name needs to correspond to the value which has been assigned to the environment variable MySQL database of the database service. So you can see here the database service also has the value WordPress. Furthermore, the environment variables WordPress database user and password needs to contain the credentials of the database that is previously set via MySQL user and WordPress database password in the database service. So these two are same again. Finally, we are to make sure to map internal port 80 to external port 80, 81 or anything, so that the WordPress will be accessible via that particular port. So we're going to copy this and we are simply going to paste this in our docker compose.yml extension file. Now the next command is the docker compose up-d, that is detach, will help you create containers in the background. And this will also help in creating a network of Dockers. Now, this is also up to date for me, but if you're new, as I've already mentioned before, the download should happen accordingly. This entire operation will help you pull multiple containers, so this is really important. Now, moving on, we will check the number of containers using the command docker ps. Now, what we can do is we can go on to our security, scroll down and give permission for our port 8081. We'll have to just edit the inbound rules. Add rule, custom 8081, scroll down and save it. Now I'm redirected to my page where my active instances are running, and I'm simply going to click on my instance and going to copy this particular address, going to my web browser. And since we mentioned the port number 8081, I'm going to click on that. And you can see that WordPress is activated. I'm going to click on English. I'm going to continue. I'm going to add in all of the information and credentials that are required. And as you can see, I made an account, I installed WordPress, and now I am inside my own WordPress account. Now let's move on to the next topic of today's session, that is companies using Docker. It is really important to know who are actually using Docker: startups, mid-sized companies, enterprise-level organizations, or is it a mix? According to the Datadog report, the move to Docker is actually being led by larger companies rather than smaller startups. Major companies that deploy Docker include Spotify, Yelp, Expedia, PayPal, BBC News, etc. For the news division of BBC, the problem was largely one of speed and volume. BBC News delivers broadcast and online news in almost 30 languages with over 80,000 daily news items in English alone. It ran more than 26,000 jobs in 10 different continuous integration environments with sequential scheduling, resulting in a chronic logjam and a combined wait and runtime of up to 60 minutes per job. Docker allowed BBC News to eliminate job wait times and run jobs in parallel. It also gave developers a flexible continuous integration environment that is easy to work with and which allows much greater control over such factors such as application architecture.
let me show you the workflow of Docker. Alright guys, so this is the general workflow of Docker. So a developer writes a code that defines all the application requirements and dependencies in an easy to write Docker file, and this Docker file produces Docker images. So whatever dependencies are required for a particular application is present inside this image, and then when we run this Docker image, it creates an instance, and that is nothing but the Docker containers. This particular image is then uploaded onto the Docker Hub. So from these repositories, you can pull your image as well as you can upload your images onto the Docker Hub. Then from the Docker Hub, various teams, just the quality assurance team or the production team, will pull the images and prepare their own containers, as you can see from the diagram. Now, these individual containers will communicate with each other through a network to perform all the actions required, and this is nothing but Docker networking. So what exactly is Docker networking? So when containers are created, these isolated containers have to communicate between each other, right? So the communication channel between all the containers introduces the concept of Docker networking. Alright, so now what would be the goals of Docker networking? So Docker is flexible, in other words, I mean pluggable. By flexibility, I mean that you can bring in any kind of applications or operating systems or any kind of features in Docker and deploy them in Docker. Next, Docker can be easily used in cross-platform. By cross-platform, I mean you can have n number of containers running on different operating systems, like one container can run on the Ubuntu host, other container can run on the Windows host, etc. like that, right? So you can have all these containers work across with the help of Swarm clusters. After that, we have Docker offering scalability. As Docker is a fully distributed network, it makes the applications grow and scale individually. Then we have Docker using decentralized network. This enables the capability to have your application spread and highly available. So in the event that a container or a host is suddenly missing from your pool of resources, we can automate the process of either bringing up additional resources or passing over to the services that are still available. Apart from offering the decentralized network, we have Docker being really user-friendly. So Docker makes it really easy to automate the deployment of your services or containers that would make things easy for you in your day-to-day life. And finally, we have Docker offering out-of-box support. So the ability to use Docker Enterprise Edition and getting all the functionalities very easy and straightforward makes Docker platform to be very easily used. So those were the goals of Docker networking. Now, to enable these capabilities, we have the container networking management, and to do that, we have the libnetwork. Now, what is this libnetwork? So libnetwork is an open source in which you can read through the source code and you can automate all of that as an open source. So libnetwork is basically a Docker library that implements all of the key concepts that make up the CNM model. Now, what exactly is this container network model? Well, container network model formalizes the steps required to provide networking for containers while providing an abstraction that can be used to support multiple network drivers. So CNM requires a distributed key value store like console to store the network configurations. The container network model has interfaces for IPAM plugins and network plugins. The IPAM plugin APIs are used to create or delete address pools and allocate or deallocate container IP addresses, whereas the network plugin APIs are used to create or delete the networks and add or remove the containers from networks. A container network model is basically built on three main components: the sandbox, endpoints, and the network object itself. So a sandbox contains the configuration of a container's network stack. This basically includes the management of the container's interfaces, routing tables, and DNS settings. Now, a sandbox may contain many endpoints from multiple networks, right? An endpoint is something which joins a sandbox to a network. Endpoint can belong to only one network but may only belong to one sandbox. And finally, as I was talking about network is a group of endpoints that have the ability to communicate with each other directly. Now that you know a brief about the container network model, let me tell you the various objects involved in this model. The container network model comprises of 5 main objects: the network controllers, drivers, network, endpoint, and sandbox.
Starting with network controller object provides the entry point into the lib network that exposes the simple APIs for users such as the Docker engines to allocate and manage networks. Since lib network supports multiple active drivers, both inbuilt and remote, network controller allows users to bind a particular driver to a given network. Next comes driver. Driver is not a user visible object, but drivers provide the actual implementation that makes the network work. Driver can be both inbuilt and remote to satisfy various use cases and deployment scenarios. The driver owns the network and is responsible for managing the network, which can be further improvised by having multiple drivers participating in handling various network management functionalities. After the driver object, we have the third object as network. Network object is an implementation of the container network model. As I said, network controllers provide APIs to create and manage the network object. Whenever a network is created or updated, the corresponding driver will be notified of the event. The lib network treats network object at an abstract level to provide the connectivity between a group of endpoints that belong to the same network and then also simultaneously isolate them from the rest. The driver performs the actual work of providing the required connectivity and isolation. The connectivity can be within the same host or across the multiple hosts. After that, the next object that we have is endpoint. As I discussed before, endpoint mainly represents a service endpoint. So it provides the connectivity for services exposed by a container in a network with other services provided by other containers in a network. So the network object provides the APIs to create and manage endpoints, and an endpoint can be attached to only one network. Since endpoint represents a service and not necessarily a particular container, endpoint has a global scope within the cluster as well. And finally, we have the sandbox. So the sandbox represents containers network configurations such as the IP address, MAC address, routes, and DNS entries. A sandbox object is created when the user requests to create an endpoint on the network. The driver that handles the network is responsible to allocate the required network resources such as the IP address and pass the info called as sandbox info back to the lib network. So, the lib network will make use of the OS specific constructs to populate the network configuration into the containers that is represented by the sandbox. So, a sandbox can have multiple endpoints attached to different networks. Alright guys, so that was a brief about the various network model objects. Now, let me tell you the various network drivers that are involved in Docker networking. Docker networking has mainly 5 network drivers involved with it: the bridge, host, none, overlay, and MACLAN network. So starting with the bridge network is the default network driver. So if you do not specify a driver, then this is the type of networking you're creating. So the bridge network is a private internal network created by the Docker on host. All the containers are attached to this network by default. The containers can access each other using this internal IP, and if it is required to access any of these containers from the outside world, then port forwarding of these containers is performed to map the port onto the Docker host. Bridge networks are usually used when your applications run in standalone containers that need to communicate. Another type of network is the host network. This removes the network isolation between the Docker host and the Docker containers, and then it uses the host networking directly. So, if you were to run a web server on port 5000 in a web app container attached to the host network, it is automatically accessible on the same port externally without requiring to publish the port, as a web container uses the host network. This would also mean that, unlike before, you will now not be able to run multiple web containers on the same host on the same port, as the ports are now common to all the containers in the host network. The third option is the none network. The containers are not attached to any network and do not have any access to the external network or the other containers. This is usually used in conjunction with a custom network driver and is not available for swarm services. The next network that we have in the list is overlay network. So to understand this network, let's consider a scenario. Let's say we have multiple Docker hosts running containers. Each Docker host has its own internal private bridge network in the 172.2.17 series, allowing the other containers running on each host to communicate with each other. However, containers across the host have no way of communication with each other unless you publish the ports on those containers and set some kind of routing yourself. This is where the overlay network comes into play. With Docker Swarm, you could create a new network of type overlay which will create an internal private network that spans across all the nodes participating in the Swarm cluster. We could then attach the containers or services to this network using the network option while creating a service, and then we could get them communicate with each other through this overlay network. So, you can say that you can use overlay networks to facilitate communication between a Swarm service and a standalone container, or between two standalone containers on different Docker daemons. And finally, we have the last network, that is the MAC-LAN network. So MAC-LAN networks allow you to assign a MAC address to a container, making it appear as a physical device on your network. Then the Docker daemon routes traffic to the containers by their MAC addresses, and then the MAC-LAN driver is sometimes the best choice when dealing with legacy applications that expect to be directly connected to the physical network rather than routed through the Docker host network stack. So guys, that was about the various network drivers. Now, let me brief you a little bit about Docker Swarm and tell you the significance of Docker Swarm in Docker networking. In simple words, if we have to define Docker Swarm, then Docker Swarm is a cluster of a machine all running on Docker. This provides scalable and reliable platforms to run many containers, which enables the IT administrators and developers to establish and manage a cluster of Docker nodes as a single virtual system. So, as we know that Docker Swarm is a technique to create and maintain cluster of Docker engines, what exactly is this cluster of Docker engines? So let me tell you that in a cluster of Docker engines, there will be many Docker engines connected to each other forming a network. This network of Docker engines is what is called as a Docker Swarm cluster, as you can see from the diagram on the screen. And this is also the architecture of Docker Swarm cluster. So there will always be one Docker manager. In fact, it is the Docker manager which basically initializes the whole swarm, and with the manager, they will have many other nodes on which the server should be executing. So there will be times when the service is also executing at the manager's end, but the manager's role is to make sure that these services or the applications are running perfectly on the Docker nodes. Now, whatever applications or services that are specified or requested, they will be divided and then they would be executed on different nodes, as you can see in the diagram here. So these different nodes are nothing but the workers. Alright guys, that's all you need to know about Docker networking. Now let's move on to the hands-on part. In our hands-on part, first I'm going to show you how to create a simple network and how to deploy the service over your network. And after that, we'll create a Swarm cluster and then we'll connect two services and then we will scale a single service. Alright, so let's get started with our hands-on. So first, we're going to deploy an application named Apache 2 by creating a Docker service in the default network, that is the bridge network. So apart from that, we'll also initialize the Swarm cluster as we want it to work on two different nodes, that is the manager node and the worker node. So for that, let me open my terminal and then let me type in the command sudo docker swarm init -advertise -addr and then mention the IP address, right? So I'll mention the IP address of the manager node and then I'll click on enter. Once you click on enter, you'll be asked for the password. So type in the password and then you can see that the swarm has been initialized. Now to connect the slave node to this particular manager, you have to copy this link and then go to the slave node, open the terminal and then paste it here. So you can see that this node has joined the swarm as a worker. So that is the manager and this is the slave. Now let's go back to the manager node and over here, we're going to deploy an application named Apache 2 by creating a Docker service. So for that, you have to type in the command docker service create --name, give the name of the application, --mode, that is which mode we want it to work. We want it to work in the global mode, -d, -p, that is port forwarding, and then we'll mention the port where it's going to work. So it's going to work on 8003 and then mention the account name from which the Docker image has been pulled. So once you click on enter, you can see that your Docker service has been created. Now to check whether your Docker service has been created or not, you can use the command docker service ls. So this will list all your running services. At present, we just have one service, that is Apache 2. Now to check whether it is running or not, you have to go to the slave node and then open the web browser here, and then let's go to the localhost to the port 8003. So let's go to the port. So you can see a message that it works. So that means our application has been deployed onto a container, and then it is also connected to the Swarm cluster. So the worker also has this particular application. Now, if you want to deploy a multi-tier application in a Swarm cluster, how will you do that? So let me show you how to do that. So before I do that, let me tell you what are we going to connect. So basically we have two applications, that is the web application and the MySQL database. So the web application has two parameters, that is the course name and the course ID. And once you mention the details and you click on submit query, it will be automatically stored in the MySQL database. This multi-tier application is connected with each other through the overlay network. So let's start doing it. So first let's create the overlay network. So for that you have to type in the command docker network create -d overlay my overlay 1. So my overlay 1 is basically the name of the network that I'm giving. You can give any other name that you want. After that, let's create a service for the web app application. So for that, I'll again type in the command docker service create -name. Name of the application is web app 1 -d -network, and we'll connect it to my overlay 1 network, and then -p for port forwarding, and then we'll mention the port on which it is going to run, and then we'll mention the account details from which this Docker image will be pulled. So after that, you can just click on enter. So you can see that your Docker service has been created. So let's check it once again. So for that, you'll type in the command as docker service ls. So you can see that the web app 1 service has been created. Now we'll create another service for the MySQL application. So for that, you'll type in the command docker service create -name MySQL, that is the name of the application, -d -network. The network through which we want to get connected is my overlay 1 -p for port forwarding. Let's mention the port, and then the account details. So for that, let me mention the account details. So you can see that your Docker service has been created. So let's check again. So for that, we'll type in the command docker service ls, and you can see that the MySQL service has been also created. Now what you have to do is you have to go to the web app application, and inside which you have to make some changes. So to go inside the web app service, you need to know the container ID. So to know the container ID, you have to type in the command docker ps. So this will list all the container IDs that are present on this node. So you can see that web app 1 and Apache 2 are present. At present, we need container ID for web app 1, right? So to go inside this container, you'll type in the command docker exec -it, and then copy this container ID and then paste it here, and then end the command with bash. So you can see that you've gone inside this container. Now you have to go to a file index.php and make some changes. So for that, we'll type in the command nano and mention the directory. So this PHP file opens up. Now you have to change the server name to MySQL since we want to get connected to the MySQL server, and then change the password to Edureka. And let's say we keep the database name as hands-on. After that, use the keyboard shortcut Ctrl X, press on Y, and then save the file. So once you're done with this, you have to exit the container. So for that, type in exit, and you can exit the container. Now you must have observed here that only the web app and the Apache 2 services can be seen on this node, whereas we are not able to find the MySQL. That is because it is present in the slave node. So let me show you there. So let me go to the terminal, type in docker ps, and you can see that the MySQL service is over here. So why is that so? That's because Swarm is performing load balancing. It is dividing its containers into two different nodes so that it can balance the load properly. So now what you have to do is you have to go inside the MySQL container. So for that, you'll type in the command docker exec -it, and then mention the container ID of this particular container, and then end the command with bash. So you'll go inside this particular container. Now, once you're inside this particular container, you need the access to use MySQL commands. So for that, you'll type in the command mysql -u root -p Edureka. So once you type in this command, you can see that you've got the access to use the MySQL commands. So -u is basically the user and -p is for the password. And if you have a question that why are we using -it here, that's because we're opening the container in the interactive mode. So once you get the access of MySQL, you have to create a database and then you have to create a table inside it. So for that, you'll use the MySQL commands such as create database hands-on. And then you have to use that database. So for that, you'll type in the command use hands-on. So you can see a message that the database has been changed. Now you have to create a table. So for that, type in the command create table. Let's say courses is the name of the table, and then mention the two parameters. So we have course name, which is of varchar type. Let's say it allows a length of 15 characters. And let's say we have course ID of varchar types of 12 characters. And after that, close the bracket. And this creates a table for you. After that, you have to exit your MySQL connection. So for that, you'll type in exit. And then you have to again come out of this container. So again, type in the command exit and you'll be out of this container. Now what you have to do is you have to go to the slave mode and then run this index.php file. So for that, let me open localhost. Since the web application service was running on 8001 and index.php file. Alright, so you can see that our Docker sample app has been opened up. Now before you include the details, let me go back to my web app container and let me show you what all I've changed in the file. So you have to mention the server name to be MySQL, your username to be root, password to be your password, and then database what I've mentioned there, that is hands-on. And the name and ID would be the parameters that I would give. So it would be course name and course ID. And then you have a basic PHP file in which you write the SQL command that insert into the course name and the course ID, which will basically include the details that we fill into the application to be stored directly into this table. Now let's go back to the slave node. And now let's mention some details. So let's say we mention a detail to be blockchain and the course ID to be randomly some number. And then we'll submit the query. Once you submit the query, you can see that a new record has been created successfully. So let me just create few records. Alright, so I've typed in few records. Now let's go back to our MySQL container and get into the database and see if our table has all the records entered stored or not. So let's go back to the terminal. So now let me type in the command docker ps and then I'll type in docker exec -it, mention the container ID. Now I'll type in the command mysql -u root -p Edureka. So this will give my MySQL connection. So now I'll type in the command as use hands-on. So database has been changed. Now I'll type in the command as show tables. So it will show me the tables that I've included in database. So I have this table included. Now let me type in the command select star from courses. So this will basically list all the details that are stored inside this table. So you can see that we have entered so many details with the help of this web app and that were directly stored into our MySQL database. So guys, that's how you can, connect multi-tier applications over the overlay network. Now, if you want to scale any particular service, you can just scale that service by using a simple command. So for that, you have to go back to your manager node and then use the command docker ps to list all the containers. Alright, so we have two containers. Let's suppose we want to scale this web app service for around 5 times. So you can do that with a simple command, that is docker service scale web app 1 is equal to 5. So you can see that the web app 1 service has been scaled to 5 times. Now, if you want to check whether it is working or not, you just have to type in the command docker service ps web app 1. So you can see 5 instances of the same services. So guys, that's how you can deploy a simple application over the default network and also connect multi-tier applications with an overlay network, and finally you can scale any particular services. So guys, that was a short demo on Docker networking.
What is Angular? So Angular is an open source client-side framework for deploying single page web applications, right? And the keyword that you need to note here is single page applications, and that's acronymed as SPA. There are quite a few technologies for developing single page applications. So Angular is a very popular one. React.js is another popular technology. Similarly, Vue.js, and we have a couple more. And well, the thing that you got to ask me here is why single page applications, right? So you might ask, why am I having a demo on single page applications, right? Well, the answer for that is because single page applications are the way forward. They are more effective and they are easier to build, and they come with a lot of other benefits that I of course can't mention in today's session because that'll get too detailed. But I do have a couple of benefits here that I've mentioned on the slide, and you can see that on your screen now. And the biggest reason and the most important factor is single page applications, which are created by technologies like Angular and the other JavaScript technologies. These applications are really fast, and they are fast because while accessing any web page which is developed in Angular or such technologies, that time your browser will fully render the entire DOM in one single time, and later on it only modifies that view or the content displayed to you when you interact with that web page, right? And even these modifications will be done by the JavaScript which runs in the background. And yeah, you can see an example of an SP architecture over here, right? So you have basically any web application which is developed with the help of Angular, right? So they'll be called single page applications, and they'll have three different components, first of all. Or well, let's not say three components. In my example, it's three components, but in general they'll have different components. And the components that you can expect there to be are those of a navigation bar where you can switch from one tab to another tab. Then you'll have a sidebar, right? Again, you can filter down to different options that you want to be displayed, and then of course you'll have a content bar, right? So similar to how you have a sidebar, you'll have another component called the content, which will be the actual display. So whatever you're actually viewing on your on your web page, that will be displayed over here, and what is displayed here can be controlled from here by clicking on the different information, or you can also control that by switching or clicking on a different option in the navigation bar or in the sidebar. So you can switch the view like that, and when you do it this way, your browser will not take too much time to fetch the information from the server, because the entire DOM will be fetched at one go. So that's the big benefit with single page applications, and especially Angular implements, Angular is used for developing single page applications. That's why it's the way forward, and it's really popular, and it's the technology is really coming up. So my team has developed a single page application using Angular, and that's what I'm going to deploy today, right? Now let me quickly go to the next slide and talk about what is DevOps here, right? I'm sure everyone here knows what DevOps is. It's a software development approach which involves continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring of the software throughout its development life cycle. Well, I've mentioned this numerous times in my various sessions, and I expect you to know this, okay? But what you might not know is which of these tools are used for continuous deployment, right? So on a higher level, I can say that Docker is the most important tool for achieving continuous deployment, okay? But as you can see on the screen, I will also be showing the act of continuous development and continuous integration in today's session. So continuous development is achieved with the implementation of Git and GitHub. Continuous integration is achieved with the implementation of Jenkins, and continuous deployment is achieved with the implementation of Docker. Well, using GitHub, you can pull the code from the repository, right? And then using Jenkins, we can deploy that code to the production environment or the servers or virtual machines, whichever suits you. And then finally, we can make use of Docker to containerize those deployments. So that's how the different DevOps tools that you see here, Git, Jenkins, and Docker, that's how they can be orchestrated to achieve automation and for software development. So that's how things go. And in my Angular application, I'm going to use these three tools, right? These three DevOps tools. Now, moving on to the next slide. Now this slide, which is all about deploying an Angular application, this is the most interesting slide in today's session. And you can ask me why. And the reason for that is, the reason it's interesting is because we are using Docker majorly, right? We are pulling all the code from Git, and then we are using Jenkins to integrate it into Docker, and we are creating multiple containers by using Docker. But at this point of time, I want to also ask another question. I want to ask you people if you know what Docker does, what are its benefits, and how it solves the developer and the operations problem, right? So how it eliminates the silos between the developers and the operation engineers. Basically, Docker containerizes application along with all its dependencies, right? And when we say containerizes, it means that we are packaging the code of the application along with all the required packages and dependencies in a lightweight manner, which is not too heavy on the server on which we are deploying the application to. Right, so and the best part with these Docker containers are that they can be run on any operating system, irrespective of the one it was built on. Well, what that means is I can containerize any application. In my case, let's say in my case I have the Angular application, right? But now tell me what kind of dependencies will my Angular application have? You people can tell me what kind of dependencies my Angular application will have. The dependencies that your Angular application would primarily need are those of NodeJs, Node Package Manager, which is again acronymed as NPM, and of course the package.json file, right? So Node.js is basically going to be the backend for your Angular application. NPM is going to install an Angular application and maintain all its dependencies and the versions of those dependencies. And the package.json file is again the most important file, right? Because it's going to contain details about your project, about what dependencies are needed and what versions of dependencies are needed. All these things will be present in your package.json file. So basically these three files will be the dependencies. And in my case, what I can do with the help of container is that I can have a container, I can install all these dependencies, I can place them all together, and I can simply without having an operating system that's actually powering it, I can package all these things into this particular container, and I can just share it with other people. And what the other people have to do is they just have to run the container, and they can just boot it with the help of any operating system, right? So that's the benefit with containers. So developers can containerize any app that's created in a Mac operating system, and probably they can upload that container or image to Docker Hub, and someone in a remote location can download that Docker image and spin a container out of it, while the person that's remotely located, while he's having a different operating system. So the guy who built the application, right, who built the Docker image, he could have done it using a different operating system, and the guy who's actually running the container at a remote location, he can have a different operating system. So that's the big benefit. So you guys are getting the advantage that lies here, right? With the help of Docker and with the help of containerizing all your applications and dependencies, minus the actual operating system. Okay, so anyways, I think it's time to move on. And now I've reached my demonstration aspect, right? So now that I've told you what exactly is what I'm going to do, right? That's going to be the architecture of how I'm going to deploy my Angular application. Now that you know it, I'm going to start with my demonstration. And what I'm going to do is I'm going to do it with the help of continuous deployment using Jenkins and Docker. And we will also use GitHub, from where we will be pulling the code, right? So let me first of all open my virtual machine for that. So guys, please tell me if you can see my screen here. This is my virtual machine that I've opened now. Okay, fine, great. So first of all, to achieve this continuous deployment, like I told you, Jenkins is the broker, right? So Jenkins is the one that pulls the code from the repository, and that is which is going to help us build Docker images and spin containers out of those images. So what I have to do is I have to first of all open my web browser and launch my Jenkins dashboard, right? So Jenkins is by default hosted on port number 8080. So let me just launch that particular launch that port number on my local host. Sorry for the delay, guys. It's lagging a little bit. Right, so this is the port number where Jenkins is hosted. Now in the meanwhile, let me just quickly go to my terminal and show you my project folder where my actual application is present. So here's the terminal and my project is present in this folder. I've created a demo folder inside which there's a top movies, right? So the top movies is the project which I created, the project folder. And what you see here, these are the different files and folders present inside this project folder. Let me also open it through my file explorer here and explain what these different packages, files and folders are for. So this is the project that I created, and as you can see there are a number of files here, and the number one file that I want to talk about is that of a Dockerfile, right? Now the Dockerfile is basically used to build your Docker images and spin containers out of those Docker images, right? And to build your Docker images, you specify the commands inside the Dockerfile, right? And then you just execute that Docker image which is built by issuing the run command. That time your Docker container would be spun, and that time your container would be ready and your application would be hosted on a particular port number, and then it would be mapped to a particular port on your local host. So all these functionalities are done with the help of Dockerfile. Okay, now, but that is only with respect to Docker. And the other things here, the other folders and the files that you see here, these are with respect to my Angular application. So we have different files like the package.json file, we have node_modules, we have src folder. So all these things, well, first of all, let me talk about the package.json file, right? Now this package.json file is a very important file which contains all the details about my project. It contains which version of which dependencies my project needs, what's the name of my project, what versions of dependencies my project needs to implement. All these details would be present inside my package.json file. So without the package.json file, your application cannot get hosted. It's, for those of you who are new, you can consider this to be like the metadata, right? If people know what is a metadata, so package.json does a similar role, right? But here comes the question: how will the package.json file be initiated, right? From how do you execute the package.json file? What's the first step? And that's where this whole node_modules folder comes into the picture, right? So you have a command called npm install, right? So npm install is nothing but, npm stands for node package manager, right? So it installs all the dependencies that your project needs. And when you run the command npm install through your terminal, so at that time it will look for the package.json file in that particular directory. So I have to execute the npm install from the directory where my package.json file is present. From here, if I execute that command, that time it would first of all initiate the package.json file, and whatever dependencies are present over here for my project, for my code, all those would be installed and downloaded and installed from the node repository, right? In my case it would be node repository, but yeah, otherwise you would just download it from the internet and you would have it already, and all those dependencies would be present inside this folder called node_modules, right? And this folder node_modules is going to be a very heavy folder, right? There's going to be a lot of contents here, so it's ideal that you don't place it in the GitHub. If you want to share your project with someone else, you in the real world environment, what happens is you just share the package.json file, and when they do the npm install, that time they would automatically get all the dependencies installed as per the package.json file, whatever specified here. So that's what it does. And then you have other files here, right? Other configuration files like protractor.configuration file. You have the TypeScript configuration file, the TypeScript lint configuration file, and you have the other files here. So all these, excuse me, 1 minute, guys. Yeah, so guys, all these configuration files are the configuration for your Angular applications, right? Be it the TypeScript configuration or the linting configuration or the protractor. All these can be considered, basically these are the boilerplates that come with the actual Angular application. So that's these are dependencies, right? So you need it with your project, and the folder src. So this is where your actual project would be present. So whatever code you've written for your Angular application, that would be present here. So yeah, these are basically the contents of my repository, and these are what is needed for containerizing my Angular application. And maybe you would find I have not explained this folder, right? E2E. So this one basically is used for the end-to-end testing. So whatever is needed for that is present in this package here. But yeah, on a high level, this is what you need to know. These are the packages, and the first thing that I got to do is to to containerize this application. The first thing I have to do is I have to pull the code from my GitHub repository, and I will do that with the help of Jenkins, right? So even though I have it locally in a real world environment, developers or engineers would pull this code from GitHub, right? So I will show you how that happens by first of all going through my Jenkins dashboard here. This is my dashboard. I already have a project called demo. So this is the one that I want to show you a demonstration of. So this contains, I've already pre-built the environment so that I don't waste much time in downloading everything, and because downloading everything and installing everything would take a lot of time. So if I have the environment ready, I can just show it to you straight away. So I have it over here, and if I go to configure, I can show you what are the elements that I've defined already. So let's just wait for this to come up for a minute. First of all, we have to go under the source code management, right? So this is where you need to first of all enter the GitHub repository from where you want to pull your code, right? Now let me just open this repository and show you what I'm going to pull. It's basically the same content that is there in my local host, in my host system, right? So whatever you saw over here, the file explorer, most of the contents over here are there in my GitHub repository, except for the node modules, because this gets installed automatically when you run the package.json file. Yeah, so you guys see this, right? So we have the same E2E folder, we have the SRC folder, and then we have various other files like the Angular CLI JSON, we have the Docker ignore, we have the Docker file that's present. And I'm surprised I didn't get any question from you people asking why the Docker file is present inside the GitHub repository. Well, I found it strange because the moment you people would have seen it, I expected you people to ask me a question. But anyways, the reason I have the Docker file inside the GitHub repository is because wherever my code is present, right? So that's where my execution should ideally happen. And if I have my Docker file present in the same directory, then I can run my Docker file. I can use my Docker file to build my Docker image inside that repository, and it will also look for the dependencies and the Angular code for my application, all these things from the same repository. So that's why I have the Docker file in the same repository, right? So that's what Dockerfile is used for. And then similarly, we have the other dependencies like the package.json, the tsconfig.json, the other things which I spoke about, which was there over here. So the same thing we have in our GitHub repository. So getting back to our Jenkins, we first of all specify that we want to pull the code from here. And what we do next is we can go down to the build option. So under build, we have our shell here, right? So whatever commands you specify here, they would be executed on your shell. So since I'm using a Linux system, I've chosen to execute these commands on my shell. Well, in case you guys are executing it at your end, if you're using a Windows system, you might probably want to choose Windows batch command and then specify the commands that you want to run in your Windows CLI, right? So that's the only difference. But yeah, whatever commands I specify here, they will be run on my shell. And the command that I'm first of all running is that of docker build, and I'm building the image called demo app1. So right now I'm using the docker build -t flag t command to build a new image called demo app1, and it would build this application based on the Docker file which is present in this folder. So this is the folder where my Docker file is present, right? So I can in case I do a cd, and if I give this folder, then I would have moved to that particular directory, and then I can just simply replace this path with a dot. So that's another alternative. But yeah, otherwise you can specify the entire absolute path also here. So I've done that, and it's basically creating a new image based on the Docker file and the instructions present inside the Docker file in this command. And then in the second command is the docker run command. Okay, so the image that was created here, demo app1, so that image is basically being run. Okay, you spin an image into a container by running this command docker run, and you specify other options while doing this. We specify flag rm we specify single flag P, and then we specify the port numbers. So the P flag is used for mapping your Docker containers port to your host machine's port. So over here, the 4200 that you see here, this is the port number of my host machine on which the subsequent or the equivalent port on which my Docker container, right? So whatever is basically present in my Docker container, the port number, whatever is hosted there, that would be visible inside my 4200 port in my host system. Okay. So yeah, it's an Angular application, right? It's a web application. So what you have to do is you have to host that in one of the ports. And I have, see, by default, Angular applications are hosted on port number 4200, and I've also specified the same in the package.json file. So that's where you specify the port number. And what I'm saying here is whatever is running inside my Docker container in port number 4200, that should also be visible or available in the port number 4200 of my host machine. So that's what the flag here stands for. And then we have the name I'm giving this container which I'm building. I'm giving it a name, Top Movies 1. And yeah, this is basically the image, same image that we are first of all spinning with the help of our Dockerfile. So these are the two commands that I'll be running. And at this point of time, if there are any of you who are new to Jenkins, or if you are new to Docker, if you execute the same commands from your execute shell, you might have a problem. So can any of you guess what that problem might be? Right? So I can give you a hint. The problem would lie over here. Okay? So it would lie right at the beginning of this command. Well, no problem. See, the thing is, any Docker command that has to be run, it has to be run with the sudo access, right? Only the root can execute any Docker command, especially the build and the run command. Okay, but there are few commands which can be executed without the sudo, but yeah, these two commands especially need sudo access. If you are executing the same two commands from your terminal, then you can just simply prefix this whole command with sudo here, and then the shell would prompt you for the password, and then you can enter the password. But what would you do in case of Jenkins, right? So this is Jenkins. You cannot put sudo here because Jenkins cannot manually enter the password for root access, right? So root credentials Jenkins doesn't have. So in this case, what you need to do is you have to give the sudo credentials or the root credentials to Jenkins itself. So Jenkins is actually a user. If you guys notice, if you go under or let me just tell you this. Jenkins is a separate user because it's a web server, right? And any commands that you execute through Jenkins, it would be executed as the user Jenkins. So what you have to do is, similar to how you you execute Docker commands without sudo, how you create a new Docker group and you add your user, the user from which you're executing, you add that user to the group. Similar to that, you have to add your Jenkins user to the Docker group, and you should give the Docker group the root access. So the Docker group would basically be on par with root in terms of the access that it has over the system. So that's the important step that you need to do, because otherwise if you don't enable this access, then your command is not going to get executed. It would say failure, permission denied. So that's the thing. And yeah, if you have these two ready, then it's pretty much ready, right? Your Docker file would be used to build the image, and then that image would be used to get the container out. So I'm just gonna save this and quickly show you how to build this application. Okay. So to build the application, you can simply go to build now, right? You can see the build history here. These were the previous times I ran the same command. And if I do it again, build now, it says build is scheduled, and you would see a new build pop up over here. Build number 12, right? So if I click on this, and if I go to console output over here, you would get to see what is the status of this build. So let me just go here. And yeah, if you go to console output, you will get to see what's happening. So similar to the output that you get on your terminal, something like that you will get over here. Okay, we're here already, so let me just quickly go up. As you can see, the first set of commands I've started executing using your by Jenkins, and the first one was to pull the data, the code from Git, right, and from the Git repository. So whatever was there is being fetched over here, and then the first command that we're executing on the shell can be differentiated with this command. The plus symbol basically indicates that it's a command that's being executed on the command prompt. So the Docker build -t demo app is the command that's being built, And when you build it, you can see that there are various steps being performed. So for each line in your Docker file, there will be a step that will be performed. Now, let me quickly go to the Docker file and explain what are the different steps that are going to be performed. Okay, so at this point of time, I'm going to go back here and let me open the Docker file and explain the different steps. Because if we want to host a node, if we want to host an Angular application, we have to first of all pull a node image, right? Your Angular application would be present, or it would be hosted only when there's a node application which is running at the back end. So the first command, that is from, it's going to pull the node image which has the tag 6, right? So version number 6 of node. So probably this is what is going to get pulled with the help of from node 6. And when it pulls, then what you got to do is you have to use the run command to make a directory inside this particular image. So you use the -p flag to specify the path that you want to create, /user /src/app. So you're creating this particular path inside your Docker image which you've pulled, and then you're changing the working directory to the path that you created by using this command workdir and this. And the first thing that you got to do, that you need to notice here, is the package.json file which is present in my local system, that I'm moving to my path which I created inside my Docker image. Now that is because this is the file that contains all the dependencies that are needed to basically download all the node modules, right? So whatever dependencies are there inside the node modules, they will be downloaded with the help of package.json. So right now it's present in my local system. I'm specifying Docker to copy this file into the directory path here, and then once you've done that, it asks me to run the npm cache clean. Now if you're running the npm install for the first time, or if you're using npm for the first time, you might not need it, but since I've run this command earlier, I'm just using it because I want to avoid any version conflicts between the different dependencies, right? So dependencies can be of different versions of Angular 2 version or Angular 4 version and all those. So I'm just using this to keep myself healthy there. And then I'm using the run npm install. So this is the most important command which would basically start everything. So the npm is the node package manager, and when the moment I issue this command, my package.json file would be searched for, and when it's located, the commands there, the dependencies which are there inside, those will be created inside a Docker modules, right? Node modules. Inside that folder, everything will be created. So that's what this command does. And the next command is all about copying every single file or folder which is present inside my inside my host directory, that I'm copying it into my host folder. So the other files that are those of configuration files which I spoke about earlier, the TypeScript configuration file, the TypeScript lint file. So all those applications will also be copied to this image inside my to this path inside my Docker image. And then I'm finally saying expose 4200 because this is the port on which my AngularJS application would be hosted. And then I'm finishing it off by specifying this command of npm start. So you do the npm install here. So at this point of time, your dependencies are ready, everything is ready to be, your application is ready to be deployed and hosted, and the start is what is going to actually do the hosting onto this port number 4200, right? So that's what the Dockerfile instructions are, and the same instructions have been running on my Jenkins. So it says step 1 of 9, it's pulling from here and it's moving to this directory, and it's creating a new directory, moving the working directory to this, and then copying the package. So each and every step is being executed one after the other. If any of them fail, then you would have a notification saying this step failed and check your command. So all those details. But anyways, since ours is successfully built, this is the ID of my image which was generated, right? And yeah, this is the tag has been added to it. And the next command that's being run from my shell is the docker run command with the --rm flag and the p flag, right? The same command which I explained earlier. And when this command is executed, it says that your ng serve is being hosted. So this is the localhost port which I'm mentioning, on which I wanted to run, and you can see the status here, right? It says 0%, 10% here. You have again, 10% here, and yeah, basically it keeps increasing. So we have 11%. So it's a big process. So there's a lot of dependencies that gets downloaded, and in the meanwhile, that we saw the Docker file that I was explaining the Docker file, we have all our packages downloaded and installed, and your application is actually hosted. So it says Webpack compiled successfully, right? So this is the success message. If I now open the localhost 4200, then you would see that my Angular application is up and running, right? So you can see that the application name is Movie Rating System. And this is something that I didn't tell you. This was the application which my team created for me, and this project is all about the top 250 movies that you have to watch before you die, right? Some of the the biggest blockbuster hits of Hollywood. So all those are present here. It's the Angular. You will get the Angular feel over here by looking at the different components. So the logout option that you see here, this is a different component, right? If I log out, then I do not get to see the list of movies. But if you log in, only then you will get to see that, right? And then you have the navigation bar here, where you can switch to different tabs. You can go to the Edureka Home tab. You can go to the the About tab, where again we have other details. And then if you log in successfully, then you will get to see the movie list that we have. So let's just wait for this to log in, and I can show you the movie list that we have. Yeah, so you have the movie list here, right? So in the navigation bar, let me just click on this movie list, and you can see the 250 movies that we choose are have been the best ever Hollywood movies. Yeah, so the number one movie that you have to watch is The Shawshank Redemption, right? And then we have other movies like Godfather, the Part 2 of Godfather, Dark Knight, 12 Angry Men, which again is my favorite movie. We have Schindler's List. We have a number of movies here which which is our favorite, of course. And we've created an application this way. And this is a simple web application, a single page web application that we created. And you can create all these things if you know how to work with NodeJs, and if you know how to work with AngularJS, right? Similarly, if I go to the Edureka tab, we have details about Edureka over here. So we believe in tech up your skills, rediscover learning. So we have that, live classes and expert instruction. So this is the interface that we built, that we created in our application, and that's what I want to show you. And in the movies list again, I mean, of course, we have the list of movies, and if you click on any of the movies, you can look at the details of that movie, as in when it was released, what is the genre of the movie, who was the director, writer, who are the actors in the movie, and what ratings it has got. So whatever data we have here with respect to ratings and writer and stars, these were basically basically got from IMDb, right? So it was those IMDb ratings that we are using as data set. So that's about our Angular application, and it's a simple application which even you could create one if you have expertise in Angular.
Now, before listing down a few features of Jenkins, let me tell you some fun facts about Jenkins. Currently, there are over 24,000 companies which use Jenkins. To name a few, there is Google, Tesla, Facebook, and Netflix. Now, there has to be a reason why such reputed and successful companies make use of Jenkins. Now, let's discuss a few key features and see why Jenkins is so important. All right. Now, the first feature is that it is an open source, freely available tool which is very easy to use. It has various features like the build pipeline plugin, which lets you graphically visualize the output. And apart from that, there is also a feature known as user input, which lets you interact with Jenkins. All right. Now, one major feature of Jenkins is that it implements continuous integration. Now, what is continuous integration? Every time a developer commits into a source control management, that commit is continuously pulled, built, and tested using Jenkins. Now, how does Jenkins do all of this? Now, Jenkins has over 2,000 plugins which allow it to integrate with other tools like Docker, Git, Selenium, etc. So by integrating with other tools, it makes sure that the software development process is fully automated. All right. So it is also an automation server which makes sure that the software delivery cycle is fully automated. Now let's see how Jenkins works. So here you can see there is a group of developers committing their code into the source code repository. Now, every time a developer makes a commit, it is stored in the source code repository. Now what Jenkins does is, every time a commit is made into the source code repository, Jenkins will pull that commit, build it, test it, and deploy it by using plugins and other tools. All right. Now, not only is it used for continuous integration, it can also be used for continuous delivery and continuous deployment with the help of plugins. So by integrating with other tools, the application can be deployed to a testing environment where user acceptance tests and load testing is performed to check if the application is production ready. And this process is basically continuous delivery. Now it can also make use of plugins to continuously deploy the applications to a live server. So here we saw how Jenkins can be used for continuous integration, continuous delivery, and continuous deployment by integrating with other tools. All right. Now let's move on to what is Docker. Now before we discuss about Docker, let's compare virtualization and containerization. Now the goal of virtualization and containerization is to solve the problem of the code works on my machine but it does not work on the production. Now this problem happens because somewhere along the line you might be on a different operating system. Now let's say your machine is a Windows machine and you're pushing the code to a Linux server. Now this will usually result in an error because the Windows and Linux support different libraries and packages. And that's why your code works on the development server and not on the production server. All right. Now when it comes to virtualization, every application is run on a virtual machine. Now a virtual machine will basically let you import a guest operating system on top of your host operating system. Now this way you can run different applications on the same machine. All right. Now you're wondering what is the problem with virtualization. Now one major drawback of virtualization is that running multiple virtual machines on the same host operating system will degrade the performance of the system. Now this is because the guest operating system running on top of your host operating system will have its own set of kernel and set of libraries and dependencies which take up a lot of resources like the hard disk, processor, and RAM. And another drawback is that it takes time to boot up, which is very critical when it comes to a real-time application. All right. Now to get rid of these drawbacks, containerization was introduced. Now in containerization, there is no guest operating system. So instead, the application will utilize the host operating system itself. So basically, every container is going to share the host operating system, and each container will have its own application and application specific libraries and packages. All right. So within a container, there's going to be an application and the application specific dependencies. I hope this is clear, guys. Now that we've discussed containerization, let's see how Docker uses containerization. Now, Docker is basically a containerization platform which runs applications within different Docker containers. So over here, you can see that there is a host operating system on top of which there is a Docker engine. Now, this Docker engine will basically run container number 1 and container number 2. Now, within these two containers are different applications along with their dependencies. All right. So basically within a container, every application is going to have its own dependencies installed. So it does not have to bother any other container. Okay. So basically there is process level isolation that happens here. All right. Now there are three important terminologies to remember when it comes to Docker. Now the first is the Dockerfile. Now the Dockerfile basically contains the code which defines the application dependencies and requirements. All right. And through the Dockerfile, you're going to produce the Docker image which contains all the dependencies, such as the libraries and the packages of the application. Next is the Docker container. Now, every time a Docker image is executed, it runs as a Docker container. So basically, Docker container is a runtime instance of a Docker image. So now let's look at a Docker use case. Now over here, you can see that I've created a Docker file. Now within the Docker file, I've basically defined the dependencies of the application. Now out of this Docker file, a Docker image is created. So basically the libraries and the packages that the application needs is installed within the Docker image. Now every time the Docker image is run, it runs as a Docker container. Now these Docker images are pushed into a repository known as Docker Hub. Now this repository is very similar to the Git repository wherein you are committing code into the Git repository. In this case, you're going to commit Docker images into the Docker Hub repository. All right. Now you can either have a private or public repository depending on your requirements. Now after the image is published to Docker Hub, the production team or the testing team can pull the Docker images on their respective servers and then build as many containers as they want. All right. Now this ensures that a consistent environment is used throughout the software development cycle. Now let's look at what are microservices. Now guys, I'm going to explain what microservices is because we need to deploy a microservice based application in our demo. Just to take it up a notch, I've implemented microservices. Now first, let's look at the monolithic architecture. Now over here, let me explain this with a small example. Now on the screen, you can see that there is an online shopping application which has three services: customer service, product service, and cart service. Now these services are defined within the application as a single instance. So when I say single instance, it means that these three servers will share the same resources and databases, which make them dependent on each other. Now, if they share resources, obviously they're dependent on each other, right? Now, you must be wondering what's wrong in this architecture. Now, let's say that the product service stops working because of some problem. Now, because the services are dependent on each other, the customer and the cart service will also stop functioning. So basically, if one service goes down, the entire application is going to go down. All right. Now, when it comes to a microservice application, the structure of the application is defined in such a way that it forms a collection of smaller services or microservices, and each service has its own database and resources. All right. So basically, customer microservice, product microservice, and cart microservice will have their own database and their own resources. And therefore, they're not going to be dependent on each other. All right. So they are basically independent, autonomous microservices. All right. Now let's look at a few advantages of microservices. Now the first advantage is independent development. Now when it comes to a monolithic application, developing the application takes time because each feature has to be built one after the other. So in the case of the online shopping example, only after developing the customer service, the product service can be started. So if the customer service takes 2 weeks to build, then you have to wait until customer service is completed, and only then you can start building the product service. All right. But when it comes to a microservice architecture, each service is developed independently. And so you can develop customer service, cart service, and product service parallelly, which will save up a lot of time. All right. Now, the next advantage is independent deployment. Now, similar to independent development, each service in a microservice application can be deployed irrespective of whether the service before it was deployed. So each service can basically deploy individually. Now, fault isolation. Now, when it comes to monolithic application, if one of the services stopped working, then the entire application will shut down. But when it comes to a microservice architecture, the services are isolated from each other. So in case any one service shuts down, there will be no effect on any other service. Now, the next advantage is mixed technology stack. Now, each microservice can be developed on different technology. Now, for example, the customer service can be built on Java and the product service can be built on Python and so on. All right. So basically, you're allowed to use mixed technology to build your microservices. Now, next is granular scaling. Now, granular scaling means that every service within an application can be scaled independently. So basically, the services are not dependent on each other. They can be developed, deployed at any point of time, irrespective of whether the previous service has been deployed or not. So guys, I hope you're clear with the advantages. Now over here, we're going to compare how microservices can be deployed by using virtual machines and Docker containers. All right. Now when it comes to a virtual machine, now let's say that we have a microservice application which has 5 services. Now in order to deploy these 5 services on a virtual machine, we'll need 5 virtual machines. All right. Now each virtual machine will be for one microservice. Now for example, if I allocate 2 GB RAM for each virtual machine, then 5 of these virtual machines will take up 10 GB RAM. And the microservices may not even require so much of resources. So we'll just end up wasting these resources, and at the same time, you're occupying too much disk space, which will degrade the system's performance. Now let's see how Docker containers deploy microservices. So instead of running 5 virtual machines, we can just run 5 Docker containers on one virtual machine. Now by doing this, we're saving up a lot of resources, but when it comes to a Docker container, you don't have to pre-allocate any RAM. The Docker container will just utilize the resources that are needed. And another point to remember here is that Docker containers are lightweighted. They do not require additional guest operating system. Instead, they just share the host operating system. All right, so this makes them very lightweight when compared to a virtual machine. Now let's move on to the use case. Now basically, we're going to try and understand the problem with the help of an analogy. Now over here you can see that in the favorable environment, the soil is fertile and the tree is watered at a regular basis. And as a result of this, the tree grows properly. But when the tree grows in an unfit environment where the required dependencies for growing a tree are not present, then the tree will die. All right. Now similarly, when an application runs on an inconsistent environment which does not support the application dependencies, then the application will fail. Alright guys, now let's look at the problem statement with a small example. Now let's say that a developer is building an application using LAMP stack. Now after the application is developed, it is sent for testing. Now this application runs properly on the testing server, but when it is deployed to production, a feature or the entire application fails. Now this may happen because the Apache version of the LAMP stack is outdated on the production server. So due to the difference in the software versions on the production and development server, the application fails. Now in order to get rid of the inconsistent environment problem, we're going to deploy an application using Docker. Now Docker will make sure that the environment throughout the development cycle is consistent. Now deploying a monolithic application can cause many problems. Like for example, if one of the features of the application stops working, then the entire application will shut down. So for this reason, we're going to create a microservice based application and build it on the Jenkins server and finally use Docker to maintain a consistent environment throughout the cycle. So over here, you can see that there are 4 microservices, and for each microservices, I've built a Docker file. All right. So first, let me discuss what each of these microservices do. Now the account service and the customer service are the main microservices, whereas the discovery and gateway services are supporting microservices. Now account service will basically hold the account details of a customer, and similarly the customer service will have a list of customer details. Now discovery service, which is a supporting service, will hold details of the services that are running on the application. And apart from that, it will also register every service in the application. Now what the gateway service does is, on receiving a client request, it will route the client request to the destination service. Now to be more specific, it will provide the IP address of the destination service. Okay. So now that you know how these microservices work, let's move on to the next part. Now basically these microservices are coded and their dependencies are put into a Docker file. Now for each of these Docker files, a Docker image is created by packing the Docker image with the jar files. Now how do you create a jar file? A jar file is created by running the mvn clean install command, which basically cleans up anything that was created by the previous builds, and it will run the pom.xml file, which will download the needed dependencies. So whatever dependencies are needed are stored in this jar file. Alright. Now once the Docker file is packaged with the jar file, then a Docker image is created for each of these microservices. So here we're going to use Jenkins to automate all of these processes. So Jenkins is basically automatically going to build and then push these Docker images to Docker Hub. Now after the images are pushed to Docker Hub, the quality assurance or the production team can pull these images and build as many containers out of it. Alright. So basically over here, we're going to create Docker files for each of these microservices, and then we're going to package these Docker files along with the jar files and create a Docker image for each of these microservices. Alright. Now after creating the Docker images, we're going to push these images to Docker Hub, after which the quality assurance or a production team will pull these Docker images onto their respective servers and build as many containers as they want. I hope this is clear. So now let's practically implement all of this. Alright guys, so I've logged into Jenkins and I've created 4 different jobs, each for one microservice. Alright. Now let me just show you the configuration of one of these jobs. Now let's go to account service. Let's go to configure. So guys, make sure that you enter your GitHub repository here. So go to source code management, click on Git, and then enter your repository URL over here. Now let me just show you what we're doing here. Now within the build step, I've selected execute shell. Now let me just show you how that's done. So it's simple, just go to add build step and click on execute shell. So when you click on execute shell, a command prompt will open like this and you can type this code on that. Now what I'm doing here is, first I'm changing the directory to account services because I'm running the account service within this job. After that, I'm performing an mvn clean install, which I explained earlier. Now once we're done with that, we're going to build a Docker image and then we're going to push it to your Docker Hub account. Now these are the credentials to my Docker Hub account, where Zulekha is the username of my Docker Hub account and Edureka-demo is a repository that I've created in my Docker Hub account. Then click on apply and save. Now, apart from account services, I've built jobs for the other services as well. Now, let me just show you customer service also. Let's go to configure. Now, within the source code management, like I said earlier, enter your repository URL. After that, go to the build steps. Over here, you can see that I'm changing the directory to customer service. Then I'll perform MVN clean install. So next, I'm going to build Docker images. Now, over here, customer is basically the tag of the image. So whenever this image is going to get pushed to my Docker Hub, the tag is going to be customer. All right. Now, similarly for account service, the tag was account. Now I've done the same thing for all the other jobs. All right. Click on apply and save. Now guys, in order to run these 4 jobs as one workflow, I've created a build pipeline. Now this pipeline will basically execute these 4 jobs in one workflow. Now if you want to know how to create a build pipeline, please refer the video in my description box. I'm going to leave a link where you can see how to create a build pipeline. All right. Now let me just show you my GitHub account. Now over here you can see that I have account service, customer service, discovery service, gateway service, and also there's Zipkin service. Now guys, this service basically keeps a track of all the other services. So it's going to keep a track of where the requests are going and how the requests are getting sent from account service to customer service. Now within account service, you can see that I have a Dockerfile, Jenkins file, and a pom.xml file. All right guys, now let's start building our application. Just click on run. Now here you can see that account service is getting executed. Now let's individually go to account service first. Let's click on account service. All right, here you can see that it's building this job. So basically here what we're going to do is we're going to change the directory to account service. After that, we're going to perform an MVN clean install, and then we're going to build an image and push that image to Docker Hub. All right. So guys, remember to provide your Docker Hub credentials. Now this job has successfully executed. Now after this job has executed, it's going to trigger the next job, which is customer service. Now let's look at the build pipeline. Now over here, this has turned green because account service has completed execution. Now customer service is currently running. So let's look at the build in customer service. So after the account service has completed execution, guys, you can also check the output of account service from here. Scroll down, it says success. Now after account service has finished, let's trigger the customer service. So customer service starts executing now. Now let's individually look at customer service. Now over here you can see that customer service is building. Now in this job, we're basically going to change the directory to customer service. After that, we're going to perform an MVN clean install command, and then we're going to build and push a Docker image to Docker Hub. All right. So once this is completed, the next job in the pipeline will get executed. Okay. All right, guys. So this is successfully executed. Now you can see that customer service has also turned green, which means that it has successfully finished building. All right. All right, guys. So you can see that customer service has completed execution. Now let's trigger the build of discovery service. Now let's look at the output of discovery service. So guys, you can see the output from here itself. Let's click on console. All right, so within the discovery service again, we're going to change the directory to discovery service. After that, we're going to perform an MVN clean install. And once we're done with that, we're going to build an image and then we're going to push it to Docker Hub. Guys, make sure you have entered your Docker Hub credentials. All right, guys, so this is completed execution. You can see that it says success. Now it's triggering the new build, which is gateway service. So here you can see that gateway service has started execution. Let's look at the console output. All right, so similarly in gateway service, first you're going to change the directory to gateway service. After that, you're going to perform an MVN clean install command. And once you're done with that, you're going to build an image and then push it to Docker Hub. So guys, gateway service has successfully completed execution. Now the build pipeline has fully turned green, which means that the entire workflow has completed execution. Now let's go to our Docker Hub account and see if all these images got pushed to Docker Hub. All right. So I'm going to my Docker Hub. Now let's go to the Edureka demo repository. Now over here, you can see that the account, customer, discovery, and gateway services, all of these 4 images are pushed to Docker Hub. All right. So with this, we've come to the end of the demo. Now, after pushing these images to Docker Hub, any quality assurance team or any testing team can pull these images onto their respective servers so they can easily deploy this to production.
Why use Node.js with Docker? So as it speeds up the application deployment process, deployment becomes easier where there are a lot of things which you don't need to look at while deploying. If it runs locally on your Docker container, surely it will run on any other machine or any other server on any Docker container. Application portability increases. You're developing on Windows, deploying on a Linux. You don't need to care about all that. If it works in one container, it will work in another container. Simplifies the version control process, promotes component reuse, very light footprint, and puts less overhead on the app. Now let's start with a simple Node app. I'll do npm init, I'll create an empty project. So we have a empty package.json file. We'll go ahead and install Express. So we'll try to create a very simple hello world application using Express. So it will be a web application. Express is a very popular web framework created on Node. So if we open the package.json, we can see the name of the application, and mainly in the dependencies we have Express listed over here. Okay, we'll create our app.js file. That will be our app. Let's write our application over here. First, we'll import the Express module. We'll use that object of the Express module to create our app object. We'll use the app object to listen. So this is where we're actually starting our HTTP server, and it has to listen on a particular port. We can use any port number over here. 3000. The port numbers that are commonly used are 3000, 8080, or 888 four times. Basically any number, any port that is open on your system. And then finally we'll just create one route where the app would be giving a response if that route is hit in the browser. We'll just send hello from Docker. Okay, I think that's all we need. Just a simple demo. We'll try and run this. Okay, app listening on 3000, no errors. We'll open this. Okay, hello from Docker. We have it. Great. So I'll close this now. Now let's Dockerize this application. So as you remember, the three basics of Docker: Dockerfile, Docker image, Docker container. We need a Dockerfile over here. Just write Dockerfile. No need to give any extension. Okay, it's still a text file. We'll open this. Now this is where we will tell Docker what to do. Before moving on with the commands, this is the Docker Hub website, hub.docker.com. I suggest you please create an account on this website. Or I guess when you go to download the Docker, I think it'll tell you to create an account or Docker ID. So once you have an account on hub.docker.com, you go to explore, and this is where you see all the popular images of Docker. So anytime you're working with any language platform, for example, let's say NodeJs in our case, or PHP or .NET, or using in databases, let's say like over here, Postgre or Couchbase, all these standard technologies, they have their own official Docker images already on the Docker Hub. You don't need to create images for these from scratch because these are already available to use. So in our case right now we need to use the node on the Docker. So you just search for node. Okay, and as you can see, we have node. It's an official image. Official image means this particular Docker image is created by the people who create node. Okay, like Mongo Express. So this Docker image is created by the people who actually create the Mongo Express library. Okay, and then obviously there are verified publishers, like for example Microsoft, and anybody can upload a Docker image over here in the hub. Okay, and you can also filter them by the categories, the kind of image that you want, the supported OS, supported architectures, etc., etc. So for us, all we need is this node Docker image. So this is the image upon which our image will be built and the container would be working. Okay, so coming down, how to use this image. Okay, so you need to go to this guide. It'll open the GitHub page of node. Okay, so over here, create a Docker file in your Node.js app project. Specify the node base image with your desired version. This will be the first line of our Docker file. So this is the official Docker image that we want to use, and this is the version of that Docker image, not the version of Node. You can have a look at all the supported Docker image versions of Node. I think 10 is good for us. I think it is the latest one. We don't actually need to go and dig into which version supports what, but this is good for us for now. Okay, moving forward. Now, what do we want to tell Docker to do? First, we'll create a working directory for the Docker. So this is where we are telling Docker to like create a app directory for itself, where whatever work or things the Docker needs to do for our application, Docker can put it inside the app folder. We'll tell Docker to copy our package.json. And if you remember, Dockerfile is inside our app folder. Okay, so this is inside our app folder. So we don't need to give any paths for any files that we are referencing. So I can directly say copy package.json inside the app. Okay, run npm install. So this is like very easily understandable commands. Copy package.json inside the app folder and then run the npm install. So this command will be run inside this folder of the Docker container. And what npm install would do is whatever packages are listed inside package.json, if you remember, we have Express. So those packages will be installed. Okay. Then we tell Docker to, now dot over here means the current directory the file is in. So this is our current directory. And we're telling Docker to copy everything from the current directory to the app folder and then run the command node. So this is the command which even we use to run the node app. Okay, so this is what Docker would run inside its container. And lastly, if you remember, we had a port number which we were using. For us, it's 3000. So we need to expose a port number as well. Okay. Yeah, so I think this is it. We are done. Now we'll try and run this inside Docker. Okay, so first we need to build the Docker image. We only have a Docker file right now. So next step is to build a Docker image from the Docker file. We need to give a name to the Docker image. I'll name it Hello Docker. Okay, because the mistake that I did is to put a dot in the end, suggesting the current directory we are in. Okay. So as you can see, these are the commands that is running one by one. It's going through all the steps from node 10, work dir, copy package.json, run npm install. And this over here, it might take a while because it needs some time to download the packages listed in package.json. Okay, and then it went through everything, fine. Okay, now we have the image created. Now we need to run the Docker app. So the command for that is Docker run. Also, again, we do have the Docker documentation online, which you can refer anytime. Okay, so any language, any platform, technology you learn, always try and refer to the official documentation. If you can like refer from it, study from it, that is the best always. Another thing, even in the terminal, in the console, you can always look at help. It'll list out all the options that you can give to the command. So these are the options for the run command, not the Docker command, the run command. Okay, all the options for the Docker command would be, okay, Docker help. Okay, so these are all the subcommands and options that you can use with Docker. So moving on, we're going to run the image Docker run. Now IT means we want the Docker to run in an interactive shell. So if you look at the options, that's not required, but it's good. Okay, so -i, -i interactive keeps standard input open even if not attached. And T, allocate a sudo TTY. TTY means a terminal. So Docker run, and we want to tell Docker which port we are exposing and which port we are using inside the application. So again, if you look at help, there is this P option, publish list, publish a container's port to the host. So we'll be creating a Docker container which is running on the host. Host is our Windows operating system. We need to tell which port the Docker is exposing and which port is being used by the app inside. This port 3000 over here and this 3000 over here can be different. Okay, it's not compulsory that they should be the same all the time. We can have 8000 over here and 3000 over here, and all we need to do is map it in the command. But over here it's the same. So Docker run. So IT, what basically would do is, I'll show you when the command runs. So this first 3000 is the port number we listed in the Docker file, the port exposed by Docker, and the second one is what our app is using. Okay, now our image name was hello Docker. Let's run this. Okay, we have some error. It says it's already allocated. Okay, we'll try another port. This may be due to because I was already doing some tests and running this. Now, once I've changed the Docker file, I need to rebuild my image. So we'll run the build command again. Okay. Now I'll run the image. Docker run interactive 888 and 3000 inside the application. Hello Docker. And we have running. Now let's try and run again. Okay, the site can't be reached. Now, if you remember, we have this Docker toolbox thing open, and it has its own machine IP 192.168.99.100. 192.168.99.100, port number 3000. Okay, so I'm sorry, but I had another instance running already on that port. That is why it did not allow me to run that Docker image on that particular port. I changed my Dockerfile port to 8888, and that is the one that is being exposed. So for us over here, the port number should be 8888, and that is where I see the message hello from Docker, which is what we have used. Hello from Docker. The reason why 3000 is working is because there's already another Docker instance running in the background, which I didn't close, and it says hello world. So there's actually another Docker container already running on that port, and that is why it did not allow me to run the Docker container on this port. So as you can see, I already had one running, which I forgot about. Sorry about that. So our app is running right now on the port 8888, and that is the port exposed by Docker to my operating system, which is Windows. But the port on which the app is running inside the Docker container is 3000. So the app is still running on 3000, but Docker is exposing our app to port 8888, and that is what we have mapped over here. And minus -it means it's interactive. Right now, this message, what you're seeing, is actually from a console inside the Docker container. This is not from our own CMD or command line. Okay, so now I can press Control C to end this. Okay, yeah. So as you can see, it has ended. Okay. So I was able to give it the command to end it, and that command went to the console of Docker container. So I hope you enjoyed it, the small demo. Okay. And yeah, this is what we actually did basically: create the Node.js app, create the Docker file, build the image, and then execute it.
Let's understand what is Kubernetes. So you can imagine as the number of deployable application components in our system grows, it becomes really hard to manage them all. Google was probably the first company that realized it needed a much better way of deploying and managing their software components and their infrastructure to scale globally. It is also, repeat, it is one of only a few companies in the world that runs hundreds of thousands of servers and has had to deal with managing deployments on a very massive scale. So this has forced them to develop solutions for making the development and deployment of thousands of software components manageable and cost efficient. So through the years, Google developed an internal system called Borg, which was later called as Omega, that helped both application developers and system administrators manage those thousands of applications and servers. Now, in addition to simplifying the development and management, it also helped them achieve a much higher utilization of their infrastructure, which is really important when your organization is that large. Now, when you run hundreds of thousands of machines, even tiny improvements in utilization mean savings in millions of dollars. So the incentives for developing such a system are very clear. After having kept Borg and Omega secret for a whole decade, in 2014, Google introduced Kubernetes, an open source system based on experience gained through Borg, Omega, and other internal Google systems. Kubernetes is simply an open source software system that allows you to easily deploy and manage containerized applications on top of it. So it relies on the features of Linux containers to run heterogeneous applications without having to know any internal details of these applications and without having to manually deploy these applications on each host. Because these applications run in containers, they do not affect other applications running on the same server, which is extremely critical when you run applications for completely different organizations on the same hardware. This is of paramount importance for cloud providers because they strive for the best possible utilization of their hardware while still having to maintain complete isolation of hosted applications. Kubernetes enables you to run your software applications on thousands of computer nodes as if all these nodes were a single enormous computer. It abstracts away the underlying infrastructure and by doing so, simplifies development, deployment, and management for both development and the operations teams. Deploying applications through Kubernetes is always the same, whether your cluster contains only a couple of nodes or thousands of them. The size of the cluster makes no difference at all. Additional cluster nodes simply represent an additional amount of resources available to deployed applications. So let us understand the core of what Kubernetes really does. So this is the simplest possible view of a Kubernetes system, okay? The system is firstly composed of a master node and any number of worker nodes. When the developer submits a list of applications to the master, Kubernetes deploys them to the cluster of worker nodes. So what node a component lands on doesn't and shouldn't matter, neither to the developer nor to the system administrator. The developer can specify that certain applications must run together and Kubernetes will deploy them on the same worker node. Others will be spread around the cluster, but they can talk to each other in the same way, regardless of where they are deployed. So Kubernetes can be thought of as an operating system for the cluster. It relieves application developers from having to implement certain infrastructure-related services into their applications. Instead, they rely on Kubernetes to provide these services. This includes things such as service discovery, scaling, load balancing, self-healing, and even leader election. Application developers can therefore focus on implementing the actual features of the applications and not waste time figuring out how to integrate them with the infrastructure. On the other hand, Kubernetes will also run your containerized application somewhere in the cluster, provide information to its components on how to find each other, and keep all of them running. Because your application doesn't care which node it's running on, Kubernetes can relocate the application at any time, and by mixing and matching applications, it achieves a far better resource utilization than is possible with manual scheduling. So as you can see that Kubernetes exposes the whole data center as a single deployment platform. So now let's talk about some of the most important Kubernetes components. So Kubernetes includes two major players. The first one is masters and the second one is nodes. The master is basically the heart of Kubernetes. It controls and schedules all of the activities in the cluster. Nodes, on the other hand, are the workers that run our containers. So the master includes the master, as you can see in the image, includes the API server, control manager, scheduler, and etcd. All components can run on different hosts with clustering. However, it can also run on the same node. Firstly, we will talk about API server. The API server, what it really does is it provides an HTTP or HTTPS server, which provides a RESTful API for the components in the Kubernetes master. For example, we could use get to get the resource status or post to create a new resource. We can also watch for updates for resources. The API server stores the object information in etcd, which is Kubernetes backend data resource. So now let's move ahead and talk about Control Manager, also known as Kube Control Manager. Okay, now the Control Manager is a set of control loops that watch the changes in the API server and ensure the cluster is in its desired state. Let me explain this with an example. Now the deployment controller ensures that the whole deployment is run on the desired amount of containers, whereas the node controller responds and evicts the pod when the nodes go down. The endpoint controller, on the other hand, is used to create a relationship between services and pods. The service account and the token controller are used to create a default account and API access tokens. Now that we know what is controller manager, the next subcomponent of the master component is the etcd. Now, etcd is an open source distributed key value store where Kubernetes stores all of the RESTful API objects. etcd is responsible for storing and replicating data. The next and the last subcomponent is the scheduler or kube scheduler. Now, the scheduler determines which nodes are suitable candidates for pods to run on. It uses not only resource capacity and the balance of the resource utilization on the node, but also node affinity, times, and toleration. Now that we've discussed the master subcomponents, let's go ahead and talk about node components. Now, node components are provisioned and run on every node, which report the runtime status of the pod to the master. Firstly, we will talk about kubelet. So kubelet is a major process in the nodes. It reports node activities back to Kube API server periodically, including pod health, node health, and liveliness probe. As the diagram shows, it runs containers via container runtimes such as Docker. The next subcomponent in the node components is the proxy or kube proxy. Now, the proxy handles the routing between a pod load balancer, which is also known as service, and the pods. It also provides routing from external internet to services. There are basically three proxy modes, that is user space, IP tables, and IPVS. I'll be talking about all of these. The first one is the user space mode, which creates a large overhead by switching the kernel space and user space. On the other hand, we have the IP tables mode, which is the latest default proxy mode. It changes the IP tables network address translation in Linux to achieve routing TCP and UDP packets across all the containers. IP virtual servers, that is IPVS, was general available in Kubernetes 1.11 and is used to address performance degradations when running more than 1,000 servers in a cluster. So basically, it runs on a host and acts as a load balancer, forwarding the real connection to real servers. IPVS mode will fall back to IPv tables in some scenarios. The last component is Docker. As we've already discussed, Docker is a container runtime implementation, and Kubernetes uses Docker as a default container engine, and it also supports other runtimes such as RKT and runc. So let us understand how the node and the master components really interact with each other. The client uses kubectl, which is a command line interface to send requests to the API server. The API server, on the other hand, is a hub between the master components, will respond to the client requests and push and pull the object information from etcd. Now, if a new task is created, such as run pods, the scheduler will determine which node should be assigned to do that task. The controller manager monitors the running tasks and responds if any undesired state occurs. The API server fetches the logs from pods via the kubelet. Finally, the API server fetches the logs from pods via the kubelet. Now that we know the components of Kubernetes and we've discussed how they interact with each other, let's move on to the next part of this session and talk about Kubernetes benefits. Now, if you have Kubernetes deployed on all your servers, the operation teams do not really need to deal with deploying your applications anymore. Because a containerized application already contains all it needs to run, the system administrators don't really need to install anything to deploy and run the application. Now, on any node where Kubernetes is deployed, Kubernetes can run the application immediately without any help from the system administrators. This brings to the first benefit of Kubernetes, that is simplifying application deployment. Because Kubernetes exposes all its worker nodes as a single deployment platform, We had already seen this in the previous part of the session. Application developers can start deploying applications on their own and do not really need to know anything about the servers that make up the cluster. In essence, all the nodes are now a single bunch of computational resources that are really waiting for applications to consume them. A developer does not really usually care what kind of server the application is running on, as long as the server can provide the application with adequate system resources. Certain cases do exist where the developer does care what kind of hardware the application should run on. Now, if the nodes are heterogeneous, you will find cases when you want certain applications to run on nodes with certain capabilities and run other applications on others. Let me explain this with an example, okay? Now, if one of your applications may require being run on a system with SSDs instead of HDDs, while other applications run fine on HDDs. In such cases, you obviously want to ensure that particular app is always scheduled to a node with an SSD. Now, without using Kubernetes, the system administrator would select one specific node that has an SSD and deploy the application there. Now, let's consider a scenario where you're using Kubernetes. Instead of selecting a specific node where your application should be run, it is more appropriate to tell Kubernetes to only choose among nodes with an SSD. So this is the first benefit. It simplifies application deployment. The second benefit is that it helps in achieving better utilization of hardware. By setting up Kubernetes on your servers and using it to run your applications instead of running them manually, you have decoupled your application from the infrastructure. When you tell Kubernetes to run your application, you're letting it choose the most appropriate node to run your application on based on the description of the application's resource requirements and the available resources on each of these nodes. Now, by using containers and not typing the application down to a specific node in your cluster, you're really allowing the application to freely move around the cluster at any point of time, so the different application components running on the cluster can be mixed and matched to be packed tightly onto the cluster nodes. This ensures the node's hardware resources are utilized as best as possible. The ability to move applications around the cluster at any time allows Kubernetes to utilize the infrastructure much better than you can achieve manually. Humans aren't great at finding optimal combinations, we all know that, especially when the number of all possible options is extremely huge, such as when you have many application components and many server nodes they can be deployed on. Computers can obviously perform this work much better and faster than humans. Now, the third benefit of Kubernetes is health checking and self-healing. Having a system that allows moving an application across the cluster at any time is also valuable in the event of server failures. As your cluster size increases, you will deal with failing computer components even more frequently. Kubernetes monitors your application components and the nodes they run on and automatically reschedules them to other nodes in the event of a node failure. This frees the operations team from having to migrate app components manually and allows the team to immediately focus on fixing the node itself and returning it to the pool of available hardware resources instead of focusing on relocating the application. Now, if your infrastructure has enough spare resources to allow normal system operation even without the failed node, the operation teams doesn't even need to react to the failure immediately, such as at 3 a.m. in the morning. They can sleep tight and deal with the fail node during the regular work hours. Now, this brings us to the last benefit of Kubernetes, that is automatic scaling. Using Kubernetes to manage your deployed applications also means the ops team do not really need to constantly monitor the load of individual applications to react to sudden load spikes. As previously mentioned, Kubernetes can be told to monitor the resources used by each application and to keep adjusting the number of running instances of each application. If Kubernetes is running on cloud infrastructure, where adding additional nodes is as easy as requesting them through the cloud provider's API, Kubernetes can even automatically scale the whole cluster size up or down based on the needs of the deployed applications. Now that we have discussed the benefits of Kubernetes and how you can utilize it to the maximum, let us move ahead to the next part of the session and prepare the Docker Kubernetes environment. So firstly, we will have to have a system running Ubuntu 18.04 or Ubuntu 20.04. Currently, I'm working on a Linux VM that is Ubuntu 18.04. You will also have to have a user account with privileges. So what I'm going to do now is I'm just going to open my terminal. Now, before we, install whatever requirements that we'll need, we are also going to execute some basic commands. So before installing any software, what you need to do is you need to update and also upgrade the system if necessary that you are working on. To do so, you can just run the apt get command. Okay, once you have successfully updated your system, what we're going to do now is we're going to make sure to install or check whether you already have the required packages, that is curl package and also the transport HTTPS package. Okay, so for this, what I'm going to do is I'm just going to execute the command apt get install curl. Okay, and this will install curl for me. So since I already have the newest version, nothing has been, upgraded or installed or removed. Okay. Now, next, what we're going to do is we are going to execute the apt get command to install transport HTTPS. So even the apt transport HTTPS is already the newest version. So I don't have anything that is going to upgrade or install or even remove. So if you don't have curl or if you don't have apt transport HTTPS, then it is going to go ahead and install all of these for you. And it's going to take some time, obviously. So you'll have to be patient. Now I'm just simply going to clear my screen. The next step is to install VirtualBox Hypervisor. So if I haven't mentioned this already, you will need a virtual machine in which you can set up your node clusters. Okay. That is, you can set up your single node cluster with Minikube, or you can create your own clusters and scale them up. For this, it is really, really important that you have a virtual machine that is already set up in your VM or any of your Linux machine. So what we're going to do is we are going to install VirtualBox on Ubuntu. So for this, we're just going to execute the command apt install VirtualBox ext pack. And you can already see that VirtualBox is already the newest version and it is already installed in our VM. So if you're installing VirtualBox for the first time, you'll just be prompted with another window that says, do you want to continue this installation process? You can just confirm it by clicking Y and hitting enter. Then you'll be prompted with another window with the license agreement on the screen. So you can just press tab that is present on your keyboard and then enter to continue. Okay, the installer will then ask you to agree with the terms of the VirtualBox PUEL license by selecting yes. And once that is done, you can just wait for the installation to complete and then move on to the next step. Now what we're going to do is we are going to be installing two tools. One is Minikube and the other one is kubectl. For this, I'm just going to open my web browser and we'll check out the various commands that we can use to install Minikube and kubectl. So if I haven't mentioned already, kubectl is the command line interface that will allow you to make changes, access, and really access Kubernetes as a whole. So what we're going to do is I'm just going to look for install kubectl Minikube. If you scroll down, you can see there's an option that says install tools Kubernetes. And this is your official website from where you could download all of the tools. So I'm just going to click that and this will immediately redirect me to a page that will allow me to install kubectl on Linux, Mac OS, and on Windows. So if you are working on Mac OS or Windows, this is the right option for you. But if you're working on Linux, like I am, I can just click on install kubectl on Linux. And if you scroll down, you can also install Minikube. Okay. So Minikube is just a tool that really lets you run Kubernetes locally. It just runs a single node Kubernetes cluster on your PC so that you can try out Kubernetes or for daily development work as well. But no one really uses, Minikube for local development. Then it's not suggested. It's not really suggested to work on Minikube if you're actually, using it for your daily development work. So I'm just going to click on this view Minikube get started guide. So before we, install Minikube, what we're going to do is we're going to set up kubectl. Okay. So for this, I'm just going to switch to this page and I'm going to quickly scroll down. There are three ways that you can install kubectl on Linux. The first one is kubectl binary with curl on Linux. The second one is by using native package management. The third one is by using other package management. So I would suggest you to install kubectl binary with curl on Linux, and you can execute all of these commands, right? You can execute the step number 1, that is to download the latest release with the command. And if you want to download a specific version, you can simply replace the command with the portion of the command with a specified version, okay? And there's also an example as how you could do that. So if you just want to download the latest version, you can execute the first command. Then you can validate the binary, okay? You can just download the kubectl checksum file and then validate it. If it is valid, the output will say okay. If it hasn't, then it says kubectl has been failed. Then you can just figure out where you have made the mistake. So moving on, then you can install kubectl, right? So this is the location as to where kubectl will install. And finally, you can just test to ensure the version you have installed is up to date. That's what I'm going to do. I'm going to copy this. Since I have already kubectl installed in my VM, I'm just going to check the version. You can see the client version, you can see the Git version, you can see the build date, you can see the Go version. All of the information is given here. So now what I'm going to do is I'm going to switch back and I'm going to switch the tab to Minikube start. So as I've already mentioned, Minikube is just local Kubernetes, right? It's focused on making it easy to learn and develop for Kubernetes. All you will need is Docker, a container, or a virtual machine environment, and Kubernetes is a single command away. So there are some prerequisites, right? You'll have to have 2 CPUs or more. You have to have 2 GB of free memory. You'll need to have 20 GB of free disk space. You'll need internet connection. You'll need a container or virtual machine manager such as Docker, Hyper-V, HyperKit, all of that, VirtualBox, etc. So we have successfully downloaded VirtualBox, right? But we haven't downloaded Docker. So I'm just going to open a tab. I'm just going to click on Docker. So this will redirect me to my official website of Docker. So I'm just going to click on that. So once that is done, I'm just going to click on this option that is available on the right-hand corner that says Get Started. So this will allow you to set up Docker, right? So there are 3 different types of Dockers, okay? There's Docker Desktop, there's Docker Hub, there's Play with Docker, which is basically a cloud-based Docker environment, whereas Docker Hub is a cloud-based application registry. So it is like, GitHub, where you can share your development results and also share what you've been working on and collaborate with your team online. Whereas Docker Desktop really allows you to, work locally and work for yourself, right? Just create a local environment and do what you have to do. So what we're going to do now is we're just going to download what we need. You can download for Mac Intel chip, you can download for Mac Apple chip, you can download for Windows, you can view the Linux engine. So I'm just going to click on that. So once that is done, you can just pick on the community that you're working on, whether it's Fedora, CentOS, or Azure, Ubuntu. So since we are working on Ubuntu, you can just click on, Ubuntu community. So once this is done, you can read a description, you can see the reviews, and you can also see the resources. So once you click on the resources, you can see the detailed installation instructions, and this will allow you to install Docker engine on Ubuntu. So there are some OS requirements. You can also uninstall the older versions. And finally, you can just install Docker. So now to set up Docker, all you have to do is follow these instructions. You have different ways of installing Docker. You can choose the one which will allow you to install Docker using the repository. So firstly, you will have to set up the Docker. And once that is done, then you will have to add the Docker's official GPJ key. And then all you have to do is you will have to use the command to set up the stable repository, okay? And you have to check the architecture of your Linux machine, okay? Whether it is ARM64 or it is AMD64. So based on the architecture of your Linux machine, then you just choose the final command to set up the repository and you can execute it in your terminal, okay? Once that is done, you will compulsorily have to install the Docker engine using the install docker c docker ce cli containerized.io. And if you have a specific version that you'd like to install, you can just do that too. And if you just don't want to, then you can just skip the step. And finally, you can just verify if the Docker engine has been successfully installed in your Linux machine by executing the run command, okay? So that's what we're going to do. So I'm just going to check if Docker has been installed, and you can see that it says hello from Docker. So all of the information, a brief, summary of what you can do with the help of Docker is given below. So you know that Docker is up and running. So that's great. Now that we have installed Docker, let's switch back to Minikube. So all of my requirements have been successfully satisfied. So now what I'm going to do is I'm simply going to install Minikube. For this, I'm just going to, click on the operating system, the architecture type, and then the installer type. Okay. Once that is done, you can just copy this command that is here. So if it is a Debian package that you want to install, then you can click on that. If you want an RPM package, you can click on that. And whatever is well suited for you, just pick on that and install it. Okay. Execute these commands on your Linux terminal and get them installed. And once that is finally done, you're just going to execute the command sudo minikube start. Okay. But before we start our default minikube cluster, let's, experiment with Docker a bit, right? So what we're going to do is, using the run command, you can run many images that you'd like to. Okay. So we just ran hello world. You can also run busybox. Okay. And print hello world. So if you're unfamiliar with busybox, that's okay. It is basically a single executable that really combines many of the standard Unix command line tools such as echo, ls, gzip, and so on. So also, instead of the busybox image, you can use any other full-fledged OS container image such as Fedora, Ubuntu, or other similar images, as long as it includes the echo executable. You can see that we have successfully executed the hello world command. Okay. You can also create a Docker file for the image. You can build the container image. There's a lot of things that can really happen. I'm just going to clear the screen. Now what I'm going to do is I'm going to start my Minikube cluster, which is the default Kubernetes cluster. So it's going to take some time to start the cluster. So once it's done, we'll get back to the next part. Now you can see that kubectl is now configured to use the Minikube cluster, which is again the default cluster of Kubernetes. And also there is a default namespace that has been created. So now I'm going to clear the screen. So now what I'm going to do is I am going to use the kubectl pod command, and I'm going to use the A flag to display all of the namespaces that have been created in Kubernetes. As you can see, all of the output, you have default namespaces, you have Ingress, NGinx, you have Kube System, Prometheus. All of these are namespaces that have been created, and they have a particular name. They have the status when it restarts, whether it's ready. So the status, as you can see, some of them are running, some of them are on error, some of them are completed. All of the information regarding these namespaces are given here. Now I'm just going to execute the Minikube dashboard command. So this will activate the dashboard for Kubernetes. So once that's executed, you can access the URL via a web browser. So now the dashboard is enabled, and you can see that the proxy has been launched. Now this URL, what you can do with it is you can open it in a web browser. So as you can see, the deployments, workload status, you can see on the left-hand side the workload, services, config and storage, clusters, custom resource definition, settings, and about. So you can access to any of these, and you can see the status. You can literally monitor your entire cluster based on this dashboard. And if you scroll down, you can see there's deployments, there's pods, the deployments that have been created in the past, and also the pods that you have created in the past before. If you keep scrolling down, you have stateful sets, ingresses, you have the services that are currently created and have been running, persistent volumes, secret storage classes, all of the services that Kubernetes really offers to you. So I'm just going to switch back to my terminal, and I'm just going to clear the screen. Once that is done, what I'm going to do is, so I'm just going to use the docker pull Ubuntu command, and this will pull the Ubuntu image from Docker. So as you can see that the Docker is going to pull the image Ubuntu from library Ubuntu. Now I'm going to use the run command -it-d to run Ubuntu successfully. You can see that Ubuntu has been containerized and run successfully in the container with the container ID D8, 3D047, so on. Just going to use the docker ps command and just get the information of all the containers. Use the A flag for more information. I'm going to clear the screen and I'm going to execute the docker images command, which will give me an overview of what all images are running in Docker. And you can see that the Ubuntu image has been created just 4 days ago, and it is the latest image that has been pulled from the Docker website. And that's the latest image that has been pulled from the Docker website. I'm going to clear the screen. So with this, we come to the end of this session. Let's move on to the next part of the session of Kubernetes and Docker. So now let's discuss a case study on how Pinterest really used Docker and Kubernetes together and faced the challenges that they faced. So after almost 8 years in existence, Pinterest had grown into 1,000 microservices and multiple layers of infrastructure and diverse setup tools and platforms. Back in 2016, the company launched a roadmap towards a new compute platform led by the vision of creating the fastest path from an idea to production without really making engineers worry about the underlying infrastructure. So this was the challenge that they faced back in 2016 when the company was at its boom. So once they faced this challenge, they had to find a solution. The first phase involved moving services to Docker containers. Now, once these services went into production in early 2017, the team began looking at orchestration to help create efficiencies and manage them in a decentralized way. After an evaluation of various solutions, Pinterest went with Kubernetes. Now, by moving to Kubernetes, the whole team was able to build on-demand scaling and new failover policies in addition to simplifying the overall deployment and management of a complicated piece of infrastructure such as Jenkins. They not only saw reduced build times but also huge efficiency wins. For instance, the team reclaimed over 80% of capacity during non-peak hours. As a result, the Jenkins Kubernetes cluster now uses 30% less instance hours per day when compared to the previous static cluster. So there is a relationship between Kubernetes and Docker. We're going to discuss them now. So if Docker is containers and Kubernetes is container orchestration, why would anyone ask, should I use Docker or Kubernetes? Now, in reality, the two tools are actually complementary to each other and help build cloud native or microservice architectures. Docker is mostly used during the first days of a containerized application. It really actually helps build and deploy the application's container or containers. In cases where the application's architecture is very simple, Docker can address the basic needs of the application's lifecycle management. Now, if the case or the scenario where the application is broken down into multiple microservices, with each of these services having their own lifecycle and operational needs, Kubernetes comes into the picture. It is not only used to create the application containers, it actually needs a container platform to run, and Docker being the most popular one, it runs on that. Kubernetes integrates with a large toolset built for and around containers and uses it in its own operations. Containers created with Docker or any of its alternatives can be managed, scaled, and moved by Kubernetes, which also ensures failover management and health maintenance of the system. As you can see in the diagram, the container lifecycle has been explained. You can see that in the Docker, there is the build and deployment of the application that has been successfully done. Once the Docker has been successfully deployed, then Kubernetes takes the responsibility to monitor and scale the application. There are great benefits to using Kubernetes with Docker. Firstly, the applications are easier to maintain as they are broken down into smaller parts. Also, these parts run on an infrastructure that is much more robust, and the applications are more highly available. Here, applications are able to handle more load on demand, improving the user experience and reducing resource waste. As applications become more scalable, there is no need to pre-allocate resources in anticipation of load peak times. Now here, both Docker and Kubernetes are backed by strong open source communities and are part of the Cloud Native Computing Foundation, a Linux Foundation project aiming to advance container technologies and align the industry around specific standards. Now that we understand that Docker and Kubernetes have a really great relationship together, let's move ahead and address the main topic of today's session, that is Kubernetes versus Docker. Firstly, we will compare them in terms of setup and installation. As you can see on the screen, Kubernetes really requires a series of many manual steps to set up the master and worker node components in a cluster of nodes. It's really hard and complicated to install Kubernetes. But on the other hand, that is installing Docker is a matter of one-liner commands on Linux platforms like Ubuntu and CentOS. So compared to Kubernetes, Docker is much more easy to install and set up. Moving on to the next difference, that is logging. Kubernetes provides no native storage solution for log data, whereas logging driver plugins are available in Docker 17.05 and much higher. So in terms of monitoring Kubernetes applications, you can use various open source tools like Prometheus, Grafana, InfluxDB, etc. Docker, on the other hand, also has tools like Prometheus, Docker API, etc. for monitoring purposes. Kubernetes supports up to 5,000 nodes, whereas Docker supports only up to 2,000 nodes. And in terms of compatibility, Kubernetes is more comprehensive and highly customizable, whereas Docker is less extensive and customizable. So for all of y'all who don't know what load balancing is, it is an efficient distribution of network or application traffic across multiple servers in a server farm. So usually each load balancer sits between client devices and backend servers, receiving and then distributing incoming requests to any available server capable of fulfilling them. As you can see in Kubernetes, you must manually configure your load balancing settings, whereas in Docker, it does auto load balancing. That is, it is automated. Now, there are various companies that use Kubernetes and Docker. Companies like Google, Shopify, Udemy, Slack, Robinhood, Delivery Hero, Stackshare, Nubank, etc. use Kubernetes every day. On the other hand, various companies like Twitter, Business Insider, Spotify, PayPal, eBay, Oxford University Press, the New York Times, New Relic, all of these companies and organizations make use of Docker. Now that we've compared Kubernetes and Docker, let us understand in what situation to use Kubernetes and Docker. So what are the choices when it comes to Kubernetes and Docker? What happens if you do choose to use only one and not the other? So there are three scenarios that I'll be addressing. The first one is Docker without Kubernetes. The second one is Kubernetes without Docker. And the third one is Kubernetes with Docker. We've already discussed the benefits of using Kubernetes with Docker, but we'll just brief up that again. So firstly, let's understand the scenario where Docker can be used without Kubernetes. Docker by itself will allow you to build container images, manage them in a registry, run containers, and communicate with them, and eventually put them together in a multi-container application using Docker Compose. So is Docker all that you need? Now, when it comes to producing and managing container images and putting containers into operation at the runtime level, the answer for the most part is definitely yes. It has become the industry standard for creating containers and getting them off the ground. Now, under Docker's current developer-centric definition of its mission, however, it has moved away from earlier attempts to go beyond its core functions. It is no longer attempting to compete with Kubernetes and other companies at the infrastructure or orchestration level. Now, let's talk about the second scenario. Kubernetes does not include functionality for creating or managing container images, and it does not by itself run containers. It really needs to work with an external container source and runtime. It is, however, capable of using containers from a variety of sources, and it is compatible with runtimes other than Docker, so it is not inherently dependent on Docker and Docker alone. What Kubernetes does is it provides a rich and a very flexible and powerful framework for defining applications and orchestrating containers at scale. It is very well designed for key enterprise level tasks such as automated scaling, maintaining high availability, and operating in a multi-platform environment. It also has a large community of users and developers with a corresponding large number of add-ons and support tools. So finally, in the third scenario, what is the best choice? This is a tricky question, and the answer is most obvious, that is, use both. The truth here is that although Kubernetes can use other container sources and runtimes, it is designed to work well with Docker, and much of Kubernetes documentation was very well written with Docker in mind. The most basic Kubernetes use case is Kubernetes plus Docker, and Kubernetes includes Docker-centric tools such as Compose, which converts Docker Compose commands and settings so that can be used by Kubernetes. For its part, Docker has embraced Kubernetes and has in fact offered its very own integrated Kubernetes distribution. So the bottom line is that Kubernetes and Docker are both industry standards in their respective core areas of expertise, and together they provide a well-integrated platform for container management, deployment, and orchestration at scale. It was never really a question of Kubernetes versus Docker. It was always Kubernetes and Docker, and today this is even more true.
Let's start with installation and cluster configuration. Now, for setting up your cluster with Kubernetes, it's going to be really challenging in the beginning because you will have to set up multiple things. You'll have to first bring up your cluster, then you have to set up the storage volume for your cluster, and then you have to set up your environment, and then you have to bring up your dashboard. You have to bring up your pod network, and when you bring up your dashboard, you have to do the cluster role binding and all these things. Okay, and then finally you can get your node to join your cluster. Okay, but with Docker Swarm, it's pretty simple and straightforward. You need to run one command to bring up the cluster and one command at the node end for it to join the cluster, and two simple commands and your cluster is running. You can straight away get started with deploying. Okay, so this is where Kubernetes falls short. It's a little more complicated, but it's worth the effort because the cluster strength that you get with Kubernetes is way more stronger than Docker Swarm. Okay, so when it comes to failover mechanisms and to recovery, in such places, Kubernetes is a little faster. And in fact, Kubernetes will give you more security compared to Docker Swarm because your containers are more likely to fail with Swarm than with Kubernetes. So it's not like I'm saying that your containers will definitely fail, but if at all they fail, then there are more chances of your containers failing at Swarm than with Kubernetes. Okay, so that's about the cluster strength. And if you are really important about your prod environment, and if you have a business which is basically running over these containers, then I would say your preference should be Kubernetes because at the end of the day, business and your containers running in prod are more important. So the cluster is more important, and that's why Kubernetes. Now moving on to the next parameter, we have GUI. Now Kubernetes wins over here also because Kubernetes provides a dashboard over which we can basically control our cluster. Not just control, we can also figure out and get to know what is the status of your cluster and how many pods are running in your cluster, how many deployments are there, how many containers are running, how many services are running, and which are your nodes. You will have all these details in a very simple fashion. Okay, so it's not like you don't get all these things with Docker Swarm. Okay, you get it with Docker Swarm also, but you don't have a GUI over here. There's no dashboard where you can visually see everything. So you can use the CLI with Docker Swarm and you can use the CLI with Kubernetes also. But it's just that Kubernetes provides you a dashboard, which is a little better. And to our eyes, it's a little more easier to understand when you see graphs, when you see your deployments would say your all your deployments are 100% healthy. When you see some things like that, you will relate to it a lot more and you will like it a lot more. So that's this additional functionality which you get with Kubernetes. Okay, so that's where Kubernetes wins over here. And I also want to add another point that with your Kubernetes dashboard, you can easily scale up your containers and you can also control your deployments and make new deployments in a very simple fashion. So even non-technical people can use Kubernetes. Okay, but I mean, if you're a non-technical person, then what are you doing with containers, right? So that's what veterans would say. So seasoned developers would say that, I mean, if you're not technical enough to deal with containers, then you don't deserve to be here. So that is one point which can defend Docker Swarm, but it does not change the fact that Kubernetes makes our life easier. Now moving on to the third one, which is scalability. Both Kubernetes and Docker Swarm are very good for scaling up. Okay, so that is the whole point of these tools. So when we say orchestration, this is the biggest benefit. Okay, Kubernetes can scale up very fast. Swarm can also scale up very fast, but there's a saying that Swarm is 5 times faster than Kubernetes when it comes to scaling up. That is the point. So I think Swarm just nudges Kubernetes over here to victory, right? But yeah, whatever it is, it's scaling up. That's what matters. Since both can do it, well and good. So the next point is auto scaling. Now, if I was a salesman, then I would use this whole point of auto scaling as my sales pitch, because auto scaling is all about intelligence, right? With Kubernetes, Your Kubernetes will always be analyzing your server traffic, and whenever there's a sudden increase in your traffic, your Kubernetes will automatically scale up your number of containers. Okay, and then when the traffic reduces, then automatically your number of containers will also be scaled down. Okay, so there's no manual intervention whatsoever. I don't need to barge in. So if there's a weekend coming up, and if I'm pretty sure that my website is going to get a lot of traffic over the weekend, over the Saturday and Sunday, then I don't have to manually configure my deployments for the weekend. Kubernetes will automatically do that for me. And with Docker Swarm, that is a major drawback, because you cannot do auto scaling. You will have to do it manually. Okay, you can do scaling. It's not that scaling is a big deal, but during emergency situations, it's really important. Okay, Kubernetes will automatically analyze that, okay, you're getting a lot of traffic today, and it will automatically scale it up for you. Okay, but Swarm is a little different. And if there's an emergency, and if your containers are running out of the number of services which they can request, then they cannot do anything. I mean, worst case scenario, they will just die out. Okay, so this is where Kubernetes wins during these emergency situations, because auto scaling is not possible with Docker Swarm. Now, moving on to my next point, which is load balancing. Okay, now with Kubernetes, at times you will have to manually configure these load balancing options. Okay, with Docker Swarm, you don't need to do that because it's automatically done. Now, the reason you should do it with Kubernetes is because in Kubernetes, you will have multiple nodes, and inside each node, you will have multiple pods, right? And inside these pods, you will have many containers. Now, if your service is basically spanning over multiple containers running in different pods, then there's this concept of load balancing, which you have to manually configure, because pods can let all the containers inside them to talk to each other. Okay, but when it comes to managing your load between these pods, that's where the challenge comes, especially when these pods are on different nodes. Okay, so you will face times when you will have to manually configure these load balancing, and you will have small issues. Okay, but it's not that it's going to be major. You can still deal with it. But Swarm wins it because you have no concept of pods over here. You have a Swarm cluster in which there are containers. So these containers can be easily discovered by others. Okay, so they use IP addresses, and they can easily just discover each other, and you're all good. So that's the point. And now coming to the sixth point, which is rolling updates and rollbacks. Let's say that these two are very important aspects, and these are some of the best features of these two tools. Okay, now rolling updates is basically needed for any application. Now, be it a software application which is using Kubernetes or not, whether it's using Docker Swarm or not, any application needs updates. Okay, so rolling updates is really important because any application would need to have updates to it, right? Any software application, any web application, it definitely needs updates to its functionality. Okay, now if your application is basically containerized, then at any point of time, you don't need to bring down your containers and then make the updates. With the help of using these containers, the different containers and these pods can be progressively given the updates. Okay, so in Kubernetes, we have the concept of pods, and inside the pods, we have multiple containers, right? So in Kubernetes, what happens is these rolling updates are gradually sent to each of these pods as a whole. So all the containers inside the pods will be gradually given these rolling updates. Okay, with Docker Swarm, you have the same thing, but it's a little different because you don't have pods. The rolling updates are gradually sent to all the containers one after the other. That's the only difference. Okay, rolling updates are gradually sent to different containers in Kubernetes and in Docker Swarm, but in Kubernetes, it's to all the containers within the same pod. Okay, rolling updates sent one after the other to the different containers in the same pod. That's the point. And when it comes to rollbacks, again, both provide the same thing. Okay, you can roll back your changes. So if your master at any point of time figures out that your rolling update is going to fail, then you have an option of rollback. You actually have the functionality in both Kubernetes and in Docker Swarm. But the point is, there's no automatic rollback. In case of your Kubernetes cluster, if your master finds out that the update is going to fail, then it will automatically roll back to the previously stable condition. But with Swarm, the Swarm manager will not automatically do it. I mean, it provides optionality to roll back, but it's not automatic. That is the only difference between these two. So I think over here also Kubernetes slightly beats Docker Swarm. Okay, just nudges ahead of it. And now coming to the seventh point, which is nothing but data volumes. Now, data volumes is a very key concept because you can have a shared volume space for different containers. Okay, now the conceptual difference between these two is that in Kubernetes, you have multiple pods, and only containers inside that one particular pod can have a shared volume. Okay, and the difference with Docker Swarm is that since there are no pods, pretty much any container can share the shared space with other containers. So that is the only difference. Okay, so I don't think I would go ahead and rate these two. It's just a functionality and a conceptual difference between these two tools. Okay, now moving on to the last point, logging and monitoring. So with Kubernetes, you have inbuilt tools which does the logging for you, and also the monitoring happens. Okay. So there's a particular directory where you can go and you can read your logs and you can find out where your errors are, why your deployment failed, why something happened. You can get all those details because it automatically does the logging. And the monitoring part is used by your master to basically analyze what's your cluster status at all the times, what is the status of all your nodes, what is the status of the different pods in the nodes, are all the containers up and running, are containers responsive. So Kubernetes uses monitoring for all these purposes. Okay, but with Docker Swarm, there's no inbuilt tool, and you have to use third-party tools, something like an ELK, right? So I've done that before, and I've set up ELK to work with my Docker Swarm, and it pretty much does the same thing. Okay, so with ELK, you can collect all the logs, you can figure out where the error is, and even monitoring can be done. But it's just that ELK is again not a very easy tool to set up, and it's that extra step which you have to do with respect to Docker Swarm. Okay, so I think that's pretty much the end of the functionalities and the conceptual differences between these two tools, Kubernetes and Docker Swarm. Now that is the end of the theory part over here. I want to open up a Docker Swarm and Kubernetes and show you a demonstration and give you a feel as to how they work. Okay, so for that, let me open up my VMs where these two are installed. Let me start the demo with Docker Swarm first. So can everybody see my VM over here? So I have two virtual machines. I have a master and I have a slave. But when it comes to Docker Swarm, they are not called master and slave, but they are rather called manager and worker. So my manager is the manager of the cluster, and my worker will be the one that will be executing the services. All right. So like I said, with your Docker Swarm, it's very easy to bring up the cluster. And the command to do that is very simple. You can just specify Docker Swarm init advertise adder and just specify the IP address of your master. Okay. So in my case, my master or my manager's IP address is this one. Okay. So if I just hit enter, then everything's up and ready. I get the joining token, and if I just execute this command at my node end, then my cluster would be ready and I would be joining my cluster. Okay. So I'm going to copy this. Let me go to my worker, and here let me paste this. If I hit enter, then it says that this node has joined the swarm as a worker. Brilliant, right? So that's as quick as it is. And with your master, you got this message saying to add a manager to the swarm, you should use this other command. Okay, but that's only if you want another node to join as a master or as a manager. But otherwise, this command is good enough. So your cluster has been initialized in just a few seconds, right? So it's as simple as that. If you want to deploy an application, you can go ahead and straight away do that. Let me show you a simple application. Let me run a hello world and show you. I can use the command docker service create, and let me give the name as hello world. Okay, and the image to be used is the hello world image. Okay, so I will basically get a container having the name of hello world, and that would be created. And it could be both. It could be running in both the manager and on my node. But if I want one replica of that running in both my manager and my node, then I can set, then there's another flag I can use to set that. Okay, and that is the mode flag. I can say mode is equal to global. So with this, I will have one container running on my manager end and one container in my node. And this is where the difference is with respect to Kubernetes, because in Kubernetes, only your nodes will run the services. Your manager or your master will not execute any service. Okay, it will only manage the whole deployment. Okay, so there was a spelling mistake in my command. So let me just go here and say service. Okay, so let's just wait for a few seconds until my container is up and running. Great. So as you can see, my service has been created, and this is my ID. If I want to verify my cluster state and to check if my service is ready, I can run these commands. I can do a docker node ps. Okay, and this way I'll know how many containers came up and on which nodes they were executed. So it says on my manager there were 4 of these that started. Okay, and of course it's a hello world container, so it's basically shut down immediately. And I can do a docker node ls to identify how many members are there in my cluster. So with this, you can see that there are IDs for 2 different nodes. One is my worker and the other is my manager, right? And that's how simple it is with Docker. But with Kubernetes, it's a little more different. Okay, so I think by now you got a good idea of how simple Docker Swarm is. Okay, and besides, I can also check the service status by running a few commands. right? So I have a Docker service ls. So this would basically list down the containers which are there and the services. Okay, so it says I have a hello world container which is running and it's in replicated mode, and there is one replica of this particular container, right? So I can also check more. I can do a Docker service ps and I can say the name. I can say hello world, and I have details about my container, right? So initially there was one container which started off in my worker, and then it got shut down, and then one more on my worker, and then a couple of them on my manager. So these are the details, and this is how you drill down, right? So you've specified that I need one particular service, that is the hello world service, and I need this many replicas wherein I want them running on my manager and my worker, and then the container has been deployed and it's running, and that's what you can see here, right? So that is about Docker Swarm. And let me bring the VM down and bring up my Kubernetes VMs to show you a demonstration of Kubernetes. Okay. Well, I hope the concept was clear to you, but in case if you have any doubt, then I would request you to go to Edureka's YouTube channel and watch my video on Docker Swarm, where I've shown load balancing between the different nodes, and I've also shown how to ensure high availability. Okay. So in the meanwhile, let me just shut this down. To bring down the cluster, I can basically get my nodes to leave the cluster first and then shut down the cluster itself. So if I want to bring down my cluster, I can do it with a simple command. But before I do that, let me stop the service which I created. Okay, so Docker service rm and hello world was the name. So I'm going to stop the service, and now there are not going to be any replicas of this service or this container. Okay, now let me go back to my node, and here let me leave the cluster, the swarm cluster. Okay, and the simple command for that is Docker swarm leave. So if I hit the command at the node end, then this node will leave the swarm. Okay, so if I run the docker node ls command over here, then the entry for my node would be gone. It would have only one entry, that is my manager. Okay, but anyways, if I want to bring the cluster to an end, then I can get even my manager to leave the cluster, and I can execute the same command for that. I can say Docker swarm leave and everything's back. So yeah, let me use force. Okay, node has left. So that's it with Docker swarm. Okay, let me just close this terminal and go to my next demo. So now let me open up my VMs which have the Kubernetes running. Okay, so this is my Kubernetes master, and this is my Kubernetes node. Okay, now the thing is that I'm not showing you the entire setup over here because it's really complicated. All right, so I don't want to go ahead and execute all the 10-15 commands and show you the entire cluster setup because it's going to take a lot of time to do that. Rather, if you want to know how to do the cluster setup with Kubernetes, then you can go and see the blog which I've written. And also there's another video on how to set up the Kubernetes cluster. All right, so these two would do you of any help, the YouTube video and the blog, and the link to both of them are below in the description. Okay, so let me just straight away get started and tell you what I've already done. If I've wanted to set up the cluster, then there are a lot of things which I should have done. Okay, starting from here. So basically I've started my init command over here. I've specified which pod network I'm using. I'm going to use a Calico pod network. So I've specified that, and I've specified the address where the other nodes have to subscribe. Okay, and then there are various commands which I have to run with respect to setting up the environment. Okay, these, and then I've basically set up the Calico pod over here, and then I've made room for setting up the dashboard, and then I've brought my proxy up. Okay, yeah, and then from the second terminal, I've done a few more things. I've brought up my dashboard account. So I have created a service account for my dashboard, and then I've done the cluster role binding by saying that this dashboard that I'm the admin, and give me the admin privileges. So I've done that here, and then I've basically obtained the key, which is basically the authentication key for accessing the dashboard. So these are the so many other commands which are needed to be executed from the master's end before your node joins. And then after that, I basically went to my node, and then I executed the one command which I was asked to execute. Okay, so this was the join command generated at my master. So I took that and I pasted it here, and then my node successfully has joined the cluster. So this was the entire process, and you can go to my blog and to my videos and go through this whole process. Okay, so I've also brought up the dashboard, right? So let me just straight away go to the dashboard and show you how simple it is, how easy it is to make any deployment, because that is the whole advantage with your dashboard, right? Docker Swarm may be easier. That's what I showed you. With Kubernetes, it's much more better. And this is the Kubernetes dashboard that comes up. It comes up on this port number. All right. And if you want to start your deployment, it's very, very simple. Okay, you can just go to this create button over here, click on create, and then you have option. You can either write your JSON script, or you can upload the JSON file which I've already written, or you can click on this create an app. Over here, it's basically a click functionality. And here you can just put in your app name. So let's say I want to deploy the same hello world app. So I'll just put the hello, I'll give the name over here, hello world. And then the base image which I want to use for this is going to be the hello world image, is going to be present in my Docker Hub registry or the Google registry. So hello world is the image, and let's say I want 3 pods initially. Okay, and let me just straight away click deploy. Okay, and with that your application is deployed. And similarly, if there's anything else you want to containerize, it's as simple. If it's going to be an NGinx server or a Tomcat or an Apache server which you want to deploy, you can just choose the base image and hit on the deploy button, and yes, it's straight away deployed. And you'll get something like this which would show what is the overview and what is the status of your cluster. Okay, as you can see, my deployments, my pods and replica sets, everything is healthy, 100%. Right, so this is my deployments. So it says that 2 out of 3 pods are running. So let's just give it a few minutes, and then all the 3 pods will be up and running. Okay, you got to give it a few seconds because it's just 19 seconds old. And yeah, these are the 3 pods. The third one is coming up. Okay, because yeah, it says terminated because the hello world container, it's a self-destruct container, right? It prints hello world and it exits. That's what happens here. Same thing with replica sets. I've mentioned 2 out of 3 pods, which means that at all times there will be 3 pods running, and my replica sets and replication controller is the one that will control this aspect. Okay, so yeah, that is pretty much it, and that's how easy and simple it is to work with Kubernetes. Right, so you can have your own opinion. You can choose whether you want to use Kubernetes, or you can choose if you want to use Docker Swarm. Okay, so my take on this is, if you have a very simple application, then you would rather be better off with Docker Swarm. Okay, and also if you have very few clusters which you are dealing with. But if you're dealing with a real prod environment, then I would say Kubernetes is a better option. And also when the containers are many in number, when you have a lot of containers, then it's easier to work with Kubernetes. You can just specify the configurations. You can say that I need these many containers running at all the times. I need these many nodes which are connected to my cluster, and I will have these many pods running in these nodes. And whatever you say, that will be followed by your Kubernetes.
Well, the major differences come with operating support, security, portability, and performance. So let's discuss each one of these terms one by one, and let's know the differences between both of them. So let's start with the operating system support. The basic architecture of Docker containers and virtual machines differ in their operating system supports. Containers are hosted in a single physical server with the host operating system, which is shared among them. But the virtual machines, on the other hand, have a host operating system and an individual guest operating system inside each virtual machine. Irrespective of the host operating system, the guest operating system can be anything, like it can be Linux, Windows, or any other operating system. Now, the Docker containers are suited for situations where you want to run multiple applications over a single operating system kernel. But if you have applications or servers that need to run on different operating system flavors, then virtual machines are required. Sharing the host operating system between the containers makes them very light and helps them to boot up in just a few seconds. Hence, the overhead to manage the container system is very low compared to that of virtual machines. Now, let's move on to the second difference, that is security. In Docker, since the host kernel is shared among the containers, the container technology has access to the kernel subsystems, as a result of which a single vulnerable application can hack the entire host server. Providing root access to the applications and running them with a super user privileges is therefore not recommended in Docker containers because of these security issues. On the other hand, virtual machines are unique instances with their own kernel and security features. They can therefore run applications that need more privilege and security. Now, moving on to the third difference, that is portability. Docker containers are self-contained packages that can run the required application. Since they do not have a separate guest operating system, they can be easily ported across different platforms. The containers can be started and stopped in a matter of few seconds compared to that of VMs due to their lightweight architecture. This makes it easy to deploy Docker containers quickly in servers. On the other hand, virtual machines are isolated server instances with their own operating system. They cannot be ported across multiple platforms without incurring compatibility issues. For development purposes, where the applications have to be developed and tested in different platforms, Docker containers are the ideal choice. Now, let's move on to the final difference, that is performance. Docker and virtual machines are intended for different purposes, so it's not fair to measure their performance equally. But the lightweight architecture makes Docker containers less resource intensive than the virtual machines, as a result of which containers can start up very fast compared to that of virtual machines, and also the resource usage varies among the two. In containers, the resource usage such as CPU, memory, input, output varies with the load or traffic in it. Unlike the case of virtual machines, there is no need to allocate resources permanently to containers. Scaling up and duplicating the containers is also an easy task compared to that of virtual machines, as there is no need to install an operating system in them. So now that I've told you the differences between Docker containers and virtual machines, let me show you a real life case study of how Docker containers and virtual machines can complement each other. So all of us know PayPal, right? So PayPal provides online payment solutions through their account balances, bank accounts, credit cards, or promotional financing without sharing the financial information. Today, PayPal is leveraging OpenStack for their private clouds and runs more than 1 lakh virtual machines. Now, one of the biggest desires of PayPal's business was to modernize their data center infrastructures, making it more on demand, improving its security, meeting compliance regulations, and also making everything cost efficient. So, they wanted to refactor their existing Java and C++ legacy applications by Dockerizing them and deploying them as containers. This called for a technology that provides a distributed application deployment architecture and can manage workloads, but must also be deployed in both private and public cloud environments. So, PayPal uses Docker commercial solutions to enable them to not only provide gains for the developers in terms of productivity and agility, but also for the infrastructure teams in the form of cost efficiency and enterprise grade security. The tools being used in production today include Docker commercially supported engines, Docker Trusted Registry, and as well as Docker Compose. The company believes that containers and virtual machines can coexist, and thus they combine these two technologies. Leveraging Docker containers and virtual machines together gave PayPal the ability to run more applications while reducing the number of total virtual machines and also optimizing their infrastructure. This also allowed PayPal to spin up new applications much more quickly and also on as needed basis. Since containers are more lightweight and instantiate in a fraction of a second, while virtual machines take minutes, they can roll out a new application instance quickly, patch up an existing application, or even add the capacity to compensate for peak times within the year. So this helped PayPal to drive innovation and also outpace the competitions. So guys, that's how the company gained the ability to scale quickly and deploy faster with the help of Docker containers and virtual machines.
Let us begin with the first category of questions, that is the beginner's questions. This category of Docker interview questions consists of questions that you are expected to know. These are the most basic level questions. An interviewer will start with these and eventually he will increase the difficulty of the questions. So let us begin with our first question. And the first question here is, what is hypervisor? A hypervisor is a software that makes virtualization possible. It is also called virtual machine monitor. It divides the host system and allocates the resources to each of the divided virtual environment. You can basically have multiple operating systems on a single host system. So basically there are two types of hypervisors. The first one is the type 1 hypervisor. It is also called the native hypervisor or bare metal hypervisor. It runs directly on the underlying host system. It has direct access to your host's system hardware and hence does not require a base server operating system. And the second type of hypervisor is the type 2 hypervisor. This kind of hypervisor makes the use of underlying host operating system, and it is also known as the hosted hypervisor. So let's move to the next question. And the next question here is, what is virtualization? So virtualization is the process of creating a software-based virtual version of something, be it compute storage, servers, application, etc. These virtual versions or environments are created from a single physical hardware system. Virtualization lets you split one system into many different sections which act like separate, distinct individual systems. A software called hypervisor makes this kind of splitting possible. The virtual environment created by the hypervisor is called a virtual machine. The next question here is, what is containerization? So let me explain this with an example. Usually in the software development process, code developed on one machine might not work perfectly fine on any other machine because of the dependencies. This problem was solved by the containerization concept. So basically, an application that is being developed and deployed is bundled and wrapped together with all its configuration files and dependencies. So this bundle is called a container. Now, when you wish to run the application on another system, the container is deployed, which will give a bug-free environment as all the dependencies and libraries are wrapped together. Most famous containerization environments include Docker and Kubernetes. So the next question here is, what is the difference between virtualization and containerization? You guys can have a look at the diagram that is present on your screen right now. Containers provide an isolated environment for running the application. The entire user space is explicitly dedicated to the application. Any changes made inside the container is never reflected on the host or even other containers running on the same host. Containers are nothing but an abstraction of the application layer, and each container is a different application. So this was the concept of containerization. Whereas in virtualization, hypervisors provide an entire virtual machine to the guest, which includes the kernel as well. Virtual machines are an abstraction of the hardware layer, and each virtual machine is a physical machine. So these were the differences between virtual machines and containers, or you can say virtualization and containerization. So the next question, and pretty obvious question, is what is Docker? Docker is a containerization platform which packages your application and all its dependencies together in the form of containers so as to ensure that your application works seamlessly in any environment, be it development, testing, or production. Docker containers wrap a piece of software in a complete file system that contains everything needed to run. That is code, runtime environment, system tools, system libraries, etc. It wraps basically anything that can be installed on a server. This guarantees that the software will always run the same regardless of the environment. So the next question here is, what is a Docker container? Docker containers include the application and all of its dependencies. It shares the kernel with other containers running as isolated processes in user space on the host operating system. Docker containers are not tied to any specific infrastructure. They run on any computer, on any infrastructure, and in any cloud. Docker containers are basically runtime instances of Docker images. And once you mention the concept of Docker image here, the next obvious question will be, what are Docker images? So as you can see on the screen, this is basically the entire process of Docker. So first you have a Docker file, you write a Docker file, and once you write a Docker file, you build it, and which leads to the formation of Docker image. And once you have a Docker image, when you run that image, you have a Docker container. So Docker image is the source of Docker container. In other words, Docker images are used to create containers. When a user runs a Docker image, an instance of a container is created. These Docker images can be deployed to any Docker environment. So the next question here is, what is Docker Hub? So Docker images create Docker containers. So as we saw in the previous question, there has to be a registry where these Docker images live. This registry is known as Docker Hub. So users can pick up images from the Docker Hub and use them to create customized images and containers. Currently, the Docker Hub is the world's largest public repository of image containers. So the next question here is, explain Docker architecture. So you can refer to the diagram that is present on your screen right now. So Docker architecture basically consists of a Docker engine, which is a client-server application with three major components. The first one is a server, which is a type of long-running program called a daemon process. The second component is a REST API, which specifies interfaces that programs can use to talk to the daemon and instruct it what to do. The third component here is the CLI, that is command line interface or the client. And the fourth thing here is the CLI uses the Docker REST API to control or interact with the Docker daemon through scripting or direct CLI commands. Many other Docker applications use the underlying API and the CLI. So these were the important components of Docker architecture that you can answer when you face such a question in your interviews. So the next question here is, what is a Docker file? Docker can build images automatically by reading the instructions from a file called the Dockerfile. A Dockerfile is a text document that contains all the commands a user could call on the command line to assemble an image. Using Docker build, users can create an automated build that executes several command line instructions in the succession. So the next question here is, tell us something about Docker Compose. A Docker Compose is a YAML file which contains details about the services, networks, and volumes for setting up the Docker application. So you can use Docker Compose to create separate containers, host them, and get them to communicate with each other. Each container will expose a port for communicating with the other container. Moving on to the next question. So the next question is, what is Docker Swarm? Docker Swarm is a native clustering for Docker. It turns a pool of Docker hosts into a single virtual Docker host. Docker Swarm serves the standard Docker API. Any tool that already communicates with a Docker daemon can use Swarm to transparently scale to multiple hosts. The next question here is, what is a Docker namespace? A namespace is one of the Linux features and an important concept of containers. Namespace adds a layer of isolation in containers. Docker provides various namespaces in order to stay portable and not affect the underlying host system. So few of the namespace types that are supported by Docker are PID, mount, IPC, user, network, etc. So the next question is, what is the lifecycle of a Docker container? So guys, for this question, you can refer to the diagram that is present on your screen right now. So this is one of the most popular interview questions, and a Docker container can have the following lifecycle. As you can see on the screen, the first lifecycle phase is that of create. So first you create a container and then you run the container. After these operations or the phases, what you can do is you can pause and unpause the container depending upon your requirement or the application that you're trying to run on. And after that, you stop the container, and also you can restart the container. And once you're done by using containers, after that, you can kill the container and then destroy it. So these were the lifecycle phases of a Docker container. So the next question is, what is Docker Machine? Docker Machine is a tool that lets you install Docker Engine on virtual hosts. These hosts can now be managed using the Docker Machine commands. Docker Machine also lets you provision Docker Swarm clusters. So with this, we have covered the most basic Docker interview questions, like the beginner interview questions. And now we will move to the intermediate level of questions. So basically, this set of questions is related to Docker commands. So the interviewer will obviously try to know whether you have hands-on experience using Docker or not. So let us move to the next question. So the next question here is how to check for the Docker client and the server version. So as you can see on the screen, the command for that is very simple. You simply have to type Docker version in your terminal. So let me just quickly show you. So let me just log into my CentOS. So as you can see here, I have opened the terminal, and now you have to type the command Docker version. So as you can see here, you have the details of the client and the server here. So the client version here is 1.13.1 and the server version is also 1.13.1. And you have other details as well, such as the API version, package version. And here also you have API version, package version, build, okay, and the other things. So this was one very simple command here. Let's move on to the next question now. So the next question here is, how do you get the number of containers running, paused, and stopped? As you can see on the screen, the command for that is very simple. You simply have to type Docker info in your terminal. So let me just quickly show you that command, Docker info. So as you can see here, once you run this command, so here you can see the number of containers. We have 16, out of which none of them is running, none of them is paused, and all are stopped. So apart from the containers, we also have images. We have 13 images right now. So this was one very simple command to know the status of the containers. Okay, so let's move on to the next question. So the next question here is, if you vaguely remember the command and you'd like to confirm it, how will you get help on that particular command? So the command for this is very simple, as you can see on the screen, docker -help. So let me just show you how do you do that. So before that, let me just clear the terminal here. So let me just quickly type the command here, docker -. So once you type this command, these are the commands that you can use with Docker: attach, build, commit, cp. As you can see, this is a long list here. So the docker -help command will help you on using a particular command. So say for example, this is the list of commands here, as you can see. And so say for example, this is the command that you wish to know more about, run command. So for that, what you need to do is you have to type docker, the command name, and -help. Okay. So as you can see here, you can get more information about the usage of this command, docker run, the options, the image, command, and arguments. So this is the description of the command here. And these are the options here that you can use with the run command. So this was the usage of the help command here. So let me just clear the terminal here. So let's move on to the next question here. So the next question here is how to log in into a Docker repository. So as you can see on the screen, the command for that is very simple. So let me just show you how to use that command here. So the command for that is very simple here, docker login. So here it says login with your Docker ID to push and pull images from Docker Hub. If you don't have a Docker ID, head over to this website here, the URL that is specified here, and you have to sign up on this Docker Hub website. So I've already signed up on that website, and let me just enter my username here, Arvind P 111. So after that, you have to enter your password. So once you do that, you will see a message here, login succeeded. Okay, so let's move on to the next question, guys. If you wish to use a base image and make modifications or personalize it, how do you do that? Okay, so again, as you can see on the screen, the command for that is very simple. You simply have to use this command, docker pull, and the name of the image. So to get the list of images that you can pull, you can go to the Docker Hub website. So this is the website here, hub.docker.com. So once you do that, as you can see here, official images, you can pull any image that you want. So as you can see here, MongoDB, NodeJs, Redis, these are the images that you can pull here. So say for example, you have to pull an image called Postgres. So this is basically a database here, and command for that is very simple. As you can see on the screen, docker pull Postgres. So as you can see here, Docker is pulling that image from the Docker Hub, and this might take a few seconds. Okay. As you can see here, Docker is extracting the images related to Postgres. So as you can see here, the image has been pulled. So let's move on to the next question. How do you create a Docker container from an image? So as you can see on the screen, the command for that is very simple, docker run -it space -d and the name of the image. So let me just quickly show you. Before that, let me just clear the terminal here. So docker run -it -d and the name of the image. So we just pulled an image called Postgres. So let me just run this command here. So the next question here is, how do you list all the running containers? So as you can see on the screen, the command for that is simple as well, docker space ps. So before that, let me just clear the terminal here. So docker space ps. So as you can see here, none of the containers are running at the moment. So that is why all of these fields are blank. So let's move on to the next question. So the next question here is, how do you access a running container? So as you can see, the command for that is very simple: docker exec -it, the container ID, and the bash command. So let me just quickly show you how do you run this command. So to get container IDs, let me just use the command docker ps. So this command will show you all the running containers. So as you can see here, this container called Ubuntu is currently running, and this is the container ID of this. Let me just copy it. So let me just type this command here, like we saw, docker exec -it, the container ID that we just copied here. Let me just paste it here, and bash. So as you can see here, right now I am inside that container and I can do whatever operations that I want. So this is how you access a container. So let's just move on to the next question here. So how to start, stop, and kill a container? So as you can see on the screen, these are the simple commands to do that: docker start and the container ID. Similarly, docker stop and the container ID, and docker kill space the container ID. So let me just quickly show you. So since this container Ubuntu is already running, so let me just stop it. Okay, so let me just clear the terminal first. So let me just stop this container that we started in the previous command, docker stop and the container ID. Okay, so let me just clear the terminal here. Okay, so as you can see here, we are already in the Ubuntu container here. So let me just exit this container here. Okay, so first we will have a look at all the running containers here using the command docker to see a list of all the running containers. So as you can see here, only this container is running here, Ubuntu. So let me just stop this, docker stop. This is the command here and the container ID. So this has been stopped, and let's just verify this. So as you can see here, none of the containers is running right now. So similarly, you can use the command docker start to start a container and docker kill to kill a container. So let's just move on to the next question here. So can you use a container, edit it, and update it? Of course, this can be easily done using the command, as you can see on the screen, docker commit, the container ID, and after that, the username and image name. So this was one very simple command to do this. So let me just quickly show you. Let me just clear the terminal here first. So the command for that is docker commit the container ID. This is the container ID of Ubuntu, and space the image name, Ubuntu. So as you can see here, docker commit container ID, and either you can type your image name here or the username here. Okay. So once you do that, this will give you one SHA key. Okay. So the next question is, once you have worked with an image, how do you push it to the Docker hub? So the command for that is very simple, as you can see on the screen, docker push the username or the image name here. Okay. Let's just move on to the next question here. How to delete a stopped container? So as we saw previously, the command for stopping a container is docker stop and the container ID. And once you stop a container, if you want to delete it, you can use the following command, as you can see on the screen, docker rm and the container ID. So the next question here is how to delete an image from the local storage system. So similar to rm, the command for this is docker rmi and the image ID. The next question here is how to build a Docker file. So once you have written a Docker file, you need to build it to create an image with the required specifications. So as you can see, the command for that is very simple, docker space build and the path to the Docker file where you have stored the Docker file. So that path you have to specify here. So the next question here is, do you know why docker system prune command is used? And what is the usage of that command? So the command, as you can see on the screen, is very simple, docker system prune. And this command is used to remove all the stopped containers, all the networks that are not used, all the dangling images, and all built caches. And this is one of the most useful commands in Docker. So with this, we have come to the end of the intermediate level of questions, which were basically related to the Docker commands. So now let's just move on to the advanced level of questions. So once the interviewer knows that you're familiar with Docker commands, he or she will start asking you the practical applications of Docker. So basically, this set of questions will cover the practical application aspect of Docker. So the next question here is, will you lose your data when a Docker container exits? So the answer for this question is no. You won't lose any data when Docker container exits. Any data that your application writes to the container gets preserved on the disk until you explicitly delete the container. The file system for the container persists even after the container halts. So the next question is, where all do you think Docker is being used? So this question talks about the application of Docker. So as you can see on the screen, these are some of the applications of Docker. So the first one here is for simplifying the configuration. So Docker lets you put your environment and configuration into code and deploy it. If you talk about the next application, that is code pipeline management, there are different systems used for development and production. As the code travels from the development to testing to production, it goes through a difference in the environment. So Docker helps in maintaining the code pipeline consistency. The next point here is the developer productivity. Using Docker for development gives us two things. We are closer to the production and the development environment is built faster. So the next point here is the application isolation. As containers are applications wrapped together with all the dependencies, your apps are isolated. They can work by themselves on any hardware that supports Docker. So the next point here is the debugging capabilities. Docker supports various debugging tools that are not specific to containers but work well with the containers. And the next point here is the multi-tenancy. Docker lets you have multi-tenant applications, avoiding redundancy in your codes and deployments. And the last application here is the rapid deployment. Docker eliminates the need to boost an entire operating system from scratch, thereby reducing the deployment time. So these are some of the applications of using Docker. So the next question here is, how is Docker different from other containerization tools or methods? So Docker containers are very easy to deploy in any cloud platform. It can get more applications running on the same hardware when compared to other technologies. It makes it easy for the developers to quickly create ready-to-run containerized applications, and it makes managing and deploying applications much easier. Using Docker, you can even share your containers with your applications. So let's just move on to the next question. Can I use JSON instead of YAML for my compose file in Docker? So the answer to this question is yes. You can use JSON instead of YAML for your compose file. So the next question is, how have you used Docker in your previous position or your previous experience? So in this question, you have to explain how you have used Docker to help rapid deployment. Here you can also explain how you have scripted Docker and used it with other tools such as Puppet, Chef, or Jenkins. If you have no past practical experience in Docker and instead have experience with other tools in a similar space, be honest with the interviewer here and explain the same thing. In this case, it makes sense if you can compare Docker with other tools in terms of functionality. So let's just move on to the next question here. How far do Docker containers can scale? Are there any specific requirements for the same? So large web deployments like Google and Twitter and platform providers such as Heroku and .cloud all run on container technology. Containers can be scaled out to hundreds of thousands or even millions of them running in parallel. Talking about the requirements, containers require the memory and the OS at all the times and a way to use this memory efficiently when scaled. So the next question here is, what platforms does Docker run on? So this is a very straightforward question, but it can be tricky at times. Before answering such questions, you have to do some company research before appearing for such interviews. And you have to mention the various platforms that Docker runs on. So if you talk about the Linux platforms, so Docker runs on Ubuntu, Fedora, Red Hat, CentOS, Arch Linux, Crux, and so on. It can also be used in production with cloud platforms with services such as Amazon EC2, Amazon ECS, Google Compute Engine, Microsoft Azure, Rackspace, and so on. So the next question here is there a way to identify the status of a Docker container? So there are 6 possible states a container can be at any given point of time, such as created, running, paused, restart, exited, and dead. So as we saw previously, the command for this is docker space ps. This command lists down only the running containers by default. And if you want to have a look at all of the containers, then the command for that is docker space ps -a. So the next question here is, can you remove a paused container from Docker? The answer for this question is no, you cannot remove a paused container. The container has to be in the stopped state before it can be removed. The next question is, can a container restart by itself? The answer to this question is also no. It is not possible for a container to restart by itself. By default, the restart flag is set to false. So the next question here is it better to directly remove the container using the rm command or stop the container followed by the remove container? So it is always better to stop the container and then remove it using the remove command. So as you have seen previously, the command to stop the container is very simple. Docker stop the container ID. And after that, if you want to remove the container, the command for that is, as you can see on the screen, docker rm-f space the container ID. So stopping the container and then removing it will allow sending SIG-HUP signal to the recipients. So this will ensure that all the containers have enough time to clean up their tasks. This method is considered a good practice and it also avoids any unwanted errors. So the next question is, will cloud overtake the use of containerization? So Docker containers are gaining popularity, but at the same time, cloud services are also giving it a tough fight. In my personal opinion, Docker will never be replaced by cloud. Using cloud services with containerization will definitely hype up the game. Organizations need to take their requirements and dependencies into consideration and then decide what is best for them. Most of the companies have integrated Docker with cloud. Using this way, they can make the best out of both of the technologies. So the next question here is, how many containers can run per host? So there can be as many containers as you wish per host. Docker does not put any restrictions on it, but you need to consider every container needs a storage space, CPU and memory, which the hardware needs to support. You also need to consider the application size. Containers are considered to be lightweight but very dependent on the host operating system. The next question here is it a good practice to run stateful applications on Docker? The concept behind stateful applications is that they store their data onto the local file system. You need to decide to move the application to another machine. Retrieving data becomes painful, and I honestly would not prefer running a stateful application on Docker. Let's just move on to the next question here. So the next question here is a scenario-based question. So suppose you have an application that has many dependent services. So in this case, will Docker Compose wait for the next container to be ready to move to the running of next service? So the answer to this question is yes. Docker Compose always runs in the dependency order. So these dependencies are specifications like depends on, links, volumes from, etc. So the next question is, how will you monitor Docker in production? Docker provides functionalities like Docker stats and Docker events to monitor the Docker in production. Docker stats provides CPU and memory usage of the container. Docker events provide information about the activities taking place in the Docker daemon. So the next question here is it a good practice to run Docker Compose in production? So the answer to this question is yes. Using Docker Compose in production is the best practical application of Docker Compose. When you define applications with Compose, you can use this Compose definition in various production stages like CI, staging, testing, etc. The next question here is, what changes are expected in your Docker Compose file while moving it to the production? So as you can see, these are the changes that you need to make into your Compose file before migrating your application to the production environment. The first change is remove volume bindings so that the code stays inside the container and cannot be changed from outside the container. Next, the binding to different ports on the host needs to be done. After that, you have to specify a restart policy. And finally, you have to add extra services like the log aggregator. So the next question here is, have you ever used Kubernetes? If you have, which one would you prefer amongst Docker and Kubernetes? So guys, it is expected to be very honest in such questions. If you have used Kubernetes, talk about your experience, Kubernetes and Docker Swarm. Point out the key areas where you thought Docker Swarm was more efficient and vice versa. So this question totally depends upon your experience. And the last question here is, Are you aware of load balancing across containers and hosts? If yes, how does it work? While using Docker service with multiple containers across different hosts, you come across the need to load balance the incoming traffic. Load balancing and HA proxy is basically used to balance the incoming traffic across different available and healthy containers. If one container crashes, another container should automatically start running and the traffic should be rerouted to this new running container. Load balancing and HA proxy works around this entire concept. So with this, we have come to the end of this session. So I hope you have enjoyed this session. So that was all from me in this session. Thank you so much.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!